तुला बघू देतो म्हणजे घरी बघितले नाही तर चालू तुमचा फोटो व्हिडिओ ऑन कर.
हेलो किससे
अभिजीत के साथ उसका कॉलेज चल रहा
नहीं
है.
सुनो मौले का शुरू करना वो वेट कर रहे उधर मौले का शुरू करना
काय तुला व्हिडिओ नाही दिसला मला इकडे काही. दिसली
सर।
व्हाट्सअप सर।
हाँ हाँ जी हाँ जी ओके सर।
मीटिंग मध्ये कोणी नाही येणार.
हेलो यस सर यस गुड मॉर्निंग सर.
आलो सर.
ओके
अरे Q&A ऑटोमॅटिक रिफ्रेश होतं ना.
नाही आपण करावं लागतं.
No sir, you can join at 10 o'clock in Hall C sir. Yes 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 sir yes yes.
इतक्या लवकर ओपन करून काय ठेवलं आपण?
Yes yes of course sir of course.
रेकॉर्डिंग चालू करायची.
हो मी परत बंद करून परत सुरू करू शकतो.
No sir, Zoom link you can do yourself to meet and mute sir. We will make you co-host. You can do from your side also.
लगेच वेळ.
Thank you. Thank you Abhi.
त्यामुळे विजय ना थोडा.
क्या हो गया इनको चालू क्यों नहीं कर रहे?
Very good morning, sir. We will start the session by 10 a.m.
Yeah, okay. Good morning, Professor. Good morning, Professor Brijesh Srivastav ji. Can you hear me? Sir, you are muted. Please unmute. Sir, please unmute.
Yeah.
Ah,
Good morning, sir.
good morning. Good morning. How are you, sir?
I'm fine, sir.
Okay. So today in the morning session, you are co-chair.
Yes, sir.
Okay.
Just I'm adjusting the camera so that it will be perfect. It should be perfect.
Yeah.
Good morning, sir. Now my voice is clear, sir.
Yes, very much audible.
Okay. So
My voice is audible?
yes, sir. Yes, sir. Now I will download the resumes that they have provided.
Yeah, we have to read. Yeah. I have taken printout.
They have not provided very good information, sir. So this is the
Yeah.
and sir, only 3 speakers are there. Only B and B2 are chairs, co-chair, and one extra.
One, Mahendran is there.
Huh?
Mahendran from Tanjavur.
Whether-
He does very good work in this area, cold plasma for
Yeah.
various applications in food processing and agriculture.
Yes, sir.
And
I also
he is
having
dynamic.
doing that. I am also in that area. I am also having that equipment with me. Okay, sir.
Basically, sir, I am a physics person.
Okay. I think you are working with Professor Annapurna, sir.
Yes, correct. And I have been working in the area of plasma surface modification of materials, particularly polymers and textiles.
Yes,
Okay,
sir.
and nanomaterials.
Yes,
And
sir.
then, eventually I joined hands with Professor Annapure and started working in the area of food processing.
Yes,
But
sir.
the only plasma part is looked by me, and the remaining characterization related
Yeah.
is looked by Professor Annapure. So basically, I am a physicist and know more about plasma rather than the food chemistry.
I agree,
Because
sir.
that part is looked by Annapure, sir.
Okay, sir.
So in my talk, I will be giving more emphasis on about the plasma.
That is good,
and
sir.
highlight applications of plasma in food processing. Whereas your talk and Mahendran's talk will be more detail on
food processing, sir.
from food processing point of view.
They could have kept some oral presentation in between this, sir.
No, morning this invited talks are there, right?
No, sir. In our session, only 3 presentation is there. V2 and one more. That was mostly invitee presentation is there.
And
no.
three parallel tracks are there, right?
Yes, sir.
Okay.
Maybe the number of participants may be not that much actually.
Correct. You are from Tejpur University, right?
Yes, sir. I am from Tejpur University. It's a central university, sir. And
I have developed the reactors which are required. Okay, are designed and developed by me only.
yes, sir. Very good, sir. Actually, sir, we are not expert in this your power supply and all these things. However, the person I have got to make this power supply is from Bangalore, so they give the knowledge. But
Who? Suresh. You
no,
have
no, sir. He is one company is there. They are producing instrument for the military.
battery.
So they are dealing with the high power.
But are they supply RF power supplies also? Radio frequency power supply
Sir,
RF?
you may once I will give you. They are supplying something RF frequency. I think they are doing the on antenna. Sir, they are a big manufacturer. They are manufacturing the equipment for this Air Force and yeah, military.
Oh, that's nice. Sir,
So,
maybe can you share, just tell me your
yeah,
mobile number so that
I will
I'll
share
write
to
down.
you. I will share to you. Sir, yeah, Geonic system is there. I will share the detailed information to you, or if I will get your email, I will share
Yeah,
your.
even if you just tell me here also, nobody is there in the room. Okay,
No,
your
sir, you
mobile
can,
number
sir.
I will
No,
write
sir,
down.
I can. You have to write. I will give it Geonic system, Bangalore, sir. Geonics, ZE, Geonic system from Bangalore, sir.
Okay.
In yeah, Solapur, his person is he is everything. He is their whole family is involved. The Mr. Solapur is there.
Okay.
In Solapur. So so they are doing this. They are involved in manufacturing the equipment for the Air Force and military. So once I visited their plant also. So they give the power supply. So they also, the person concerned is highly enthusiastic, and he is a person, but highly enthusiastic to work upon this. So he developed the power supply. Then rest of the design part, how our requirement I told to him,
Right.
they made that system in that way. Okay, sometime we will get opportunity, then I will collaborate with you, sir, for this purpose. And then sometime we get opportunity to call you to see our system here, sir.
No problem.
Okay. So, once we can try our slides, sir.
Yeah, we can try. Okay, just a minute.
Sir, I am trying, sir.
Yes, sir. I can see your slides.
Okay.
Yeah. Now you have to,
it is not.
Then only I can be able to,
Now it is okay, sir.
Yeah, I can see that.
Now this everything I can check, sir. Pointer option.
Yeah.
It is there, sir. No?
Yeah, pointer is there. Yes. Sir, we have 20 minutes, right?
Yes, sir. 20 minutes.
Maybe I also have around 40 slides. So half a minute per slide.
No problem, sir. You
And I will be skipping,
only sir, we three are presenting, sir. No
and I will be skipping few slides or going little fast through few slides. So maybe I should be
You
able
can
to
also
manage
test
that.
your, you can also test your,
Yeah. Yes, yes. Can you see my slide?
it's coming, sir. Yes, sir, it can. So convert to the presentation mode, sir.
Converted.
Yeah, no, it's okay, sir. Just move one or two, sir.
And yeah, laser pointer is there.
Yes, yes, sir. Sir, move one or two, sir, slides, sir.
Okay.
Yeah, it's moving, sir. It's moving, sir. It's
Moving, na?
moving, sir. Yes, sir.
Okay.
Okay, sir.
No problem, sir.
Now you can, yeah, you can
Now
start.
I will stop sharing.
Stop sharing, yes, sir.
Okay. Remove.
Yeah. Now Dr. Mahendran will is come. It is around 15 minutes is there. Sufficient time is there.
Yes, sir.
So we will join, sir, at 10:50, 9:55, sir, now.
Yeah. I just keep logged in. Okay. I will not be just okay. And then
Okay.
Good morning,
sir.
Dr.
Good morning, sir. How are you, sir?
Yeah, I am fine. How are you doing?
I am good, sir. Good, sir.
Okay, very nice.
Yes, sir.
Another speaker, Professor Brijesh Srivastava has also joined.
Yes, sir.
Good morning, sir.
Good morning,
Yeah.
sir.
So how are you?
Hello, Professor Brijesh Srivastav.
Hello, sir. Yes, sir.
Yeah,
Time is started, sir.
yeah. So any,
I think now we can start, sir.
yeah, I think we should now,
Okay,
because
sir.
otherwise we will be lagging behind.
Yes, sir. Yes, sir. Yes, sir.
Yeah. Somebody has joined with ICFOST 2022. Who is the host there?
Maybe some organizer team, maybe the first 2020 Hall B, na, you are talking?
Hall B host.
Only, sir, just see only 3, we 4 are there. 3 are there.
Yeah, can't help. Yeah, okay. Host, can we start?
Yes, sir. Yes, sir. Time is there.
Okay.
So we can.
Yeah.
Yeah, we can. They are also organizers are also telling to start the session, sir.
Okay, no problem then. Let us start.
Okay, so now, so with due the permission to the chair, may I start the session, sir?
Yes, sir.
Okay. Good morning to the our today's session chair, Dr. R.R.
Deshmukh.
Sorry, R.R. Deshmukh, sir, and the audience of ICFOST participant of ICFOST 2020 and other distinguished guests. Today, I welcome our today's session chair, Professor R.R. Deshmukh. The Dr. Deshmukh is currently working as a professor in the Department of Physics in ICT Mumbai, and he is also working as a registrar of same institute. Dr. Deshmukh has awarded his postdoctoral fellowship from University of Texas during 2009 and 10. He is having around more than 25 years of experience in teaching and research. He has worked as a Senate and Academic Council member, Board of Studies in Physics of 7 universities, Fellows, and Maharashtra Academy of Science, Fellows, Indian Chemical Society. He is also recipient of Professor M.M. Sharma Award for contribution in the field of science and technology. He has also delivered many talks in national and international conferences, and he has published more than 125 publications and 10 book chapters. And he is having 1 patent granted in his credit, and he has guided 7 PhD and 4 masters. And his area of specialization is plasma processing of polymers and textiles, non-thermal plasma processing of foods, functionalization of materials, polymer, dispersed liquid crystals, application of plasma in biomedical field, polymer, composites, conducting polymers, gas sensor, etc. So, and now the today's other presentation is from Dr. R. Mahendran from NIFTM Tanjore. So with this, I will request our session chair to start, take the control of the session and start the session, sir.
Yeah. Thank you, Professor Brijesh Srivastav, for kind introduction and starting the session. And as per the schedule, first talk is mine only. So I will share without wasting time. I will share my slides with the audience.
You're welcome, sir. Sure, sir.
Can you see slide?
Yes, sir. It is coming, sir. Yes, sir.
Yeah. So today I will be talking about plasma, the fourth state of matter, and its applications in food and agricultural industry. More emphasis will be given on generation of plasma, types of plasma, and all those things. And I will be touching upon its applications in food processing industry. The reason is the next 2 speakers will be giving more emphasis on application part. So I will be delivering my talk more on the fundamentals of plasma rather than the applications, though some applications will be covered. I am professor of physics and not a food technologist, but this work was carried out in collaboration with Professor Uday Annapure in ICT. So plasma is the fourth state of matter. We know solid, liquid, and gases as the three states of matter. The distinctive feature in these states of matter is that solid atoms or molecules, they have a fixed position in the material. At the most they can vibrate about their main position when energy is given, whereas liquid molecules enjoy a little more freedom. They can move in the container because they have more energy as compared to solid molecule. Further, if this liquid is heated, we get vapor. A simple example, in all states you can see ice as a solid, then water vapors, and then we can, so water vapor molecules or gas molecules enjoy much more freedom as compared to the previous two states of matter, and they have a lot of energy. And further, if we give energy in the form of heat or electric field, these gaseous atom will acquire energy. The electrons will go to the excited state, and then they can be liberated from the binding forces of atom. So then you have a free electron and ion remaining in it. So it's basically the charged particles, positive ion and negative electron. Then with the under the influence of very high electric field, they attain high kinetic energy, and then these charged particles then collide with the neutral atoms or molecules, okay, in the gaseous form, and there will be inelastic collision, so that the energy is transferred to other neutrals and they are also ionized. So in short, then we get a fully ionized gas. So then ionized gas cannot be covered under the laws of kinetic theory of gases. So therefore, it is called as a fourth state of matter, that is plasma. So by considering the energy of particles constituting it, plasma is energetically the fourth state of matter apart from solid, liquid, and gaseous state. Now here in this diagram, you can see that where plasma stands as far as temperature is concerned, it is around in the range of 10⁴ to 10⁵ Kelvin temperature. Okay, and equivalent inner particle energy scale in electron volt is shown. So which is around 1 to 10 electron volt. Let me have pointer. Okay, around 1 to 10 electron volt of energy, which is sufficient to carry out many chemical reactions, chain session, bond breaking, okay, etching of polymer surfaces or textile materials and all those things. So have a sufficient energy for many applications. Okay, and Irwin Langmuir defined plasma as the fourth state of matter consisting of electrons, ions, radicals, UV radiations, and neutral. Now here, when electrons are excited, that excitation state is unnatural. So the natural tendency is to come down to the ground state energy level, thereby giving the energy in the form of radiation or light, okay, which is equivalent to the energy difference between those two energy levels, okay, which are involved in the transition. And therefore, plasma appears as a glow. So it is sometimes called as a glow discharge as well. Plasma does exist in nature. Earth's ionosphere is a layer of partially ionized gas. In the upper atmosphere, almost everything is in the plasma state. And this ionosphere, okay, which is surrounded by Earth, is very useful for communication purpose. So the radio waves which are sent from the transmitter are reflected down by the ionosphere and are received from the other part of the Earth, okay, where the receiver is there. And in this pandemic situation also, we are able to communicate with each other due to this ionosphere. 90% of the universe consists of plasma. At the beginning of universe, everything was in the plasma state. In the present epoch, stars, nebulae, and even interstellar space are filled with plasma. Solar wind is also an example of Earth's plasma. So Earth's magnetic field, you know that the magnetic field, Earth produces magnetic field. We have a north and the south pole. So Earth's magnetic field protects us from the plasma created by solar wind. So solar wind continuously move towards the Earth, but then Earth is surrounded by Earth's magnetic field. And because of that, the plasma is trapped here, okay, is unable to reach to the Earth. So it the Earth's magnetic field is protecting us from the solar wind. Sometimes what happens is that this plasma may enter, okay, from this side, okay, to the polar region or here, okay, and one can see, plasma, certain type of plasma at the poles. Plasma state on sun, it's a hot plasma, temperature is very high, and this can be observed particularly when there is a total solar eclipse. In total solar eclipse, the moon covers the sun and whatever glow we see around it is plasma. Lightning is another example of plasma in the nature. Lightning helps to convert nitrogen present in the atmosphere, okay, it is converted into the nitrous oxide and all those things, which can be then absorbed by plant. So this is useful phenomenon basically. Yeah, this is what I was trying to tell, that the aurora borealis is observed at the poles, north and the south pole. The reason is because from that there is a possibility that the solar wind may reach sometimes, not always, sometimes, to the polar region, and then we see such colored, beautiful colored background, that is aurora borealis plasma. So those were the examples of plasma found in nature. Plasma can also be created in laboratory. There are two types. One is thermally equilibrium plasma and the another one is thermally non-equilibrium plasma. Let us see what is thermally equilibrium plasma. Normally, it's a high pressure, more than 10 torr. It is called as a thermal plasma. At high temperatures, gas become fully ionized and sufficient number of electron neutral inelastic collision occurs. When there are enough number of interaction, collision and all those things, so there is an effective transfer of energy from energetic electrons or energetic plasma species to other species, so that the temperature is uniform and the temperature of electron T suffix E is equal to T suffix I, that is ion and electron temperature is almost same, and the temperature is of the order of 10⁴ Kelvin. So this kind of plasma is suitable for thermal plasma spray coatings, nitriding, or cutting, drilling, welding applications, okay, but not suitable for surface modification of polymers, textile, or food processing because of the high temperature. However, we have a thermally non-equilibrium or cold plasma. It can be generated at low pressure, less than 10 torr, or even at the atmospheric pressure. So we have non-thermal atmospheric pressure plasma systems also. And in this, only 1 to 10% of gas is ionized. So less number of electron neutral species inelastic collision results in insufficient distribution of energy of electrons among all plasma species. So the transfer of energy from electrons to other neutrons, okay, is not happening to that level. And because of that, the electron temperature remains high and the ion temperature is around room temperature only. So the electron temperature is here of the order of 10⁵ Kelvin, and T suffix E is very, very large as compared to T suffix I. That is, ion temperature is around room temperature only. Now here the beauty is that the electron size as compared to the ion, electron is 2000 times smaller than the ion. So though the electron temperature is very high, what we feel, the temperature of plasma is around room temperature only. And the glow discharges or RF glow discharge, neon lamps, ionosphere, aurora, DBD plasma, atmospheric pressure plasma, corona, microplasmas, plasma torches are the examples of non-thermal or thermally non-equilibrium plasma or cold plasma. There are some plasma torches, okay, which are tissue tolerable and can be used in medical sciences for sterilization of mouth, teeth, wound healing, and all other applications. In laboratory ICT, we have developed different kinds of plasma systems for different applications. We have a typical bell jar type of a system where two parallel electrodes are there and a very high voltage, RF voltage, is applied between the two plates to generate plasma. We also have an elongated system, tubular system for some long sample, okay, to be treated. Similarly, we have developed this 360-degree rotating plasma reactor. So here we can create a vacuum, and yet the system is rotating and the electrodes are kept outside, and at the center part of the electrode we have three protrudes, so that the microparticles or nanoparticles are taken up and they free fall in the system. And this this video will demonstrate how it works. Just a minute. Just a minute. Can you see video now? See here, it's a rotating reactor, so that the particles or the grains which are there inside, okay, they are rotated and free fall, okay, happens there, so that the particles are equally treated from all the sides. So that's the beauty of 360-degree rotating reactor that we have developed in our laboratory, and yet the vacuum is also maintained. Now, mechanisms of generation of plasma. An electric field is imposed to a gas. Then electrons and other charged species are accelerated and gain energy. So some electrons are, the loosely bound electrons, they are ejected, and then they charged species are formed. They are accelerated, and these accelerated species in turn interact or collide with other neutrals, and degree of ionization increases. Molecules are fragmented. Homogeneous and heterogeneous reactions occur. Then the plasma is sustained by balance between the production, that is the ionization, and loss, recombination of charged species. There is a certain possibility that the electrons and holes may get recombined. So in order to sustain plasma, we need to continuously pump energy to the plasma reactor, so that the plasma is sustained. In short, energy in should be balanced with the energy loss, and then the plasma is sustained in the system. There are large number of applications of plasma in various fields, like from textile, packaging industry, functionalization of material, tissue engineering, biomedical engineering, printing technology, and food processing technology. Attractive features of plasma surface modification is that it changes only the top molecular layers, where the bulk properties remain unaffected. It's a single and dry process to minimize waste, applicable to virtually any solid surfaces, including nanoparticles, that I have shown you the rotating reactor, which is very much suitable for this kind of thing. And conformal, highly cross-linked pinhole free polymeric films can be obtained if we do plasma polymerization work, and excellent film thickness control is possible, and wide range of film chemistry with pulsing nature of plasma is also possible. Applications of plasma in food and agriculture, this is the least where it can be used. Cereal and pulse industry, food, vegetable industry, dairy industry, meat and poultry industry, spices industry, surface modification of biopolymers, agriculture, and all those things. Plasma is also used for microbial inactivation, and what happens there is the deformation and leakage of microbial genetic material, thereby killing microorganism. Lipid oxidation, especially on cell membrane, so there will be rupture in the cell membrane. Cell wall is ruptured due to electrostatic forces, electroporation, the electric field, due to which there will be a transformation through the cells. Protein denaturation, oxidation of amino acid, nucleic acid, and which results in inactivation of microbes. So these are ACM images showing electroporation of fungal spores caused by cold plasma treatment. So for untreated one, those spores look like this, and this is at a higher magnification. Then the next two images are for 40 watt and 30-minute plasma treatment. You can see that there is a the rupture of the membrane. Electroporation can be seen, and that effect is more pronounced if we increase plasma power. This slide shows microbial inactivation of various food products using non-thermal. So there is a range of food products like dry fruits, okay, then fruit, then fruit juice, then leaves, and then cheese also. Okay, so range of food products are listed here, and the commonly found microorganisms are also listed here, and the log reduction and the time required for treatment is also given. The type of plasma, whether it is dielectric or corona or atmospheric pressure jet or gliding arc discharge, whatever, okay, and how the effect is, okay, and the last column, okay, some references are given. So a lot of work is being done in this area, and still it is a hot area that one can think about. Then the challenges in food industry is grain infestation. So fumigation is normally used in the grain supply chain. Use of fumigation has increased more in recent years. Certain kind of chemicals were used, but then subsequently they were banned. The another kind of chemicals we started using, but then microorganisms, okay, or this that they develop, okay, got developed resistance to that. And since there is no single compound today that will control all species attacking stored products, a combination of two products must be applied. Resistance to phosphine had been detected in China, India, Dominican Republic, and Australia. Similarly, mycotoxins are poisonous chemical compounds produced by certain fungi that is found on grain, okay, and are regularly found in food and animal feed stuff such as grains and seeds. Since they are produced by fungi, mycotoxins are associated with disease or moldy crops. Although visible mold contamination can be superficial, inside it may be more. So the effect of mycotoxin may be acute or lead to longer term chronic or cumulative effect on health, including the induction of cancer and immune deficiency. So it is necessary to find some newer technologies, and that technology should have certain characteristics. So action need to be taken to be able to provide grains with high quality and safety, which are stable over extended period of storage time. When fumigants are used, normally it requires at least 10 days, 7 days to kill all stages of insects life cycle, okay, that usually exists in stored food. And people are now more aware about the residual chemicals, okay, of fumigation or whatever the pest control is there. People are now more aware about it. They are more health conscious. So what is required is a decontamination intervention technology which is rapid enough with low energy and cost input, does not negatively affect the quality parameters of grain, and critically leaves no residual chemicals on the product. And in this regard, plasma is a promising candidate to get rid of infestation and sterilization of food grains. We have also used cold plasma processing for treating brown rice. Brown rice is having very good nutritional values, but so there are certain drawbacks that cooking energy required is quite high, and cooking time requirement is also high, and the chewability is another issue, and all those things. So in order to tackle that, what we did is it was processed in cold plasma, air plasma, and this SEM photograph shows that there is a etching on the surface, which resulted in decrease in cooking time, increase in water uptake, so that the hardness was decreased, softness was increased, okay, whiteness increased, and some other properties also enhanced in this. Cold plasma applications in agriculture, particularly there are two things. One is enhanced seed germination. In that also, the seed is subjected to gaseous plasma so that the surface becomes hydrophilic one, and then it can absorb more moisture or water, and the germination can be more effective. In addition to that, we can also water these seeds with plasma activated water. That also helps in enhanced seed germination. And then another thing is we can water, the plant with plasma activated water, which is little acidic in nature. So effect of cold plasma on germination. There are certain reasons why the germination, okay, is found to be increased. The etching caused by reactive species increases hydrophilicity, okay, thereby water uptake by the seeds. Increase in seed reserve utilization and ability of plasma to inhibit hormones responsible for seed dormancy. Here is a photograph which shows that how the growth of the root and the shoot, okay, is more when the mung beans were or seed were subjected to plasma. So for untreated, you can see the length is shorter as compared to the treated one, okay, which is longer one. So what is there with this PAW, plasma activated water? So if we analyze it, it contains reactive species, reactive oxygen species, reactive nitrogen species. These reactive nitrogen species are very much useful, okay, or is a nutrient rather, okay, for the plant. The decrease in pH, there is a decrease in pH, so slightly acidic in nature. Conductivity is also increases. So see, there is a synergetic effect of acidification of water and reactive species is evident in plasma activated water. Nitrate of plasma activated water is absorbed through the roots, acts as a plant growth enhancer, and this PAW also acts as a fertilizer for plant growth, and therefore we find, okay, very substantial growth or dramatic increase in the height of a plant. You can see here the example in this photograph that for the control, the progress of the plant is not much, its height is not much, whereas when it was watered with 15-minute discharge, okay, you can see it would increase, and 30-minute discharge, okay, plasma treated water, you can see that, okay, plant height is substantial. And there are some other applications that we can improve functional properties of flour. At ICT, we have studied soybean flour, then starch and all those things we have studied. Hydrogenation of oils is also possible. So no use of catalyst for hydrogenation of oils. That is okay, that we can initiate with plasma. Degradation of pesticide residuals on fruit and vegetables. Nowadays, that is also a challenging field, that the pesticide residual remains on the food product. So if such food product is processed in plasma, there are chances that these pesticide molecules may degrade, or okay, in a short chain or whatever is. But then we need to really understand whether those fragments of pesticide molecules are more hazardous or less hazardous than the entire molecule. So that study needs to be done carefully and systematically. Then only we can say about the effectiveness of plasma in degradation of pesticide residues. Okay, then sterilization of spices. Some fungus growth and some other kind of thing is observed on spices, and many volatile components are present in spices, so it cannot be subjected to thermal sterilization. So need to have some non-thermal processing, and plasma is one of them. We had a Indo-Sri Lankan joint project on which we have worked. We have done a lot of work on sterilization of different kinds of spices, and in one of the session, our Sri Lankan collaborator Dr. Neville will be presenting on this. So I have just mentioned it in this. There are certain advantages, that the minimum shadow effect, UV light treatment is also there, but then the shadow effect is there. Okay, here the minimum shadow effect, minimum effect on quality of food. The reason is that it's only the surface modification technique. It will not go into bulk. Okay, so that is sufficient, effective against most of the microorganisms, and can penetrate through cracks or crevices of any odd shape. It particularly for 360-degree rotating reactor, all the sides, okay, of grains can be processed very well. The limitations, there are certain limitations, but with time those limitations can be covered, okay, and worked out. Equipment cost is one of them. Then food safety regulations, that we need to really understand the mechanism and the effect of plasma, okay. And the other side, okay, we have just we have been talking about the positive effects, but So we also need to study some negative effects of plasma, okay, on foods, and if it is there, how it can be minimized, and then that's the toxicology, okay, that we need to. And this slide present future outlook and conclusion. Cold plasma is an emerging technology for surface modification, decontamination of foods, packaging material, biofilm, starches, and gums. Effect of cold plasma on sensitive food components like lipids. Okay, there is a possibility that the lipid oxidation may happen. Okay, volatiles may get removed to some extent. Okay, vitamins need to be better understood and optimize the plasma process. Probably we may address these issues by controlling plasma parameters, okay, or fine tuning of plasma parameters may address these issues. Inactivation mechanism of microorganisms and enzymes needs to be better understood, ensuring generation of some reactive species each time. Food safety is also a concern that needs to be addressed. And these are some images of plasmas, that how it can be used for different applications. Okay, and thank you very much. And I thank organizers for inviting me. I'm odd man out in this August gathering. That way I'm a physicist, but they have given me a chance to interact with you people. Okay, so I must thank them. And I'm thankful to the audience, and I'm also thankful to Professor Brijesh Srivastav, who is co-chair of this session. Thank you very much.
Thank you, sir, Professor Deshmukh, sir. As you said, you are odd man out. No, sir. Nowhere you are odd man out in this session, sir, because you are the person dealing with the science, and we are using the science given by you people. So you are, without you, our technology cannot be sustainable, sir. So
Yeah,
you are very much in the field, and your presentation was very much enlightened for us and for the participant of this ICFOST, and really a very nice presentation is given by you, and the knowledge disseminated by you will be used by food scientists, and they can apply this in their application, and then we can go for the more sustainable technology in the market. Thank you with this for a very nice lecture, sir.
Yeah.
With this, if you permit, we can move to the next presentation, sir.
Yeah. Okay. So as a chair of this session, I invite next speaker, Dr. R. Mahendran from IIFPT, Tanjavur. Let me introduce Dr. R. Mahendran. He is associate professor and head of the department. He has done his PhD in food process engineering. He has acquired graduation, that is BTech in chemical engineering, MTech in industrial biotechnology, and PhD in food process engineering. Mahendran's research focuses on cold plasma applications on food, agricultural food structure, shape transformation, and novel non-thermal processing on food systems. Dr. Mahendran has authored over 50 publications in very reputed journals. He has written some popular articles, and that should be the job of a scientist to, it's an outreach activity, writing popular articles in newspaper and all those things, so that the knowledge is disseminated to the society and Aam Aadmi. And he has co-authored several book chapters. He is also a member of a few professional bodies, and he has served as guest editor for some journals. And he is a board member and reviewer for reputed food processing journals. And his area of specialization is non-thermal food process technologies. I invite Dr. Mahendran to present his work. Dr. Mahendran, please.
Thank you, sir. Am I audible or my screen is visible?
Yes, sir. You are very much audible.
Thank you so much. Respected Deshmukh sir and respected Brijesh sir. On behalf of NIPTAM Tanjavur, I take this opportunity to thanking the ICFOST and AFSTI for giving me this opportunity to present our work in front of the participants and two guest speakers. So already Deshmukh sir given the brief about the plasma food system matter. I'm directly getting into the application part. So when we give ample of energy to any gases, it creates plasma via ionization. So reactive species, whether it is reactive oxygen species or nitrogen species, it is an umbrella term which includes ions, neutrals, and the charged radicals. When this energy is applied, the molecule cleavages and forms reactive species. There are 4 significant types of reactive species could form due to the homolytic cleavages which produce the free radicals. Due to the heterolytic cleavages, produces positive and negative ions, and also produces radical cation in the form of abstraction of electron, which produces the radical anion in the form of when it is added with the electron. So this reactive species are known by different type and concentration based on the equipment configuration, the quantity of power or the source of power, the mode of exposure, different types of gases which is being used, and also the time of exposure and the gas flow rate. All this will form a significant role on the intensity and the density of plasma species which is being formed during the plasma generation. This plasma species, when it is exposed to food molecules, it has a specific effect. Different species will have a different kind of effect on the biomolecules. For example, hydroxyl radical would form the which would abstract the hydrogen from the biomolecules. So, in order to your application is on the hydrogen removal or water removal part or water modification part, hydrophilic to hydrophobic modification purpose. So, for this purpose, our aim is to create the hydroxyl radical more, so that you could be able to form the hydrophilic to hydrophobic or hydrophobic to hydrophilic. Likewise, so hydrogen peroxide would form the non-radical neutral species with longer half-life generated in the presence of moisture, which is highly oxidizing in acidic environment. Likewise, a singlet oxygen electronically excited state of the triplet ground state of oxygen, which has a unique ability to penetrate in the water-lipid interface. So likewise, all these species would have a specific effect on the biomolecules. So the major biomolecules includes carbohydrate, protein, and lipids. So this plasma species form the functional group on the surface, which increases the water absorption in case of germination effect. Similarly, fragmentation or cross-linking would happen between the protein and the species, and it is which is improve the functional properties, allergen reduction, as well as enzyme inactivation. In the case of lipid biomolecule, oxidation of lipid would happen, which forms the off-label formation. Likewise, for the addition of antioxidants can be done to reduce the oxidation of lipid molecules. So there are various types and the designs of plasma configurations. Throughout the globe, there are different groups are working on it, and majorly DBD plasma is everybody adopted. Coming into the agri-food sector, we can divide into pre-harvest processing and post-harvest processing. In general, pre-harvest processing includes majorly decontamination purpose, microbial decontamination or pharmaceutical decontamination or pesticide decontamination. Also, this can be applied in soil, water, and seed, and also water can be converted into plasma activated water for the chemical decontamination or microbial decontamination. Majorly, compared with the pre-harvest, post-harvest application is more with respect to cold plasma application, whether it is root-based fruits or vegetable, or grains, or leaves, or nuts. With respect to fruits and vegetable and spices and herbs, it has vital and varietal applications. Coming into the seed part. When plasma is exposed on the seed, what happens to the reactive oxygen and reactive nitrogen species would be formed, which would etch the surface. And what will happen when the surface is being etched? So water absorption rate would increase, so which would reduce the dormancy period of the seed, so that it can potentially alter the germination rate, germination potential, bigger index, water absorption, contact angle, vitality, and the growth tolerance of the seed. So we have done an work on the cumin seed germination. So where we exposed cumin seed into the plasma, and we studied the parameters, and we found that seed germination was enhanced by about 43%. Similarly, the total chlorophyll content was improved by 15%, and the root and shoot length also improved by about 42 and 35%. So with the exposure of whole plasma, we can able to increase the germination, but also the chlorophyll content, the speed or the length and length of the root and shoot length can also be improved. As I said, when the seed is being exposed into the whole plasma, the contact angle between the water and the seed, the contact angle start reducing when the exposed time is being increased. So the controls has the contact angle of 138 degree, which means that the contact surface area of water with the seed is less when compared with the seed which has been exposed for 4 minutes. So the surface is being widely covered with the water, so that the rate of water absorption is being improved. So once the plasma activated water or the plasma treated seed would absorb more water, so surface wettability improves, so the seed germination rate fastens. Similarly, we have done the same and green gram germination, where you can visibly see the treated plasma has the better length of the shoot as well as root, but also the strength of the seed shoot is better. So effect of plasma on the microbial cell, because as we are all aware that when it is exposed to plasma, we may not be able to completely sterilize or completely expose the plasma into the liquid material because of the shadowing effect, as Desmukh sir was mentioning. So in order to improve the shadowing effect, what we did is we have generated the plasma gas and we have bubbled it through the sample. So what happens, which improves the rate of heat transfer and mass transfer. The turbulence is created, so it from the laminar to turbulent region. So when it is moves to turbulent region, the plasma is exposed throughout the sample. So here is an example of the work which we did on the coconut nira. As we are aware that coconut nira, the shelf life is only just 3 hours. After that, it becomes fermented and becomes tardy. So to avoid that, we expose the plasma with plasma gas with 5, 7, and 10 liters per hour with a 300 ml sample. So we found that the free radical was confirmed with the electron spin resonance spectroscopy. The oxygen free radicals interacted with the microbial cells and it inactivated the micropresenters. This research gives an insight for the better interaction of plasma species while bubbling through the liquid food systems. Similarly, we have bubbled the plasma gas into the cumins, which whole cumin and as well as aminated size reduced cumin particle as well, and we exposed for the extraction of the cumin oil. So we found that the plasma bubbling could improve the efficiency by about 20% and increase the yield also by 25%. And also we have done the plasma bubbling and the textural property of pearl millet. So we have taken the pearl millet and we have bubbled the plasma gas into it. And then we went for the flaking and puffing of the millets. We found that the expansion ratio of pearl millet in terms of flakes as well as puffs was improved to almost double the time. When compared was 4.2 times, means the flakes expansion ratio was 8.3 times better. Similarly, the puffing ratio was almost double the time, 4.9 for the control and 9.5 times for the pearl millet puffs. This synergetic effect of plasma reactive species in combination with the hydration, which aids in improving the grain properties, which helps in diversifying the utilization of millet grains as well. And also we have atmospheric pressure plasma jet system, wherein we can have the food samples in the conveyor and we can move between the two electrodes through the conveyor belt. One side we can keep the sample and the other side treated sample can be taken off. So here also we have taken the pearl millet. So there is an anti-nutritional factor which is present on the millets generally, particularly pearl millet. So in order to reduce the anti-nutritional factor, and also this anti-nutritional factor biting has the binding, covalent bond binding between the ions with biting. So in order to break that particular bond, we are using this plasma jet. So in order to break that particular bond, we are using the atmospheric pressure plasma system for 40 kV, 45 kV, and 50 kV. And we found that the biting anti-nutrition factor has been reduced. At the same time, the availability, bioavailability of the broken compounds, like for example, iron compounds, which is available for body to consume it. So one part is we can able to reduce the anti-nutrition factor. The other way, we can also improve the bioavailability of multivalent cations. And also, we have taken lemon peel, biological tissue. We exposed it to plasma system, wherein we found that the amount of time required to get the extraction is better in case of plasma assisted hydrodistillation when compared with the microwave assisted hydrodistillation and simple hydrodistillation. So here we could be able to see here that after plasma treatment, because of the surface etching or otherwise called surface modification, the during the hydrodistillation, the rate of penetration of sample would be much better, so that we could be able to reduce the time from 17 minutes to 11 minutes. So which is significant in terms of when compared with the conventional hydrodistillation. Not only the yield of the oil is improved, but also the time of extraction is being reduced. So other interesting application which we have done is continuous decontamination of milk, because there are a lot of works which has been done on the milk, but the quantity of milk which is being exposed was very few ml on the petitute, like 5 ml to the maximum 50 ml has been exposed. So what we did is we have developed a system in which a low pressure plasma will be generated. At the same time, the sample, liquid sample can be passed through the system on atmospheric pressure. So it is a combination of low pressure and atmospheric pressure, in which continuously we can pass the liquid at one side, we can take it the treated sample at the other side. We found that more than 95% of the microbial reduction has happened at 3 ml per minute sample. Still, we are working on it to improve the better flow rate as well as better plasma reduction. And also, we have done work on the low pressure plasma system, wherein we have taken tomato sample, where usually pesticides are more. In order to reduce the initial pesticide chlorpyrifos of 0.6 to 0.8 ppm, which is being subjected to DVD plasma for just 4 to 6 minutes. We found that a maximum reduction of about 90% pesticide concentration was reduced. As this mixer was mentioning, there are negative effects also there. So in this case, we found that the total tomato color index was enhanced, but the firmness bioyield point, carotenoid content, total phenolic content was decreased considerably. So we could able to reduce the pesticide at the same time, the carotenoid content, total phenolic content, bioyield point, firmness of the treated tomato was considerably reduced. The reason could be a low pressure plasma system, whereas suppose if you are taken the sample into the atmospheric pressure plasma system, this negative effect can also be overcome. We have compared the pesticide detection on the soybean with ozone, because when you convert the oxygen, pure oxygen, into the fourth state of matter, it forms the pure ozone. Whereas plasma is the even if you take oxygen, I mean air as a gas, it is a synergetic effect of UV radiation, plasma reactive species, and also the oxygen converted into ozone, nitrogen converted into nitrogen free radicals. So from this study, we found that ozone treatment took 30 minutes to degrade 50% of the chlorofluorous at 550 ppm concentration. Whereas at the low pressure plasma system treatment took just 6 minutes to degrade 50% concentration of chlorofluorous at 100 watts. So what I am saying is, even with the ozone, it takes 30 minutes to degrade 50% of the chlorofluorous concentration, whereas low pressure plasma system takes only 6 minutes to degrade 50% of the concentration. And also, we have done an insect mortality. It is even with ozone, we could be able to inactivate the adult of insect. Whereas with the usage of cold plasma, we can able to inactivate or kill larva, pupa, even at egg stages, we can able to kill the insect. So this could be the promising non-chemical, non-thermal method for integrated pest management in stored products. So we compared with the grain storage system. We had developed a small grain storage system, wherein we compared with the phosphine. Generally, phosphine is used for the fumigation purpose. Phosphine tablets, aluminum phosphate tablets is generally used. So when it reacts with the atmospheric moisture, it forms the phosphine gases, which when the insect inhales, it will be inactivated. Instead of that, because that has been banned in various countries, so plasma could be the alternative technique. So we generated the plasma gas and passed it through the grain storage system, where we could be able to find that with different exposure time, like 8 hours, 16 hours, and 24 hours, we could be able to reach the mortality of 100% with the plasma treatment at 200 volts. And the phosphine treatment with the 24 hours, we could be able to even achieve only 86%, because usually phosphine also they used to go for the 7 days, whereas just 1 day means it took only it produces only 86% and even in the phosphine gas. Whereas plasma within a day it could able to produce 100%, not only adult but also egg, larva, and pupa stages. And we have also done the whole wheat grains for the insecticide purpose, where maximum mortality was achieved at about 88% at the atmospheric pressure plasma system, where we used to convey through the conveyor. One side we used to pass the sample, other side we used to take the treated sample. We went for the milling yield, protein, and the fiber content of the wheat, which were enhanced with the plasma treatment significantly. And also fortification application also we can use the cold plasma, because here is an example for the eggshell. A lot of eggshells are being wasted. Eggshell contains calcium in the form of calcium carbonate, but the solubility of calcium in water or other form of liquid will be very less. In order to increase the solubility of the calcium, calcium in the form of calcium carbonate, we treated with the cold plasma, and we have taken an example of black coffee in this case. What we did is we treated with the cold plasma the calcium carbonate powder from the eggshell, and then we fortified with the black coffee. and we found that it could dissolve into the black coffee, and also it enhances the calcium availability, which could be used for the purpose of osteoporosis. People who are able to drink the black coffee with the calcium enhancement. And also other work recently we encountered this, like fun food or future food sector, where shape transformation application also we could be able to use the cold plasma, where any kind of floor like
Dr. Mahendran.
Yes, sir.
Dr. Mahendran, we are short of time. Huh?
Yes, I'm closing, sir. Last, sir. So wherein we could able to convert the floor into hydrogel and then converting it to the zero gel. So on the zero gel, we could able to apply the different kind of pattern by applying the cold plasma. So the binding of constrained material with the zero gel would be better in case of cold plasma application. So which would able to transform into 2-dimensional to 3-dimensional. So likewise, we can also use the instead of the cleaning place generally we use in the food processing industry, we can also use the plasma activated water for the cleaning of the vessels in the plasma. So by concluding that application of plasma in agri-food is explored recently for effective contribution. We have demonstrated the microbial reduction, decontamination of seeds and germination and plant growth in enhancement in insect and fungal control in the stored seeds. However, the scaling of plasma technology for agri-food industrial operation is a huge challenge. It requires significant effort from the plasma research community for the collaborative work and upstream. These are all my funding agency for the project. This is my team at Tanjore. Thank you very much for the opportunity. Thank you very much. Thank you.
So your audio is unmute yourself, sir.
Thank you, Dr. Mahendran, for giving such wonderful and comprehensive talk on applications of plasma in different aspects of food and agriculture processing. In the chat box, there is a question for you: how plasma is effective to kill eggs, spores of eggs of insect, and what is the mechanism of action of plasma on killing insect pests? Please unmute yourself, Dr. Mahendran.
Yes, actually. Yeah. Plasma is very much effective on the inactivation of insect, not only adult stage, but also egg, larva, and pupa stages. We have done in the Tribolium castanea in the wheat flour. So where we found 100% mortality achieved at the egg stage as well. So the mechanism is like when we expose the plasma, when we expose the sample which is infested with the egg, larva, pupa, and adult with the plasma, adult is surface etching. Okay, but whereas in case of egg, larva, and pupa, apart from the surface etching, but also the inhalation of the reactive species which is being generated during the plasma exposure.
Okay. Yeah. We are short of time, so I call next speaker Dr. Brajesh Srivastav, who is from Tejpur University, to deliver a talk on pulse, light, and cold plasma, a novel approach for food and vegetable preservation. Let me introduce our next speaker, that Dr. Brajesh Srivastav is a professor in Tejpur University and has obtained his BTech from AAI Allahabad, MTech from GBPUANT Pantnagar, and PhD from IIT Kharagpur. He has 22 years of teaching and research experience and have published good number of research papers in very reputed Scopus Index journals, and has co-authored 5 book chapters, have filed 1 patent, and has transferred 2 technologies. Okay, that is a very good part of it, and has guided several students for doctoral and master's thesis. His area of specialization is emerging non-thermal processing, process and food engineering, food rheology, F&V processing and machineries, hurdle technologies, and he is a member of several professional bodies. He is very active in this area, and I request Professor Brijesh Srivastav to deliver talk.
Good morning, sir. Thank you for allowing me to make my presentation. So good morning to the session chair, Professor R.R. Deshmukh from ICT Mumbai, and Dr. Mahendran from NIFTAM Tanjore as a co-presenter of this session, and other distinguished audience of 28th ICFOST. Today, I am going to deliver my presentation on my pulse light and cold plasma, a novel approach for fresh fruit and vegetable preservation. Sir, am I audible?
Yes, sir.
Okay. Thank you, sir. So with this, let us start with some data and facts about the fruits and vegetable industry in India. The fruits production in India is around 86 million metric ton. That is around 8% of the world's production. And at present, the production Indian industry at growing rate, and as the food production is growing at the rate of 3.9 per annum, the food processing sector, they are increased by 20% per annum, and foods, frozen fruits and vegetable increased by 121% per annum, and dehydrated fruit and vegetable, they increase by 24% per annum. As the presentation is focused on pineapple processing so some production fact about the pineapple in India stands 6th position in the global among the top pineapple producing countries, and within India, West Bengal, Assam and Karnataka are the leading pineapple producers. So today's society is characterized by an increasing health consciousness and growing interest in the role of food for maintaining and improving human well-being and consumers' health. In addition to their nutritional and sensory properties, food are currently recognized as active and passive proactive agents. Among others, fresh cut horticulture produce stands out convenient and novel food. As per the International Fresh Cut Produce Association, fresh cut produce as a fruit and vegetable that have been trimmed and are peeled and are cut into 100% usable products, that is bagged or pre-packaged to offer consumers high nutrition, convenience and flavor while still maintaining its freshness. As he said, it is all product is cut or trimmed, but some of the products are not cut and trimmed, like your leafy vegetables, garlic, etc. They are only peeled and they are packed. But however, all these products, their category are alive and respire. So, and their shelf life varies between from 3 to 7 days, depending on product to product. And this fresh cut fruit produce industry has experienced growth in the vicinity of 10 to 15% for the past 2 decades. And as this in this case, the increasing demand for the fresh cut at the retail level, the fresh cut industry is facing challenge to extend shelf life and enhance food safety. So traditionally, the minimal processing is performed in a fresh cut fruits and vegetable in the category of physical and chemical and biochemical preservation methods to preserve the fresh cut foods. As per the industrial requirement, the fresh cut foods must be a microbiological safe food. So almost 5D reduction in microorganism is should be there, and the enzymatically stable product, at least 1 log cycle reduction is there, should be there, and their life must be extended. And all we know, these are the common factors which are responsible for the deterioration for the food. Whereas when we come to the fresh cut foods and produce, the microorganism and food enzymes, they play the major role in deterioration. When we come to the problem part for the fresh cut and food produce, they are microbial spoilage and the enzymatic spoilage of flavor development, browning, softening, and secretion of juice. These are the main problem associated with the fresh cut produce. When we come to their hazards, these hazards may be of a different category, maybe biological or enzymatic. In case of biological hazards, these are the microorganisms which are responsible for the deterioration, or you can say the microbial spoilage in the fresh cut fruits, where these are the enzymes which are responsible for the in fresh cut produce for deterioration. So hurdle approach, in general, the hurdle approach is applied to preserve the fruit. In this case, what we do, we provide a framework for the combined and simultaneously sequentially more than one or milder preservation factor in order to achieve an enhanced level of product safety and stability. These factors are hurdles which microorganisms and pathogens need to be overcome to survive in food. The correct combination of hurdle can ensure the microbial safety, stability, and equality of the food. These hurdles may be as physical nature, that may be temperature, humidity, and pressure, or gas composition. Maybe the chemical, here in the case of natural or synthetic preservative can be used, or biochemical, maybe some competitive microflora can be inoculated to control the. So the minimal processing is one of the, as I told, is a practice which is performed conventionally. But in case of fresh fruits and vegetables cannot be currently decontaminated using conventional thermal without treatment without affecting their physical, nutritional, or bioactive properties that may reduce the content or availability of the bioactive ingredients. So therefore, to meet this demand, the industry is investigating alternative non-thermal physical approach as well as the possible combination between them or with other preservation factors, that is called hurdles. So some non-thermal approaches can be applied for this. When we compare with these thermal and non-thermal approaches, in this case, we found that these two objectives can be achieved. But the third objective is that in case of thermal one, the deterioration of nutritional component is observed, whereas in case of non-thermal, the nutritional component is also retained. So these are some of the non-thermal technologies which can be applied for the non-thermal processing of fresh cut produce. But today's presentation, I am concentrating on this your pulse light processing and plasma application in fresh cut produce. So these are some of the advantages and disadvantages and their application of these non-thermal technologies. So now I am coming to the pulse light application in fresh cut produce. In this case, this is an emerging non-thermal technology for surface decontamination. It uses high intensity of high intensity of light in the range of 0.101 to 50 joule per centimeter square, and short time light pulses. Short time means your around 1 microsecond to 0.1 second of a broad spectrum ranging in wavelength from 200 to 1100 nanometer. This phenomena increases the instantaneous energy intensity that contributes to the inactivation of both spoilers and pathogenic microbial cells by photochemicals and photothermal mechanism. Significant microbial reduction is very short treatment time, and in addition, it can limit to the negative effect on the food quality in terms of nutritional and organoleptical properties, since there is no substantial increase in the temperature during the treatment is observed. And these are the approved FDA conditions where the fluence should not be more than 12 joule per centimeter square. So keeping this thing in the view, so the pulse light treatment is designed. So this is a schematic diagram of a pulse light system. Here a power control system is there that controls the this xenon lamp. This xenon lamp is there to here the sample is exposed here. So this control the pulse, this xenon lamp in a pulse form. So light is emitted here. A radiometer is used to measure the power, and this cooling system is there to provide the cooling to this lamp. And these are the certain parameters which are related to this pulse light and which can be controlled or varied during this treatment, and that efficacy of the treatment can be judged based upon this parameter. So this is the one system we are having in our laboratory. So this is the pulse light system. Here this chamber is designed by here, and this is a lamp, and this is the control panel by which we supply the control this lamp fluence, and this is a cooling chamber, cooling line, air cooling system is provided to cool this lamp. And if we see this light spectra, and this is the xenon lamp which is available here for this treatment. And this xenon lamp is capable of producing this pulse light, and they are generally in the range of UV and visible. Effectively, the UVC is much more responsible for the virus and bacteria killing. So this is the range for this UV light generated by this xenon lamp. So, and now coming to the mechanism of this pulse light system, as I said, this having three mechanism: photochemical, photothermal, and photophysical. In this category, the photochemical, the dimerization of thymine is in the DNA due to the penetration of UV in cell. So in this case, the DNA, the structure of the DNA is get damaged, and ultimately your inactivation of this mechanism will take place. The localized, in case of photothermal, the localized heating of the microbial cell due to the light pulses that can lead to the cell explanation. And the photophysical, the inactivation caused by the physical injury to the microbial cells due to the constant disturbance produced by pulse effect of the energy. So ultimately, this microorganism and enzymes get disinfected while they are exposed to this pulse light. These are some of the previous work has been reported in the literature for the preservation of different fruits and vegetables like tomatoes, mushroom, and black peppercorn. These are the different conditions that can be applied for the preservation of fresh cut produce. One of the research is also going on. We can increase the enhancement of vitamin D availability in mushroom after giving the pulse light treatment. So this work is also going on in our laboratory. In this case, we treat the mushroom with this help of this pulse light, and the vitamin D composition will, in the availability of vitamin D in this mushroom, will get enhanced, and that can be very much beneficial for the human consumption to help to increase the health condition of bones in the human being. So this is one experiment which we have conducted in our laboratory for the fresh cut produce fresh cut preservation of pineapple cubes. The pineapple cubes were treated under this condition, and this pyroelectric sensor is used to measure the power at the time of treatment, and their physicochemical and microbial properties of that pineapple cubes were tested. And it is found that in this case, the natural microflora, in case of control, and we are given the 5 burst and 15 burst, after the 15 burst, around 2 CFU log cycle reduction is observed in case of natural microflora. And when we compare to the E. coli, again in this case, almost 2 log cycle reduction is observed. Though we are in the working on this, by some means we are going to increase this efficacy either by using certain absorption enhancing chemical. Some of the dye we can use in the range of this UV that can be used for the enhancing the efficacy of this UV light while treating. So with this we can increase this efficacy of this pulse light application. And the physicochemical properties, this we observed that there is no significant changes observed in the physicochemical properties of the pineapple cubes. So after this treatment, this major finding, the PL is a promising technology that for the surface decontamination of fresh cut pineapple, it efficiently retards a significant level of contaminating natural microflora on pineapple surface, even at a low influence of 2.5 joule per centimeter square with a very short treatment time of 3.3 seconds. The mildest treatment of 5 pulses already costs around 1.37 to 1.28 logs CFU reduction in aerobic, mesophilic as well as yeast and mold respectively. And in case of higher the pulse PL doses, the greater will be the effect of microbial safety. The application of PL did not show the much impact on the quality parameters of that pineapple. So in this case, like this pulse light can be effectively used for the surface decontamination of fresh cut produce and some of the fruits like some of the vegetable like mushroom to enhance the vitamin D content. Now coming to the pulse light whole plasma application in fruits and vegetable processing. As earlier two lectures, they have much more have delivered about this plasma and what is the plasma albino. So that is not meaningful to define again this thing, but this plasma having I will tell you something about this plasma, how this plasma can be is mechanism how they act on this system. The UV radiation is the cause, the charged particle and reactive species. These are the three factors which control by which this plasma is affecting on this bacteria for their inactivation. These are the different sources of plasma that touches that can be used to generate the plasma. So application of plasma can be done by as the application part, they can be microflora of vegetable and fruits is made by largely of Pseudomonas and Irvin herbicola, and these are the composition of this cell. So this can be ultimately affected by this plasma. The core plasma treatment was observed to have significant effect on the removal of surface human pathogens such as E. coli and Salmonella. The total mesophilic and yeast mold population in cold plasma treatment strawberry were observed to reduce by 12 to 85%. And the cutting and shedding allows interaction between the polyphenols and polyphenolic substance in presence of oxygen, leading to the melanin accumulation. And these are the reactive species which are responsible for the inactive surface inactivation. Again, these are the reported work which is where the cold plasma application has been done for the inactivation of apple juice, orange juice, white grape juice, mushroom, and fresh cut apples, etc. And this is the another application. This is also work is going on in our laboratory to preserve the strawberries in your fresh form and your juice form. So here we objective is to surface decontamination of this strawberry and then the enzyme inactivation in this strawberry juice. This is the plasma system. We are creating the plasma in petri dish and in this tray, so we can surface decontamination of the system is done. And in this case, it is observed that the mesophilic bacterial reduction is from 2.3 log CFU and no significant change in the quality parameters are observed, and PPO inactivation was observed from up to 90%. So this is the strawberry which are stored under the at 10 degrees Celsius. Here in the control one, within 2 days, the growth of fungal growth is observed. Whereas in this case, even after the 5 days treatment, after the 5 days, the strawberry is in a good condition for the consumption. So these are the certain quality parameters which are can be there is no significant changes observed in the quality parameters. So these are the certain kinetics, inactivation kinetics were also studied and is found to be there in accordance with the and the Weibull model was found to be very suited to their inactivation kinetics of PPO in the pineapple in this strawberry juice. So this is with this the relative activity of the PPO enzymes was significantly reduced with increasing voltage and time. A maximum of 90.5 reduction of PPO was obtained at the voltage of 28 kilovolt and the treatment time of 5 minutes in a 3 minute juice thickness. The thickness of the juice was made because it is surface phenomena. So we are working on the thickness of this and then we can calculate the power penetration depth after conducting the experiment. The maximum of this much percentage PPO was obtained in a 4 millimeter thickness, and the result shows that both the electric voltage and the treatment time had a significant effect on the enzymatic inactivation. So now with this again, we are going to use, as I have told you, sir, we are going to use certain noble extraction techniques, extract, to enhance the efficacy of the this UV light in case of plasma as well in case of pulse light. So we are working also in working on, we are going to use certain plant essential oils or extract which are useful for the.
Please cover it in short.
But only two slides, sir. Only two slides. Only two slides, sir. So this is a natural plant extract. Some of the plant extract which are with the in one study, we use the green tea extract to preserve the kiwi fruit for this purpose. So this is all about today's presentation. Thank you, sir.
Thank you, sir. Sir, thank you, sir, for giving such a wonderful talk on application of pulsed light and cold plasma for various applications in food processing industries, particularly for freshly cut fruits and vegetables preservation point of view, and killing or reducing microbial count on it, and for decontamination. We will take just one or two questions I can see in
Yes,
chat
sir.
box.
Sure.
The question is, what is shelf life of cut fruit upon cold plasma treatment? But then, the question was put in the chat box, and then your slide came about that strawberry, that, the treatment of strawberry with plasma, that it remained like that for 6 days. But
Okay,
then
we shall be having
something you can add.
Okay, so this is it's a question I say. How happy to learn the example where the PL or CP is demonstrated in how pulse light treatment is safe for the fresh food contamination component. Does it destroy any biomolecules? No, sir. We have not till now. We have not got any effect on quality. Only some of the loss of ascorbic acid is observed, but rest of the other quality parameters we have not observed in the loss during the treatment, whether either it is in a cold plasma treatment or in a pulse light treatment. Both ways we have not observed any such type of quality loss.
Okay. And the other question is, how cold plasma treatment is cost effective? Maybe, I'm a physics background person. I can.
Yes, sir. It will be, I think you can answer.
So I consider that this question is for me. Okay. So the question was asked by Dr. Prakash. Dr. Prakash, see, basically, a lot of development is happening in plasma processing of materials, including food, polymers, textiles, and other materials for various applications. And slowly, the cost of plasma machines and power supply is decreasing. Okay, and we are hoping that even further there will be reduction in the cost. But at present, initial investment of cold plasma processing machine is high, but the running cost is low. That I can say.
Yes, sir. Running cost is very low, sir. Running cost is very low.
The running cost is low because the wattage is not much. So and the maintenance is also not much. These machines are very sturdy. So only the
power supply, sir, high voltage supply is very steady, sir. Very steady.
Very sturdy. So that's not an issue. But with time, the prices of power supply will also go down. Yeah, this is what I am hoping.
Thank you. Thank you very much.
Thank you. Now, my job is to summarize the session. In this session, there were 3 lectures. The first lecture was given by me. The second lecture was given by Dr. Mahendran, and the third lecture was given by Professor Brijesh Srivastav. In all these 3 talks, what we have seen is, since I started, I'll start with myself, the first lecture. I belong to the physics, and therefore, the more emphasis of first lecture was on the types of plasma, how the plasma can be produced, okay, the reason, and the plasma in nature, plasma in laboratory, different kinds of plasma, the classification, thermal equilibrium plasma, thermally non-equilibrium plasma. Okay, so that was covered, and followed by that, I had mentioned applications of plasma, particularly cold plasma, non-thermal plasma, for food and agricultural processing. That was covered. And then in the second talk, Dr. Mahendran demonstrated that the reactive species which are produced in plasma is the result of their concentration or the type is a result of so many parameters like power, what type of gas you are feeding, this distance between two electrodes, time of treatment, and even the surrounding also. So in the surrounding also, if in the vicinity, if you know, for some gas, the type of reactive species generated would be different. Then, you know, he has also mentioned about different kinds of plasma reactive species which have a specific effect on food biomolecules. So ROS and RNS will have a different effect on biomolecules. That was covered. And what I have observed in his presentation is that he has covered many things, like we say roti kapda makan, something like that. So effect of plasma on soil, water, seeds, leaves, lemon peels, even milk, okay, millets, pearl millets, and all those things, and have shown positive effects of all these on all these things. Whether it is extraction of some active ingredient is there from lemon peel or some leaves, okay, or germination of seed is there, or the quality of water as a you know, for watering plants is there, or even the soil, okay, is treated by plasma and its positive effect. And in the presentation he has also mentioned one thing, that we need to understand, okay, the other side of plasma, whether there is any, you know, harmful effects of plasma. We are, so far we have been discussing only the positive points, but he has mentioned that we need to study negative points also. And finally, you know, we have to weigh the risk and the benefits, and then only, you know, the application of this plasma, the newer technology, okay, can be brought to the real sense application level. Okay, then that bubbling of gas, how it is useful. So it's the indirect exposure of you know, things to the plasma. I would not say it's a direct, it's a indirect, because the plasma is generated, and the then it's a you know, the gas that is passed through the system. So that may have, you know, limited adverse effects or no adverse effect. That is a good thing about it. And in pearl millet, what he has showed is that anti-nutrients like phytin can be reduced. This is a very good thing, because in some food products there are anti-nutrients present, or some thing which is present and hampers in digestion of nutrients. So if such things can be controlled using plasma, is a good thing, I can say. Degradation of pesticides he has studied, and he has reported that so far he has not noticed any adverse effect of, you know, the fragmented pesticides. So that he has shown. Then fortification of calcium, okay, then infestation and all those things he has covered, and has shown light on the application of plasmas. Then Professor Brajesh Srivastav has covered the application of pulse light and cold plasma, these two techniques in one lecture, okay, for food, freshly cut fruit preservation, and vegetables. He has mentioned that minimal processing is done on fresh cut fruit, and you know, there could be generation of pathogens, or there could be contamination, and that contamination or generation of pathogens or microbes can be addressed by using these technologies. Maybe, you know, we can think about a hybrid technology where the samples are treated in a UV light followed by plasma, may have a better effect, and in a short duration we can achieve the goal. That is also possible, okay, from this lecture, what I think, okay, from future point of view. And that there was a question that suppose the juice is treated with either cold plasma or using UV light, then after how much time, the microbes will start growing. That careful analysis is also required, I think. And just one suggestion, Professor Brijesh Srivastav, I have seen your machine, okay, photograph, where you have labeled the front side glass of that chamber as a quartz window. From physics point of view, what I feel is if inside is a UV lamp, then quartz window is not an ideal thing to be there, because quartz will pass UV light, and the student or anybody who is opposite.
Sir, this is not a, that is a building glass. Quartz is written, sir. That is a building glass is written.
So that, the glass, normal glass would also do, because it will absorb or block the UV radiation coming out.
So we have kept the double layer of building glass.
Okay, then that's fine. It's a very good thing. Okay, and your systems are also very good. In all the presentations were nice, and I am sure that audience must have benefited from the diverse applications of plasma in this field, though it is newer as in food processing, but this technology is very much in use as far as polymer and textile material processing is concerned. And many more applications in due course of time will be emerging out of this technology. Thank you very much. I thank organizers for giving me an opportunity to chair the session and to summarize the session. Thank you very much.
So, okay, sir. With this, my job is there to give the vote of thanks to the sisters today's presentation. So I am thankful to the our session chair, Professor R.R. Deshmukh, for this presenting a nice lecture, and Professor Mahendran for delivering a talk on this. And I am also thankful to the ICFOST committee. They have given opportunity to us to chair this session. And also I am thankful to the Aromax for sponsoring this session. And also this Aurangabad chapter, who has successfully organized this event ICFOST 2020. With this, we can end this session. Thank you all participants, and thank you, Chair, sir.
Thank you.
So the other session can take over the charge.
Okay, so do we have to log out and then log in?
So it is, you can be present here to listen to the other session also, no problem, sir.
I think there is a tea break.
Dr. Rastogi, you can take over the charge of this session. I think he is the next session chair, if I'm not wrong.
Yeah.
Yeah.
Hello.
Yes, sir.
Hello, I am Uday Naik. I'm co-chair of the technical session number 14, next section.
Okay.
So yeah, are we going to give a record? Shall we continue the next session immediately right now?
Yeah, you continue, sir. You take over the charge. You take over the charge from here, sir. Now you take over the charge, sir.
Okay. Let me check. Dr. Rastogi is there.
Yeah, I am available, sir.
Yeah, yes.
Good morning, everybody.
Yeah, good morning. Good morning, everybody. So good morning, everyone. I hope you all are enjoying the conference, and all the sessions are very nice so far. And I am excited to co-chair the technical session number 14, which is based on the theme novel, emerging and adaptable food processing technology. Let me confirm. Yeah, am I audible to all of you, please?
Yes, very much.
Yes, you are.
Yeah, yes. Thank you very much. So our this technical session number 14 is on novel, emerging and adaptable food processing technologies. We have got a wonderful personality with a lot of research and professional experience as the chair of this session. So first, I would like to introduce Dr. Naveen Kumar Rastogi, who is going to chair this session. So Dr. Naveen Kumar Rastogi is MTech, MBA, PhD in food engineering, having 32 years of research and professional experience. He is currently Chief Scientist and Head at Department of Food Engineering, CFTRI Mysore. He has been awarded with many prestigious awards, such as AFST Young Scientist Award in the year 2000 by Association of Food Scientists and Technologists India, that is the AFSTA. Then CSIR Young Scientist Award 2001 in Engineering Sciences, sponsored by Council of Scientific and Industrial Research, New Delhi. Then AFST Lalji Godo Nidhi Smarak Award 2003, sponsored by AFSTI. Then CFTRI Award in the category of Best Technology Transferred to Industry for the production of virgin coconut oil by wet processing. Then he has certain fellowships to his credit. He has been awarded with some prestigious fellowships as well. For example, Seliman APB Fellowship in Food Engineering 1997, sponsored by Society of Chemical Industry, London, UK. Then German Academic Exchange Service Fellowship, sponsored by DAAD Bonn, Germany. Then Department of Biotechnology, DBT, Overseas Fellowship 2005-2006, which is a long-term fellowship sponsored by Ministry of Science and Technology, Government of India, New Delhi. Then he is fellow of AFSTI. He is fellow of National Academy of Agricultural Sciences, FNAAS 2018. He is fellow of Institution of Engineers 2018. Then he has delivered plenary lectures, almost 46 plenary lectures in international sessions and 83 in national sessions. He has attended 25 national congress and 25 international conference and 48 national congress. Then 141 paper presentations are to his credit. He has published 36 books and chapters. He is having almost 17 patents and technologies to his work. And he's having international fellowship of 3 prestigious organizations. His area of specialization is food engineering, food technology, chemical technology, biotechnology, marketing, personal management, and system management. So I'm very happy to present this wonderful personality as the chair of this session. And there is some a bit change. Actually, 3 speakers were planned. Dr. Mr. H.S. Satish is not available, and Dr. Akshata Tushar Gaikwad from Hexagon Nutrition is going to present her topic. So over to you, Dr. Saxena, as the chair for further business. Thank you.
Okay, thank you, Dr. Uday Nayak. And it was really a pleasure indeed to hear such a nice words about me. And just for the information to our guests, members, and the friends, Dr. Uday Nayak is a BTech in the food technology from Parvani and VNMKV Parvani, and then he did his MTech from in chemical technology from ICT Mumbai. And then he started his own company, Aromax Creation. I think they are one of the sponsor of the sessions also. And he is well expertise in, like, he is extracting flavors from the nature, or sometimes synthetic flavor or synthetic nature identical flavors. He's providing flavor solutions to all over the world. And that company, and like, he has a very creative innovation experience and very dedicated in his work. And he is providing solutions for bakery, confectionery, dairy, pharma, and the snacks industry. And probably he has publicized his work in the form of the 4 publications and in the different magazines. And like, just to drive home the point, like in the AFST magazine, Food and Beverage Industry magazine, and like that. And moreover, I was very much impressed with the application of essential oil as potential adjuvant therapy against COVID-19. Sir, I really salute to you for your very nice work. And he is a life member of the 5 associations, including AFSTI, FAFAI, CMAI, MASSI. They are the reputed organizations. I need not go much in detail about that. And he's a past president of Rotary Club, Aurangabad Central. So with this background, we are lucky enough to have a co-chair over this one for this session number 14. And there is a little change, as you mentioned, that we will encourage our young researcher to speak first and get her opinion about the certain very important topic. And this researcher is Akshata Tushar Gaikwad. And maybe it is my pleasure to present Akshata before you, the friends in the food scientists and research communities. Just a very brief background of Akshata. She has done his BSc and master BSc and masters in bioanalytical and biotechnology, and then she did her PhD from the ICT Mumbai. So I should say that this session is for ICT, though I am not from ICT, but it is a co-chairman is there, speaker is also from ICT. And Akshita has worked on many aspects, and she earlier worked on the Jackson Foods as a food technologist. Later, she joined Hexen Nutrition Private Limited just 2.5 months before. And integrity, hard work, and dedication are the hallmark of the Akshita. She is really very, and besides, she is a very versatile, foresighted, proven, and performance-oriented food technologist having the highest degree in the field, that is PhD in food science, and a well-known educationist besides that. And she has worked so much on the, as I gone through her biodata, I was seeing she has too much work on the peanut and peanut milk characterization. And I let you know, ma'am, this is my favorite food. And peanut, just for a lighter sense, I want to tell you, peanut is a comic strips which was published in 1950 to 2000 in US newspapers, and 2600 newspapers have published peanut comic, and it was restarted after 2000. And then it was published probably in 75 countries. So your food is not limited to India. It was a very, in the lighter sense, it was a very, it was published in 21 languages. 1800 strips have been published in that. And one is special, just a quote from the comic strip. I said, learn from yesterday. And it was written by the Charles Schulz. He said, learn from yesterday, live for today, look for tomorrow, and rest this afternoon. So please rest after our lecture. You can be just attend our session. And one more quote here, keep looking up. That is the secret of the life. And I think our speaker is very much influenced with the peanut comic written by the Charles Schulz. And today's her talk will be on the food fortification, ensuring food security and complete nutrition. Ma'am, I welcome you to the session, and I request you to please share the slides and start your presentation. We will give you 20 minutes as provided to us by the organizers. And if you want some more time, you can cut down my time because I am also a speaker. Thank you very much. Please present your slides.
Yes, thanks a lot, Dr. Rastogi, for your kind introduction and warm welcome. It is my pleasure to represent Hexagon and talk on food fortification. I am sharing my presentation. Is my presentation visible?
Yeah, it's visible now.
Yes, it's visible.
Yes. Just let me do the full screen. So to introduce myself, I'm Dr. Akshata. I'm working as manager, technical new product development and regulatory. So I've joined Hexagon for about 2 to 3 months ago, and I am working in this new industry of nutraceuticals, having a good background of food, and hoping to contribute towards this industry. So my today's topic is food fortification, ensuring food security and complete nutrition. So let us look at the definitions first. So according to WHO, nutrition is a science of food and its relationship to health. It is concerned primarily with the micronutrients, the concentration and the role they play in our body for growth and development and its maintenance. And when we talk of food security, it basically talks of 3 A's: accessibility, availability, and affordability. Whereas accessibility talks about that there is no barrier in access to food, that food is accessible to all. Availability talks about that enough food is available for all the people. And affordability, that every person has a capacity to buy that food for him and his family. So we are celebrating around 75 years of independence, and let's see how far we have come today in terms of malnutrition and hunger. So in spite of having so many substantial strides from government and in the food grain production and agriculture, malnutrition in India is still highest amongst children in the world. Also, around 35% of world malnourished children reside in India. That is, one third of the world's hungry population resides in India. That is, 26% of India's population is considered food insecure and it's consuming less than 80% of the minimum energy requirement. And the experts call it a silent emergency because 50% of its children under the age of 5 is malnourished. And this is a problem of, this is a grave problem for India. So let us look at what are the causes of malnourishment. So there are many causes, like because of the COVID, there is unemployment, poverty, which has increased. Again, there is hunger, inadequate food intake. Then we have our bad food eating habits, wherein we are consuming more junk food. Then there is lifestyle. Then inadequate nutrient intake, lack of proper hygiene and sanitation, non-availability of healthcare services, or rather they do not reach everybody. Also in women, if there are less gaps between two pregnancy, it also leads to malnourishment. So these are different causes of malnourishment. Also, if we look at the Global Hunger Index 2021, which was released recently, the numbers have shocked India because we have slipped to a position of 101 with our previous rank of 94 in the last year. Only countries like Afghanistan, Nigeria, Somalia are far worse than India. And we have a hunger index of 27.5. With this, we are falling in serious category of hunger. Now, this hunger index is calculated on the scale of 100, wherein 100 is the worst and 0 is the best. So, with the score of 27.5, we fall under the serious category. In fact, UNICEF has predicted that this malnourishment condition is going to worsen by 10 more percent because of the ongoing COVID pandemic. So because of the pandemic, there are some hard learned lessons that we all have learned in this past few years, that our nutritional status and the quality of diet is very essential for our well-being. Everybody is aware about maintaining good health, importance of exercise, and so on. So for malnourishment, we know that malnourishment weakens your immune system. It makes you ill. It keeps you ill and also increases your chances of dying ill or because of the illness. Also, COVID-19 diet adequacies have also been put at risk because we have observed there is a disruption of health and nutrition services. Job and income losses have been faced. Infections among the poor and vulnerable people have increased. And also there has been a disruption of local food and supply chains, which is now slowly coming back on track. So when we call of this so-called nutrients, so what are these nutrients? These nutrients are nothing but organic and inorganic complexes which are present in the food, basically categorized as macronutrients and micronutrients. Now, macronutrients are nothing but which forms the bulk of the food and are majorly protein, fats, carbohydrates. They are also called as proximate principles. Whereas micronutrients are essentially the vitamins and minerals that are present in our food in traces amount, and they look after the well-being and good functioning of the organs. So certain key micronutrients are iodine, iron, vitamin A, folic acid, zinc, vitamin D, calcium, and there are other micronutrients also, like the B complex ones, then vitamin E, vitamin K, and so on. So the deficiencies of these micronutrients in our body lead to a lot of deficiency disorders, and these are very prevalent in India. Let's to look after some. There is iron deficiency, which is anemia, very common among Indian population, especially women. Then we see vitamin A deficiency. Then there are some iodine related deficiency disorders like goiter, which are again are still a big problem for India. Also, low plasma levels of zinc, folic acid, and vitamins D have been recorded among the Indian population. There are also deficiencies related to vitamin B12, B1, and B2. And also due to osteoporosis, there are a lot of recent reportings of increasing fracture risks in Indian population attributed to low calcium and vitamin D levels. So this is all a major concern, and we will see why. Because it is very rightly said that we are what we eat, right? So this what India eats report of 2020 compares the what urban and rural population eats on their daily basis against the standard my plate recommendations, wherein your my plate recommendation says that you must consume 40% of cereals and millets, 17% of pulses, legumes, a substantial amount of fruits, vegetables, good fats, milk and milk products, and so on. Whereas against that, the urban India eats more of cereals and millets, less of pulses, and the same is also observed for the rural India. In fact, there is one more component called as others, which comprises of chips, biscuits, chocolates, sweets, juices, and processed foods, which is cluttering our plate with unnecessary calories and thus reducing the naturally richness of our food and the micronutrients, resulting in the deficiencies that we just saw. So, what are the initiatives that we can take at multi levels to support our nutrition and to ensure food security? So, at individual level, one can look and focus on food utilization, making good changes in your eating patterns, your eating habits. Physical activity should be done. At the community level, we can ensure that food availability is there, food accessibility is there, there is social support, there is equity among the vulnerable groups. At the national level, government can come ahead and make policies for food security, food marketing and media, make some good food agricultural policies, good assistance in food programs, also and widening the food healthy food basket. And at the global level, countries should come together to make better food trade agreements for better food distribution and shipping channels, for achieving better food standards, commodity pricing, and they can also work on research and capacity building. So, if we look at the consequences of malnourishment, which are we can see they are percolating in every aspect of life from children to the elderly to your work, and it affects like almost everything. For example, you can see you can get repeated infections if you are not healthy, if you are malnourished. There will be impaired cognition and brain activity. It will lower your immunity, increase mortality and morbidity among the population. Stunting and wasting has been observed in the children. Anemia and night blindness instances have increased. Also, with this, the non-communicable diseases or the lifestyle diseases that we call that the diabetes and hypertension also steps in. There are problems of overweight and obesity because we are not consuming the adequate diet, and this all leads to reduced economic productivity and also your child performance in the school. Like we all are concerned, like we all want our children to perform well in the school. So it also hampers their learning ability. So what are the strategies that we can employ to reduce malnourishment? So malnourishment is of two types. Certain people are overnourished, but they are not taking the adequate, they're not taking the healthy diet. And then there are serious cases of malnutrition, micronutrient deficiency. So to address micronutrient deficiency, one can exclusively promote breastfeeding for 6 months, which is very necessary because it is very rightly said that malnutrition starts right from the womb. Okay, so a child needs to be breastfed for 6 months. Then introduction to complementary feeding after 6 months is very necessary. Monitoring of your child's growth and promotion is also important. And three main strategies which are now adopted worldwide are supplementation, diet diversification, and food fortification. But the problem with supplementation is only 55% of the people are actually given supplementations. Not it doesn't reach the entire population. Diet diversification is again a very good option, but having and affording a diversified diet is again a big question, wherein all the protein sources, all the fruits and vegetables have become very expensive and are becoming unaffordable to the majority of the population. The most effective one, according to me, is food fortification, wherein you are fortifying one staple food with multiple nutrients. It is a cost effective method and it also can be done efficiently and in a sustainable manner. For overnutrition, one can educate people about the right nutrition, reduce the high fat, sugar, and salty foods, eliminate trans fats, make healthier food options available, and needless to say, the physical activity absolutely necessary. If we look at the food fortification timeline, we can see not just India, but many countries in the world have adopted or have mandated food fortification of their certain food products with certain nutrients. We can see Canada, USA, then we can see Venezuela, Nigeria, South Africa. They all have adopted food fortification at different levels. To talk about India, in 1953, we mandated fortification of vanaspati with vitamin A. And we are also now, and in 1962, we started iodizing our salt under as a national program NGCP. There is also a concept of enrichment, and now this term enrichment is very interchangeably used with food fortification. And just to touch upon this, enrichment is nothing but the addition of nutrients back to the food which are lost during the processing. So your food does not have anything extra. It is a simple restoration of the nutrients that were lost in the processing. So that's enrichment. To come to food fortification, according to WHO, food fortification is the process whereby nutrients are added to food in relatively small quantities in traces amount to maintain and improve the quality of the diet of a group, a community, or a population. Now, food fortification is generally recognized to be the most effective, like I mentioned, because of various reasons, because it is most cost effective. It eliminates micronutrient deficiency successfully and also fights various deficiency with just one food. So you can fortify one food with multiple nutrients and your problem is solved. The right food to be fortified is also very important. So you have to choose your vehicle carefully, a suitable one. Also the combination of nutrients that you are working with, and needless to say, the bioavailability in its most bioavailable form so that it is effectively absorbed in your body and you get the benefit of those particular nutrients. Also, food fortification is the safest way to deliver necessary micronutrients in necessary amounts to the majority of the population. Now we'll see how this is being practiced. Now there are 4 types of food fortification. First is biofortification, which is nothing but breeding of crops by adopting plant breeding and genetic engineering so that naturally the nutritional value of the crop is high. So examples of these are iron biofortification, which has been tried in rice, beans, sweet potatoes, legume. Similarly, zinc biofortification has been done for certain crops, and provitamin A carotenoid biofortification done for sweet potato, maize, and cassava. Also, there is microbial biofortification. Now we see a lot of prebiotic, probiotic drinks coming into the market, which is added with extra probiotic bacteria for your gut health and immunity. Then there is commercial and industrial fortification that we will mainly discuss, and the home fortification. Nowadays, vitamin D drops, sprinklers, and some mushroom powders are also available, which you can easily incorporate in your soups, your dals to increase the nutritional value of your home cooked food. Now, like I said, there are certain criteria for fortification, and there are certain stringent technical criteria also, which one should clearly adhere to before deciding on food fortification. That and it the commodity should tick all these boxes. Like the one is that it should be consumed by high proportion of the population. So selection of a vehicle or a staple that is consumed by all. It is unrelated to socio-economic status, that everybody in the society can afford to buy that food. It should have low potential for excessive intake. and it should not change the consumer's acceptability. That is, the sensory attributes of the food should not be changes. And then,
Madam, sorry to interrupt, but we are running up out of time. Means we need to take in short, I think. And I request Dr. Rastogi to unmute himself.
Okay.
And there are some questions also, so we need to address the questions also.
Totally.
A lot of questions are there regarding the fortification of food.
Yes.
So we would focus on that also.
Yes.
Yeah.
In 5 minutes, I will wind it up. Yeah.
Yeah. Okay.
There are some technical criteria, like I mentioned, that the technology should be simple and cost effective, the high bioavailability, and should have good shelf life, should have minimum regional variation, and should be centrally processed to ensure that it is of uniform quality. The vehicles, like I said, are very important. So common salt nowadays, double fortification. So not just with iodine, salt is also being fortified with iron. Whole wheat flour is being fortified with iron, folic acid, calcium, and zinc. Similarly, rice, vegetable oils are being fortified with vitamin A and D. Milk and dairy products again with vitamin A, D, iron, folic acid, and also omega-3 and 6 fatty acids. Also, there are ICDS supplementary foods which are being fortified. Also, there are few guidelines for fortifying processed foods as well, which I will touch upon in few times. So how does this micronutrient impact our quality of life? It's by improving our vitamin and mineral status. It improves our brain function and immunity, and in turn betters our school achievement, our productivity, income, decreases the mortality, and it improves our quality of life. So yes, is the food fortification effective? Yes, totally. So these are the instances of neural tube defects, which is addressed by fortifying foods with folic acid. And we can see these instances have greatly reduced after fortifying food with folic acid. The neural tube problems have been greatly reduced in internationally in countries like Brazil, Canada, Chile, and the reports are before you. There are various channels, there are commercial channels, and there are also government funded programs which undertake food fortification, like there is ICDS, integrated child development schemes, then we have public distribution systems, midday meal programs, and so on. And also the industry is now taking up food fortification and fortifying various staples like salt, rice, oil, milk, and wheat flour. There are a lot of Indian regulations that FSSI is coming up with to support food fortification. They have coined regulations for fortification of staples and also for processed foods. Then there are provisions or mandatory, it is by 2025, it is going to be mandatory to fortify oil, wheat flour, and salt, and so on. There are also pilot scheme fortification of rice and its distribution, which has been taken under public distribution system. So lot of initiatives on governmental, non-governmental, FSSAI level are being taken to promote food fortification. So we'll see what are the food that are being currently fortified in India and are highly regulated by FSSAI. First is rice fortification, because 65% of the Indians are consuming rice, especially in South India and the other parts of the country. So it is also considered as a staple food for the poorer section of the society, and it is fortified with iron, folic acid, and vitamin B12. And fortification is also cost effective. We will see that in the coming slides how. Wheat fortification is...
Ma'am, can you please bring to the conclusion now? Because there are two more speakers in this, and I appreciate the slides and also very impressive. We need to really sit down and learn what you have presented. Please come to the conclusion, ma'am.
Okay. So like rice, wheat, milk, and edible oils are also fortified. So coming on to my last slide, I would say that cost of fortification, by adding the fortificants of given standard in a given concentration, 1 liter of milk fortification will cost less than 1 paisa. So likewise, oil will cost less than 10 paisa. For flour, it will cost less. 1 kg fortification of wheat will take only 5 paisa, whereas for FRK, it is just less than 10 paisa for 1 kg. Also, there are provisions made for processed foods fortification, and various nutrients can be added in this as well. So with this, I conclude my presentation, and I would like to thank all the listeners for their patient listening.
Thank you, madam. It was very, very wonderful presentation. A lot of information regarding nutritive from nutrition point of food you presented. It was really very well information. So there are some questions. Before going to the next speaker, shall we take the questions, or
Yes, please.
we will take the questions at the end of
Yes,
the
sir.
session?
Because I
Okay,
want
yeah.
only the speaker, chair and co-chair and the person who is asking this, because
Okay.
otherwise we are going to delay all the sessions, ma'am.
Yeah, right. Yeah.
No.
So there is a question: how do we ensure vitamin stability in cooking while fortification of rice?
Cooking oil and fortification of rice.
How do we ensure vitamin stability? I think vitamins are heat level or something like that.
Exactly.
So how can ensure their stability in heat sensitive products, where the in processes where heat is involved, particularly in cooking?
Right.
While fortification of rice.
Yes. So for oils especially, the micronutrients that we are fortifying them with are designed and are engineered in such a way that they are stable and they do not lose its activity over time or with cooking. And anyway, with oil, we do not recommend heating, boiling, and reusing oil for a longer period of time. So under standard condition, no loss in the vitamins should happen with fortification.
Okay, and how the refined food affect our nutrition? Means we always say our children that don't eat that pizza, burger, and the food products which are based on maida type of products.
Exactly.
So do we need to avoid such kind of products, or
totally? That other part of our My
the
Plate recommendation should be completely eliminated, wherein we are incorporating dips, sauces, and all different kind of stuff. So this should be replaced with fruits, vegetables, good fats, and all. So needless to say, yes, but moderation is the key to everything. This is what I would say.
Yes, thank you, madam. Very, very nice presentation and very
Thank
nice
you.
questions and answers.
Yes.
Then we are eager to listen to our next speaker. So I request Dr. Naveen Kumar Rastogi to present his views about the topic in this session. Yeah,
Sir.
over to you, Doctor.
Yeah, thank you very much, sir. So, good afternoon, everybody. It is approaching 12. So, today I'll be presenting on emerging food processing technologies. What are the new technologies have emerged for which is leading to there was a question on the retention of the nutrients. So, this is a new technology where the thermal processing is not involved and it leads to the retention of almost all the nutrients because it is not subjected to the heat. So how this new technology is developed, it is based on the consumer demand because nowadays consumer demand a better and the best quality, highest organoleptic quality, and they search for the new alternatives. Even though it is expensive, they are ready to pay, but they want the best quality of the food. And India is like a consumer mix of two types of things, whether they prefer best quality and the people who want the cheapest quality. So we are referring to a sector where we are referring to the best quality product people are want it, and then because of the problems with the existing technologies like loss of the flavor and nutrients will be lost, viscochemical properties are affected. We know about canned foods, it is flavor and nutrients or excessive loss of this. And then if you look for a new technologies, like we look for a minimum losses of the flavor and the food quality. Any new technology should give us a minimum loss and low processing temperature. Temperature should be at the ambient or very moderate temperature. Cost of the technology should be low and it should have a very fewer environmental impacts, no effect to the environment. And it should be better than the existing traditional technologies. It avoids and reduces detrimental changes to the sensory and physical properties should not be affected. And that means the food after the processing, it should remain like the original food. And main important thing is that inactivation of microorganisms as well as the enzymes. Any technology can meet this requirement, can qualify as a new technology. And main thing is that how the microorganisms will be inactivated and how enzymes will be inactivated. And this we are doing everything at non-thermal condition. We are not applying any temperature here. So there are several technologies have come: high pressure, pulse electrified, ohmic, heating, ultrasound. There are some are thermal, there are non-thermal, supercritical, other technologies. We'll be only concentrating today about the two technologies, high pressure and the pulse electric field. And I'm sorry, I'll be very little bit quick today because organizers have generously given me 20 minutes and I have to cover a lot, about 40 slides. So I'll just start with the high pressure technology. So it is very important that we know that high temperature can inactivate the microorganisms as well as the enzymes. So this was just in the breakfast meeting. These three scientists, Dan Farkas, Dallas Hoover, and Dietrich Knoll, you may have heard their names. They have written many books, many papers, and these people just in the breakfast meeting, they thought why high pressure cannot inactivate and can do the same thing what high temperature can do. And they designed a high pressure system, and then they showed that high pressure has the same capability what high temperature can do. Incidentally, I was lucky enough to work with in the laboratory of Dietrich Knoll in Germany and learned the basic concepts of high pressure technology. So what is high pressure? It kills the microorganisms and preserves the food. This was discovered long back in 1899, but there was only the Japanese people were working on it, and food technologists did not accept it at that time. Only very recently, in 1980, they have accepted that it has lot of promising things which can happen to the food technology, and then it is a potential for new generation foods. Like we can generate a new kind of foods, and if it is not subjected to a high temperature, then the retention of the micro or the nutrients is very high here. And the high pressure means it is the over exaggeration that high pressure will replace the conventional processing. That's what I put a slash in that supplement, because classical food scientists will not agree to this statement. So that's what I am satisfying the needs of both. I say high pressure can at least supplement the conventional thermal processing. I will show some of the products prepared using high pressure technology. So what is the this is the high pressure, how it works. It is something like this, because when the pressure is very high, we need to have a plunger here. It goes inside, and it is something like that here. The pressure, the liquid is pressurized, and the food is in the cans, in the flexible cans. When we pressurize this, the pressure is transmitted all around the food, and it gets preserved. And disadvantage, this is all the advantages here. So what are the conventional processing disadvantages? Like poor heat penetration. We do not want any heat to penetrate here. It is only the pressure which is same from all the sides because of the isostatic pressure principle, and there is no loss of volatiles, labile colors and flavors. Everything remains intact because we are not going to subject to a higher temperature. And there are presence of undesirable aspect of chemical preservatives. We are not adding any chemical preservatives, so it is much safer and it will not have any undesirable aspects.
Doctor, there is one query. Are there any slides in your presentations? If there are any slides, please present the slides.
It is presenting?
Yeah, slides are not appearing.
Not moving?
Yeah.
Is that moving now? Slides are moving?
No, slides
Sir,
are
you have not shared it.
Sir, you have not shared.
1 minute. Can you look at the slides now?
Yes, sir.
Okay. So that's what I just wanted to explain about the high pressure technology. It can kill the microorganisms. It was discovered way back in 1899, but it was accepted by the food technologists very recently in 1980 when the company like Media in Japan launched the commercial products. And then I will say that high pressure can replace and probably supplement conventional thermal processing in near future. So it has all the advantages, like we are not encountering under any poor heat penetration, which is generally encountered in the canning, because pressure is instantly transmitted and there is no thermal damage because we are not heating the food here. There's no loss of volatile color or the flavor. Presence of undesirable aspect because we are not using any chemical additives. So this is no undesirable aspects of chemical additives. So the question comes in how high is the pressure is. Like we are talking about the pressure which is available several fathoms below the sea level, and it is around 100 megapascal to 1000 megapascal. 100 megapascal is around 1000 atmospheric pressure. It is used to be very high, and which we get this pressure, observe this pressure under the fathoms of the under the sea. And if you want to create this pressure in the laboratory, it is very similar to that when two elephants stand one over the other at a 1 centimeter square cross section area here, that will generate 1000 megapascal. And this pressure can be generated using the machine in the laboratory and can preserve the food. So how high pressure can preserve the food? It is very similar to the high temperature. We are not denying that. Whenever I presented, people did not believe that high pressure can preserve the food. So it is something very similar to high temperature. Death of the microorganisms take place due to the permeabilization of the cell membranes. When we subject food to the high pressure, the microorganisms become permeable. The cell membrane become permeabilizable. When the cell membrane permeabilizes, all the material present in the cell membrane, it extruded out. And sometimes at higher pressure, nucleus will lose its identity, leading to the cell death. And we are applying a very high pressure above 400 megapascal because at lower pressure, these changes are reversible. Cell may repair and function again. So we need to go at a very high pressure above 400 megapascal, and then these changes are irreversible. And it leads to the even reduction of the enzymatic activity, the quality degrading enzymes like PPO, POD, LOX, and whatever is there. All the enzymes are basically protein. And then what will happen here, when it is subjected to a high pressure, it will lead to the unfolding of the protein chains. Unfolding of the protein chain leads to the loss of the catalytic activity. And then it will lead to the loss of the enzymatic activity, and only the non-covalent bonds are affected. So because of that, organoleptic properties of the food are associated with the covalent bonds, like whatever the color, flavor, everything. So only non-covalent bond types are affected. So all the organoleptic properties like color, flavor, everything will not get affected. And suppose sometimes we get a bacteria or microorganisms are baroresistive, means susceptible to higher pressure, then we need to apply a moderate temperatures to inactivate. And then in this case, bacterial spores are not completely inactivated in this processing step. So we need to preserve these kind of products under a low temperature throughout the cold chain till it is consumed, and then it will not allow the spores and the other balance remaining bacteria to grow, and it has no effect on the olfactory and sensory characteristics. Means you cannot identify whether it is processed or not processed product. So what are the advantages of the high pressure processing? It leads to the uniform penetration. So suppose we are doing the canning, we are coming across the temperature gradients, and wherever the temperature gradients are there, it leads to the excessive damage to the quality. Here we are not encountering any kind of gradients, temperature gradients, because once we apply the pressure, it is very uniformly distributed and leading a uniform quality, and it is instantly transmitted. And elimination or reduction of the heat damage, because we are not subjecting the food to the heat or chemical preservatives. So all the effects of the due to the heat or chemical preservatives will be eliminated, and sometimes it will lead to the creation of the new functional properties. If it is lead to the new functional properties, will lead to the generation of the new food products, which I have not seen, you have not seen. Maybe the future generation will see what kind of foods it can produce. Means, just for example, if we make a ice using high pressure, it can give us a 6 kind of ice, right from the different density. So we, whatever the ice creams and those things we are eating, we know that slow freezing or the fast freezing can give us the best quality of the ice creams. We don't know what kind of incorporation of the high pressure can give us a still better quality of the ice creams. And it leads to the membrane permeabilization, leading to the cell death. It improves the overall quality of the food, and it has, that's what the phase transition. It leads to the different quality of the ice, so which will lead to the different new product making here. Maybe like if you have a strawberry pulp, if you just freeze it, it will solidify of its own. Rheological characteristics will change, and when it changes, we can use that kind of solidified food in any of the new generation. Otherwise, we need to freeze the pulp and use in that. In the, suppose we are filling in the cones, so we don't have to freeze and do it. Even the high pressure can do this job. So I'll be a little bit quick now. So there are other advantages. Like high pressure is not affected with the size and the geometry. Like we need to cut the food in case of the canning, because we just to make sure that the heat reaches to the center point of the food, where heat is not like that here, because pressure is uniformly transmitted. And it doesn't matter, like the geometry of the sample can be anything. We can start with the grape to the pumpkin, but only thing is that our high pressure system should be large enough to accommodate pumping in, because the larger the size of the high pressure equipment, the higher will be the cost. So that's why we may cut it and put it in the high pressure. And possibility to it can perform the operation at the ambient temperature. We don't have to heat this. Even ice creams can be sterilized at a low temperature without heating the ice creams. It can be made microbial free here. Most of the time, we tell the children, don't eat ice cream, you will become sick. There is nothing in the ice cream which makes the children sick. Only thing is that it is most of the time it is contaminated with the microbes, Indian ice creams. If it is sterilized with the suitable techniques, I am sure that there is nothing in the ice cream which makes the children sick. They should eat more and more ice creams. So there is a waste free. There is no waste generated. This is environmental friendly and energy efficient technology. Once you create the high pressure, it is always remain there for 24 hours. Till you release the high pressure, and we can do it for the, even this can be used for the blanching and reduction, and maybe that can reduce the food processing waste. Like blanching, we get lot of blanched water as a waste. If you are doing the blanching, high pressure blanching, it will not generate any waste water, and then it will not even lose, you will not lose the nutrient content in the blanched water, because water is not used for the blanching in this case. What is the application areas? Like we can do pasteurization, sterilization, texture modification, functional changes, and specialty products. Like freezing and thawing, we can freeze and thaw at a very low pressure. Like low pressure in the sense, like you start with the 50 to the 300 megapascal. And then if you want to do pressurization, pasteurization or blanching, we need to go around more than 200 to 500 pressure here, 500, 700 like that. We can do pasteurization. If we want to go for sterilization, this can be done, but we need to have a high temperature and high pressure for a short time. So that process is called as pressure assisted thermal processing, which is coming up. US FDA is already approved about the pressure assisted thermal processing, and some of the data what I worked in Ohio State University has been taken as a reference by the US FDA to approve this process. So there are, but only thing is that here we need to have a lot of water present in it, because water present in the food, it has a lot good compressibility. Water can be compressed up to 15% at 300 megapascal. When it gets compressed, then only it gives us the effect in the food processing, like inactivation of microorganisms. So I mean to say, dry fruits, spices, they are very difficult to subject it to the high pressure if moisture is not present here. So just wanted to compare thermal processing and the retard processing. pressure stirred thermal processing. This is the curve. For the blue one is the high pressure sterilization, and red one is the retard sterilization. You see the lethality, amount of lethality associated with the process for the retard sterilization is the area under the curve. It is very high, and it takes so much of the time to reach to 121, and then it takes a lot of time to come back to the lower temperature. Whereas if you look at high pressure sterilization process, it increases very quickly and then comes down. And there is no requirement of food to reach at 121. We can reach to 105 or 110, and that gives us a required sterility. These are some of the products which can be which can be made using the high pressure thermal processing. It is like carrot, beetroot, beans, and it is all of salad quality. We can cut them, use as a salad, and they can be preserved outside without any refrigeration. And whereas canning spoils the quality, and it's sometimes very difficult. Soft carrots, you cannot identify it is carrot. So there are so many companies now. It is just to show you, there are many people are working on high pressure. Even the commercial products are available in US. Mostly Japan has launched the commercial products, and then US has also worked on the meat products. France has worked on the fruit juices. Spain and France works on the fruit juices. US has worked on the like a oyster, removal of oyster from a shell, orange juice, apple juice. They are available in the foreign markets. These are some of the products. Like I like to concentrate on this. This is avocado puree. This is a very popular Mexican food here. They need it with all kind of foods here. Like it is something like a spice for them, and it can be preserved using high pressure. If you preserve by thermal processing, you will lose all its flavor. So it is considered the best. And whereas these are some of the Japanese product, rice cakes, and even the orange juice can be preserved, salsa, whatever product is there can be preserved. There is one company in Minnesota. They are packing the Indian curries and high pressurizing it and selling to the Indian customers. We are
Dr. Rastogi, sorry to interrupt, but we need to cover in short. We are short of time here.
I just
we are having a couple of good questions also on this topic.
Questions will take it later, but let me complete about high pressure technology, and then you start it. Questions will take up at the end of the session.
Okay.
There are some other food products available in the foreign markets, and there are various applications in the food industry. This is just to show you, like we can preserve the orange juice, we can preserve the grapefruit juice, we can preserve the lemon juice without the loss of the vitamin C. And there's very few technologies which can preserve the lemon juice and grapefruit, because there are an orange juice. Mango is the most exported commodity from India. It is generally hot filled and sold, but we can use high pressure technology for filling it in this and exporting the mango pulp to different countries. Guava is very difficult. Moment you heat the guava, it changes its flavors. So this high pressure can be used. And there are other like peaches, lychees, our production, peach, avocado puree we have already covered, and strawberry and blackberry purees. It has a lot of vitamins, antioxidant activity that can be maintained using high pressure processing. And this is last one very interesting application of the high pressure. Like we put all the things together like sugar, pectin, citric acid, and fruit juice. If we mix everything and then degas and apply high pressure, we can get a jam like this without heating. And this jam is of extraordinary quality. We can even put the fruit chunks inside it. So this is one example of high pressure. This is another example. This is like we have preserved the beans, green peas, mushrooms. So it has a lot things to offer in the dairy industry, like it can extend the shelf life. And one more application I just want to highlight here is that it can coagulate the proteins, whey proteins. And when it coagulates the whey proteins, what will happen? The yield of the cheese increases. So earlier, if they were getting low yield, now because of high pressure, they can get a high yield because whey proteins, it was going in the drain. Now it can be coagulated and added with the cheese. So yogurt, another thing here, it can control the shelf life of the yogurts. An animal product, it has lot of things to offer. Oysters, we just talk, it does the twin purpose of smoking the oysters and extending the shelf life. So I think I will stop it here, and then because we are being delayed here. And I thank you, audience, and the co-chair for my, I will stop it here, and I request the co-chair to proceed
thank
with
you.
this presentation, and we will
Thank
take up
you.
questions at the end, otherwise you will not have any time to speak.
Yeah, okay. Thank you, Dr. Rastogi. It was a very, very nice session, and a lot of new technologies have been investigated recently nowadays, which may be of helpful to industry, academics, researchers, and for the overall consumer to give them a good quality of food treated with less temperature and high pressure, like that technologies are investigated. So you elaborated a lot of things very nicely. So there are good questions on this topic as well. We will take at the end of the session. Questions are from Dr. Prakash Alami, sir, and some good questions are there. We will take after the sessions. Then shall I have my presentations as a third
He is
speaker
putting
of this
questions
session?
to all the presentations. We will only reply the selected questions which are of relevance.
Yeah, right. Because we are having short of time, so it's
that's
not
what
possible to
is-
answer all the questions. And I also apologize to the listeners as there was some technical glitch at the initial of your presentation. Some slides were missing.
he
But
can
overall, the presentation was very, very nice, and everybody, I hope, enjoyed the presentation.
I will request Dr. Prakash Alami to contact the speakers over the phone or something. Otherwise, we will not be able to complete the sessions.
Yeah, sure. Yeah.
Okay,
and
you can go with your presentation.
yeah. So I request the team to present my. Actually, I will go pre-recorded session only. So, is there anyone from the event team? Actually, I have pre-recorded my presentation, so I request
we request the host to play it.
Is there anyone here from the host team, please?
Yes, sir. Just a minute.
Yeah.
Just a minute. Sir, are you able to see the slides?
No, it's blank.
Sorry, sir?
No, slides are not visible. The screen is blank.
Blank.
The shared screen is blank.
Okay, just a minute.
Yeah.
Close
all AC shift झाले का रे all screen shift हो गए
Thank you.
Okay, just a minute.
Yeah.
all AC shift झाले का रे all screen shift हो गए
सर recording सुरू झालं आता.
So is it visible?
Shall I start the presentation? Hello everyone. My name is Uday Naik. I am director at Max Creation.
Yeah, the audio,
Manufacturer of
yeah, audio is there, but slides are not appearing.
All AC shift झाले का रे
And other companies. So first of all, I would like to
Naik sir, it is better if I think you can share.
Okay, I will check the
IT team can check.
director.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
Slides.
All AC shift झाले का रे
And other companies. So first of all, I would like to
Sir, are the slides visible?
Naik sir, it is better.
Sir,
if
yeah,
I think
yeah,
you can
slides
share.
are visible, but a lot of background noise is there. Okay, slide is visible, yeah.
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
Slides.
So hello everyone.
All AC shift झाले का रे
I am director. We are manufacturer of flavors. So first of all, I would like to such as bakery.
Sir, are the slides visible?
Naik sir, it is
Yeah,
better.
sir,
if
yeah,
I think
yeah,
you can
slides
share.
are visible, but a lot of background noise is there. Okay, slide is visible, yeah.
So first of all,
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
So hello everyone.
All AC shift झाले का रे
I am director. So first, I would like to give an overview. First of all, such as bakery.
Sir, are the slides visible?
Naik sir, it is
Yeah,
better.
sir,
if
yeah,
I think
yeah. Madam, a lot of background noise is there. Slides are visible, but a lot of noise is there. Okay, slide is visible, yeah.
So first of all,
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
So hello everyone.
All AC shift झाले का रे
I would like to give an overview. First of all, such as bakery.
Sir, are the slides visible?
Naik sir, it is
Yeah,
better.
sir,
if
yeah,
I think
yeah.
Properties.
Madam, a lot of background noise is there.
Of which
Slides are
flavor is
visible, but a
very
lot
much
of
important. And
noise is
flavor is
there.
associated with appearance and texture.
I think sir, all other need.
Okay, slide is visible, yeah.
So first of all,
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
So hello everyone.
All AC shift झाले का रे
Cooling effect as in when all then Punjab like first of all custard oil.
Sir, are the slides visible?
Naik sir, it is
Yeah,
better.
sir,
if
yeah,
I think
yeah. Madam, a lot of background noise is there. Slides are visible, but a lot of noise is there.
I think sir, all other need.
Okay, slide is visible, yeah.
So first of all,
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
so hello everyone.
All AC shift झाले का रे
Cooling effect as in when all then Punjab like
Sir, are the slides visible?
Naik sir, it is
Yeah,
better.
sir, yeah,
I think
yeah. Madam, a lot of background noise is there. Slides are visible, but a lot of noise is there.
I think sir, all other need.
Okay, slide is visible, yeah.
So first of all,
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
so hello everyone.
All AC shift झाले का रे
Sir, are the slides visible?
Naik sir, it is
Yeah,
better.
sir, yeah, yeah. Madam, a lot of background noise is there. Slides are visible, but a lot of noise is there.
I think sir, all other need.
Okay, slide is visible, yeah.
So first of all,
IT team can check.
Yeah, the audio, yeah, audio is there, but slides are not appearing.
All AC shift झाले का रे
Dr. Uday Naik, your slides are visible.
are the slides visible?
Yeah. Madam, a lot of background noise is there. Slides are visible, but a lot of noise is there.
I think, sir, all other need to
Slide is visible here. Yeah, the audio is there, but the slides are not appearing.
All institutes झाले का रे?
Dr. Udana, your slides are visible.
Sir, are the slides visible?
Yeah.
Hello, Dr. Udana.
Yes, sir.
Sir, your slides were very much visible. Only thing, there was a lot of background noise. Can you play the slides and present in the current mode, because we'll stop the recorded version. And since you are available, is it possible for you to present?
So we will start the presentation now again. So just a minute.
Hello, Veena madam.
Yes, sir.
Yeah, shall I go for sharing my screen? Means shall I make the presentation? By sharing my
Sir,
screen
just
here.
can you just sir, is it is the presentation visible now?
No, the presentation is not visible.
No, it's not visible.
Your screen is there, but it's blank.
So just a minute. Now, so now is it okay?
Yeah, your screen is visible. There is a video clip is visible, but it's not playing.
It's not playing.
Give him presentation rights, Veena. It's just wasting time. Just give him presentation rights. He can present it.
Various business verticals such as bakery, confectionery.
Yeah, it's perfect, madam. Now.
Now it's perfect.
And,
Okay, sir.
Yeah.
Nutraceutical company. So first of all, I would like to thank.
Sir, recording सुरू झाले आता.
Veena, your internal audio is being played from the system. Okay, there are parallelly some other sessions running in your laptop.
Hello everyone.
That is the reason.
My name is Uday Naik. I am director at Aromax Creation.
Please don't play the audio from your system, or let him present the presentation.
Savory, liquor.
Yeah, some parallel presentations are.
Yes, sir. Yes, sir.
Like that.
Veena, you please give him co-host presentation. He can present it from his side. Okay.
This session.
Veena,
I hope all of you enjoying the conference, and I am excited to present my topic on recent trends in flavor science and technology. So first, I would like to give an overview of flavorings.
No, still some.
So actually,
some
many of the people think that flavor is associated only smell or odor part of the food. But
Veena,
in
please
fact,
stop
flavor is
presenting
the
from your
combination of
side.
smell,
There are
taste,
multiple
and
things you are playing
trigeminal
from
and
your
tactile
system.
sensations that occur
Let the
in mouth.
speaker himself
So
present
this
to
is
do
what
the
the
presentation
definition
from
of
his side.
flavor says.
It's easy.
Okay, sir. Okay.
Yeah, that is easy.
This
Your
slide
audio is
also
also
depicts
being,
that flavor is a combination
projected
of
here. That is the
odor,
reason you are
taste,
getting
and
it.
trigeminal
Okay,
and
sir.
tactile sensations.
Yeah, don't waste the time. Come
Actually,
on.
appearance, flavor, and texture are three principal properties.
Sir, you can present it now, sir. They have made you co-host.
Okay.
Yeah.
But I'm not ready. I will check. Just a moment. Yeah. Shall I? Is it visible to all of you now?
Yes, it is fine.
Am I audible and visible?
Yes.
Yes, sir,
Is my
we can
slide
see you,
visible?
sir.
Yes.
Sir, you can put it in full screen mode and then start, sir. Slideshow mode, sir. F5, you can press F5 in your system.
Is the slide visible?
Sir, it is visible, but it is not in full screen, sir.
Press the F5.
F5, sir. On the keyboard, you can just press F5. Or in the presentation, you click on slideshow. No, sir, don't zoom it, sir. Don't zoom it.
Are the slides visible?
Okay. You start, sir, please.
Sir, I asked you for requested for your control. Can you give me the control? I'll put it to full screen mode.
How to do that?
You must
approve. Okay.
Yeah, approve.
Okay, I approved. I approved your request.
Yeah, that is fine.
Okay. Okay, shall I start now? Shall I start the presentation?
Yeah, please you start.
Yes, sir, you can start, sir. Yes, sir, you can start now.
Okay. So good morning, good afternoon, everyone once again, and really apologize for the technical glitch that has happened at this presentation. So my name is Uday Naik, and I am director at Aromax Creation. We are one of the leading manufacturer of flavors based at Aurangabad, Maharashtra, and we have been supplying flavors to various bakeries, confectioneries, dairy, savory, and liquor industries. So I hope you all are enjoying the presentation, and once again, sorry for technical glitch, and I am excited to present my subject on recent trends in flavor science and technology. So most of the people assume that flavor is associated with only smell part or taste part. Just let me confirm, am I visible now, audible now to all of you?
Yes.
Yeah, okay, sure. But actually flavor is actually a combination of smell, taste, and trigeminal and tactile sensations that appear in mouth. So this is what the definition of flavor says. This slide depicts that flavor is a combination of odor, taste, and trigeminal and tactile sensations that are perceived in the mouth. We all know that there are 5 types of taste, that is salt, sour, bitter, sour, and umami. So far as trigeminal sensations are considered, we can relate it to coolness, like as in menthol, or pungency that we perceive due to allyl isothiocyanate that occurs in mustard oil.
Then very common example of trigeminal sensation is hot sensation that we perceive when we eat the food related to chili and capsicum, like that. But in case of odor, odor terminologies are not limited to a limited number. There are tens and hundreds of terminologies that odor can be described. For example, fruity, floral, spicy, woody, astringent, acidic. A lot of terminologies are there by which odor is described. So this slide shows that taste and smell, these are the parts of flavor. Smell is perceived through nose, taste is perceived through mouth, trigeminal sensations are perceived through mouth also, and these sensations directly pass to the brain. In case of other sensations, such as the sensation of hearing, or sensation of touch, or sensation of seeing, that go through some intermediate part before passing to the brain, and then these sensations are passed to the brain. But in case of taste and odor sensations, these are directly passed to the brain. So these sensations are associated with memory. If you take the example, just try to remember a day before 20 or 25 years in your life. You can remember the delicious food your mother or grandmother used to serve you, but it's a bit difficult to remember if anybody has gifted you any precious gift at the time of your birthday before 20 or 25 years. Means these sensations are very, very important in human life. So actually flavor is composed of natural flavoring substances, artificial flavoring substances, and nature identical flavoring substances. As per the new European regulations, nature identical flavoring substances, this term has become obsolete. This term is totally outdated in the new regulations. And in new regulations, European regulations, not in FOSSI, there are only two kinds of flavors. That is, one is regarded as flavorings and other natural flavorings. But in FOSSI regulations, there are still three kinds of flavors: natural, nature identical, and artificial flavorings. Then flavor also contains flavoring preparations, which are also known as natural flavoring complexes. These are basically essential oils. For example, orange oil is there, geranium oil is there, lemongrass oil is there. So these oils are also part of flavor. Then thermal process flavorings are there, smoke flavors are there, flavor precursors are there. All these components are the part of flavor. Flavor may also contain non-flavoring ingredient. For example, emulsifier is there, like propylene glycol. Then some carriers are there, such as triacetylene. Flavor also contains food additives like colors or preservatives. And the function of all these things is to disperse, dilute the flavorings, and to proper handle production, storage of the flavorings. So actually, with this note, we will come to the today's main topic, that is recent advances and recent trends. The recent trend is flavor industry in flavor sector is due to the COVID-19. The trend is post-pandemic. There is global macro trend of contemporary wellness. Consumers are taking a holistic, balanced approach to diet and lifestyle for overall well-being. There is a saying that just recently our Dr. Akshata said, we are known by what we eat. We are what we eat. Similarly, the same way consumers are nowadays are connecting what they eat to how they feel. So they are looking for nutrient density through wholesale food, for mindfulness, for cognitive health, for functional nutrition, and nourishment for overall. So because of this trend, the functional foods and dietary supplements are skyrocketing in the supermarket shelves. These kind of products are skyrocketing there is much more demand. And when such kind of products are, the demand has been increasing, there would certainly be the demand for natural flavors is increasing in the market. So we can say that there is trend of natural flavor, but only natural flavor is not sufficient. Consumers are looking for some health benefits from their food also. They have become more aware post-pandemic. They are looking for some immunity. They are looking for some antioxidant property. They are looking nutrition beyond the nutrition, means some functionality should be there in their products. So this is the trend, and due to this trend, there has been many upheaval in the flavor industry. A lot of mergers are there. Existing units are expanding their units. There are some acquisitions. For example, in 2020, Fona International Incorporation, which is a natural flavor manufacturing company that has acquired McCormick and Company, which is a leading manufacturer of ingredients. Then in 2021, Archer Daniels Midland Company launched a new production facility in India. And this is basically to cater the demand of increasing need of flavors, particularly in functional food segment and in nutraceutical and supplementary food product segment. So there are various kinds of natural flavors which can signal the potential health benefits as well. For example, lemon is there, cardamom is there, ginger is there. Let us take one flavor, that is ginger, as a case study, means to see how we can relate the flavoring aspect with the functional aspect of that food and how the flavor can act as a potential health benefit for any food product. So let us take the example of ginger oil. So ginger oil is basically ginger oil and ginger oleoresin. These are basically part of ginger flavor, natural ginger flavor that we use in various food products. So ginger oil is obtained traditionally by steam distillation products, and in advancement it is obtained by supercritical CO2 extraction process. Ginger oleoresin is obtained by steam solvent extraction process, and in advancement in supercritical CO2 extraction. If we compare the ginger oil obtained by steam distillation and supercritical, some of the components like alpha-pinene, camphene, saponin, alpha-plenarine, these are missing in steam distilled essential oil and appearing in supercritical CO2 extraction. Moreover, some important components, these appear in high dosage in supercritical extracted CO2. Therefore, nowadays, supercritical CO2 extracted oils are preferred while designing the flavors. But in some cases where tons of herbage is involved in the extraction, for example, in geranium or orange, in that case, cold press or distill process is preferred. But wherever possible, supercritical CO2 essential oils are used in the flavor creation. Let us take the example of ginger as a case study. In some research papers conducted by Jing Wang et al. At the University of Hefei in China, it has been shown that ginger essential oil exhibit a good antimicrobial activity. It acts as a preservative, as an antimicrobial agent against Escherichia coli and Staphylococcus aureus. All of you know that these two are the key pathogens which lead to foodborne diseases, which produce health concern globally worldwide. So Escherichia coli cause gastrointestinal infection, then urinary tract infection. It can damage some organs also, and in some cases it causes death also. Staphylococcus aureus produces toxins in the intestine that lead to foodborne illnesses. So these bacteria can be prevented by the use of ginger essential oil. So ginger essential oil, besides acting as a flavor, it can be used as a flavor that can signal the potential health benefits to the consumer as well. The same study has been given the same result in one study. Here, sugarcane juice was tried to preserve by using ginger oil and ginger oleoresin, and it was shown that the ginger oleoresin showed a good antibacterial, antifungal activity against foodborne pathogens, and a minimum inhibitory concentration for bacteria and fungi was 200 to 300 ppm. And here it is interesting to note that when ginger flavor is applied to any food product, maybe it's biscuit or beverage or any nutraceutical or any functional product, when it is applied to such food product at the concentration of, it's a usual concentration, that is 0.1 to 0.3%. When it is applied at this usual concentration, the amount of these bioactive molecules approximate equal to this figure, that is 200 to 300 ppm. So we can conclude that ginger is, besides acting as a flavor, it gives a good functionality in food, and that signal, that hint the potential health benefit to the consumers as well. A lot of studies have been conducted, and research is investigated, and these all studies show that ginger acts as a good immunity booster and can be used in various kind of food products. Besides immunity and besides biopreservative, ginger has shown a lot of health benefits, such as it lowers the blood glucose, it reduces pain, it has analgesic effect, it lowers uric acid level, anti-inflammatory levels are there, it increases body's immune system to prevent the COVID-19 outbreak, and Such due to such wonderful investigations, wide studies, there is trend of using such kind of flavors in functional food or in nutraceutical and even in some beverages and teas and some bakery products as well. So I will show some food products that has been recently introduced in the market with this kind of flavors which signal health halos. A sugarcane juice is flavored with ginger. Here ginger act as a flavoring agent and signal health halos also. Then some beverages are introduced in the market. Alcoholic drinks are there in the market. Even some bakery products like biscuits are introduced by some big market players because of the changing consumer preference, because of this green consumerism in the market. Then there are some lozenges or candies in the market. Beverages are there in the market. A lot of teas are coming flavored with ginger in the market. So there is a trend not only in ginger, but such trend is coming in various kind of other flavors. Like there are flavors associated with brain or cognitive health. Tea, if you feel to be relaxed, now we take the tea. Then there are dark berries, tropical flavors are there, coffee, chocolate, apple. Some flavors are evolving, such as herbal flavors are there, like eucalyptus is there, mint is there, chamomile is there. Then nuts and seeds, vanilla, these kind of flavors are evolving in the category of food product associated with cognitive health. Then the products associated with relaxation and sleep, these flavors are particularly flavored with chamomile and lavender. Most of us people associate lavender with only its fragrance or its color, but many few people know that lavender is taken internally. It's in very small dosage and it's approved as a GRAS list by FDA or FEMA or the regulatory authorities throughout the world. And so flavors based on lavender oil, chamomile oil are gaining importance in such products as they give some functional benefits to such kind of food products also. Emerging flavors in these categories are honey, vanilla, chocolate, and some evolving flavors are mint, dark berries, citrus, and other florals like that. Then some flavors are associated with immune system. In fact, most of the food products in the market that claiming immune support, they contain vitamin C source food product. So vitamin C is associated with citrus kind of flavors. Therefore, orange, lemon, citrus kind of flavors are widely used in such kind of products. Then there are some flavors like elderberry, tropical, honey. These are emerging and some flavors are evolving. This is just a generalized perception of the market trend based on the market trend, seeing the various products globally which are appear in innovative flavors. So this is about the trend, and this is all about my topic. Yeah, thank you very much. Yeah, thank you. Over to you, Chair, please.
Hello. Thank you, Mr. Uday Nayak. It was a very nice presentation and very, it was full of lot of information. So if you, is there any time we can take a very few questions, or maybe those who have questions related to this, all the presenters, they can meet them in person, or they can call them and ask, because there is going to be a next session probably, but we can take up one or two questions if it is genuine. So, and again, seeing the questions from the Dr. Prakash Shalami, like, what are the characteristics of ideal flavoring substances? That is, it's some basic question about it. If you can want to comment on this, what are the characteristics of ideal flavoring?
Yeah, yes, it's a good question. Actually, ideal flavoring should be appealing to the customer. See, the purpose of flavoring is not to add any nutritive benefit to the flavor. Its purpose is basically to add some aesthetic value to the flavor, to make the product pleasant, to make the product eatable by the consumer. A lot of pharmaceutical products are there which are very bitter in taste. So these syrups and this type of products are not easily consumed by the people. So the purpose of flavor is to make it pleasant. But nowadays it's trend that consumers are looking for some more benefits in their products. So besides flavoring, besides as an appealing aspect, they also look for some clean label, natural kind of ingredients in their food product. So ideal flavor should be, first of all, it should be pleasant, and then secondly, it's a natural, nature identical. This kind of flavors is this is consumer preference, in particularly due to the green consumerism in the market. But ideal flavor should appeal the consumer, should make the food product aesthetic to eat the consumer. So that is the main point while creating the flavor.
And another thing, like we want to know that what are the your company using what are the emerging flavors coming up?
Yeah, sure. We recently completed such orders containing chamomile flavor, which are used in lozenges, pharmaceutical product by some big corporates. Then lavender flavor in some tea kind of products, and we are giving ginger like that lozenges, pharmaceutical lozenges or food-based lozenges. So these flavors are we are getting more and more orders of such kind of flavors rather than traditional flavor of vanilla and strawberry and butterscotch like that. So this is the trend, and so these kind of flavors are demanded in the market.
Okay, just for my inference, I just want to know that what is the shelf life of the flavor? Like the flavor to develop, and then
yeah, it's a very good question. Again, actually, shelf life of flavor is usually, as per the regulation, we quote it at 1 year. But for 2 or 3 years, most of the flavors are stable. Means there is no microbial growth. There is no moisture in flavor, so there is no problem of moisture growth. And the flavor itself are preservatives kind of ingredients are there.
Okay.
So so far as question is concerned of shelf life of product, as per the regulation, we quote at 1 year, but it can be stable for 2 or 3 or more years as it is.
Okay, sir. Thank you very much. This many questions for you, and maybe if Akshita is around, there's 1 or 2 just clarifications from her, like. 1 minute, I will. One question was there, she has already answered. How do we ensure vitamin stability while cooking? And is that the fortification in the rice and other things? Is it the vitamin fortification or it is the iron fortification? Can you please clarify if Akshita you are around? Hello? Hello, Dr. Akshita, can you hear? Anyway, we'll send her the questions and seek reply later. There are a few questions to me about the high pressure technology. Is it suitable for inactivation of microorganisms? Yes, it is very much suitable. It has been shown that above 400 megapascal, it inactivates microorganisms even at a low temperature. So it is very much suitable. It can be inactivated. If we want to get a complete inactivation, we need to go at a high pressure coupled with high temperature for a shorter period of time. Another thing, there are several products available in the market, in the US and UK market, regarding treated with the high pressure processed one. And there, I have not shown here, there are several companies making high pressure equipment, starting right from the beginning with the 55 liters made by the NC Hyperbaric to Avomax, and there, it is another company, US Hyperbaric is making, and then Stanstead is making, and there are many companies making right from the laboratory scale equipment to the larger scale equipment. Only thing, capex is little bit higher, but operating cost is not very high for that. And we have made such kind of equipment at CFTRI, 100% made in India program. Cost of that equipment was 1/3 what is available in the international market. So suppose it was available For 2 liters vessel for 3 crores, what we have developed, it is only within less than 1 crore we have made, and it is functional at food engineering department at CFTRI, and people, we are working on it, and there's no problem in that. It does not have a many sophisticated features like advanced softwares and all, which even if the equipment is working, software will not allow a unit to work. We do not have many such kind of features, but we can take the pressure, temperature data, everything, and is sufficiently working. This was developed under the funding provided by the CSIR FTT project in collaboration with NAL Bangalore, because they helped us in getting the right kind of connecting with the right kind of people, and specification, everything was drawn by us, and it is working. And there are it's available, commercial equipments are available. Maybe we'll talk to Dr. Prakash Alami if he has something more to clarify.
Doctor, there is a question. What is the infrastructure cost? It's a ballpark figure of such cost.
Like if you go for a 55 liters, which is just sufficient to start a small company, it will be around 6 to 7 crores by NC Hyperbaric US. So it is little busy. We do not have incapability in India to make any kind of infrastructure here. Suppose there is a requirement for 100 high pressure processing equipment. What we have made one only, it is 1 crore rupees. Suppose we give a contract to L&T or something, it will be much lower. And they can, suppose we give a contract for 100 units, it will be much lower, and we can produce it at a much lower cost.
Okay, and does this high pressure damage means if we are lowering the temperature in processing, we need to go for high pressure. So does this high pressure has any harm on food product quality and like that?
The high pressure will not harm the quality, because high pressure unit is generally immersed in a high water bath having a very high heat capacity. So whatever sometimes heat is generated during the pressurization, that is called as a compressive heat, and that gets dissipated very quickly in the water bath or oil bath. So there is no effect of heat during this. Suppose we want to add moderate heating to it, we can heat that liquid outside the high pressure unit, and we can subject it to a moderate temperature up to 40-50 degrees centigrade. High pressure products are not available in India at the moment. Some companies claim in Bombay, raw pressery and all, but they never declared that it is a high pressure product. They have made it, they are selling it in the airports, raw pressery. They make a sugarcane juice, orange juice, and many juices they are selling. But they never declared that it is a high pressure process. I am also doubtful, because they do not declare, but the product is very expensive. 200 ml may cost around 400 rupees. And you will find it in the airports. And maybe some bigger canteens like ICFOST and somewhere other. Reliance may sell.
Yeah, right. Good. Yeah. So, shall we go for any question? There are a few questions. Shall we go for?
Yes, sir.
So, can such products prepared with high pressure can be stored at ambient temperature, or does it need a refrigeration or like that?
It is, what is happening in the high pressure, it does not lead to the complete inactivation, and spores are even active. So if we store at a room temperature, there is a chance that spores may develop again and spoil the product. So it is necessary, not the high pressure. Throughout the world, whatever, if you are using any novel technologies for the preservation of the food, even could be high pressure, pulse electric field, or any other technology, we need to store at a low temperature so that the microorganism should not repair and damage the food. And we are started working with a private company, and maybe the giant in the Bangalore. They want to study that kind of aspects. Can we store the high pressure processed food at a room temperature? We are working on it. We have some concepts to do it. I'm not able to divulge everything because we have signed a NDT with them. Maybe we are coming up with the proposal and we'll work on it, and maybe we can answer the question probably in the next ICFOST.
And there is question from Sangram Vandekar sir. So what is the mechanism of bacterial effect of ginger oil? Actually, actually it's related to me. Actually, ginger oil contains some bioactive molecules like 6 gingerol is there. A group of gingerols is there. The ginger like 10 gingerols, 8 gingerol. So 6 gingerol and gingiberine, these are the bioactive molecules, and these are lipophilic components, and these attack on hydrophilic compounds of the bacterial membrane and disrupt the bacterial membrane, and they occur the death of this bacterial cell. So a lot of literature, a lot of research is available on the mechanism of this ginger oil on bacteria, particularly Escherichia coli and Staphylococcus aureus for foodborne illnesses. We can go for that literature, means for the detailed mechanism of that ginger oil about such organisms.
If no more questions, we can close the session and go ahead with the next. Do you see any other questions?
Okay, thank you.
So I request Honorable Chair sir to thank. And
yeah, it is a matter of great pleasure for me to declare this session as closed now, and we have successfully completed this session very well in time, and maybe we are not able to give you a memento or the flowers. Maybe we'll virtually offer you the memento and the flowers, and we will declare this session as a closed. Anybody has any questions, please send it to us. We will try to respond to you. And if you are around Aurangabad or anywhere in the CFTRI, you can directly contact the Mumbai. You can contact the speakers. They will be helpful and they will be provide you the information about it. Thank you very much, one and all. And I thank the organizers for giving me this opportunity, to me as well as to Dr. Uday Nayak also for chairing and co-chairing the sessions. Last word, I leave it to Dr. Uday Nayak. Please, if you wish to say something.
Yeah, thank you, Dr. Rasgi. It was a very, very wonderful session despite some technical glitches, but we all are enjoyed the session. All the speakers were very nice, and we have become a wise person, I can say. It's a lot of information, lot of good knowledge we have gained through this session. Thank you, all the listeners. Thank you, all the speakers and Honorable Chair. Thank you very much.
Okay,
thanks.
Sir. Thank you very much.
I request the host to proceed for the next session.
Is Dr. P.V. Suresh and Dr. Nandini Shetty around, chair and co-chair?
Sir, there is a changes actually. Dr. Gridhar is the chair and my co-chair for this session.
Sorry. Then I request Dr. Giridhar to kindly start the session.
Okay, sir. Okay, good afternoon to all of you. I welcome you all for this technical session 17, oral presentation 6. So I am Dr. Giridhar, Senior Principal Scientist from CFTRA. And my co-chair is Dr. Suresh G. Sakre. First, I would like to speak about my co-chair, Dr. Suresh G. Sakre. He is the Principal Scientist and Coordinator for International School of Milling and Technologies, CFTRA Mysore. He obtained his engineering degree in food science, that is a BTech in food science, and he also did his course for FM floor milling technology, ISMT prestigious course in milling technology. And he obtained his PhD also in food science, and later he joined in CFTR as a scientist. He had very good experience over 19 years in the field of wheat milling, baking technology, and also industry association. And he had completed a good number of industry-related projects in milling technology, fortification, and nowadays he is very famous for fortification of wheat flour and other a good number of process technologies he has developed. And to his credit, he had more than 50 papers presented in national and international conferences, and 30 numbers of technologies also he has made. And he is a recipient of Best Scientist Award of CFTRI in 2016 and 17, and also an Outstanding Scientist Award in the area of food science and technology from Venus International Research Organ Foundation, and the Best Scientist Young Scientist Award given by the Society of Tropical Agriculture, and also a Young Scientist Award given by the AFSTI, especially the prestigious award in 2013, and also some CFTRI Technology Awards in 2012, and a silver medal for floor milling technology of CFTRI, and Best Poster Awards. So very accomplished person we are having here as a co-chair. Yeah, Dr. Suresh.
Yeah.
So shall I continue to introduce the number of participants also, or you would like to take it up?
Maybe if you allow me, I can do that one.
Okay. Yeah. If you want it.
Yeah. First, I would like to introduce the chairman. Thanks for the beautiful introduction. Dr. Gridhar P. He is presently working as a senior principal scientist and professor at CSIR CFTRI. He is also coordinator for ASASR Biological Science. He is having more than 22-year experience in research and development. A huge publication, I can say it is 185 publication he has published into the national and international journal. He has invited talks more than 35, 15 books chapter to his credit, 12 PhD students successfully guided and many in the pipeline. He is also having 9 patents, plus he is also having fellowship, like a DAD fellowship or Boycott fellowship from the Indian government earlier to his credit. And I must congratulate from this platform. This year he got the fellowship award of AFSTI fellow. So congratulations, sir, for prestigious fellowship getting for your contribution. So with this small brief introduction, I welcome chairperson, all the delegates to this technical session. With the permission of the chair, we have 5 talks, and I think 4 people are present for the talk. We'll go by one. The first talk, may I now request Amrita Ray. She is a MSc in Food Science and Nutrition. She has a couple of publications to her credit, and she is having 3 best paper or poster award that she has received at different conferences earlier. I think with this brief introduction, I request her to kindly give her presentation.
Thank you so much, sir, for the introduction. Am I audible, sir?
Yeah.
I'm
Amrita,
sharing my screen.
Yeah, Amrita, one thing, 10 minutes of time will be given to you, followed by 2 to 3 minutes questionnaire. Okay.
All right, sir. Yeah. Yes, thank you so much, sir. I hope my slides are visible, sir.
Yes, you can.
Yeah.
All right. This is Amrita Ray from CSIR CFTRI. My topic is quinoa germ, a nutrition powerhouse, its novel extraction process, characterization, and stabilization. I'll quickly introduce the grain. It is a pseudo-cereal adaptable to agriculturally marginal areas, and it is considered a superfood and being promoted for larger consumption. It's a good source of quality protein and has high lysine and threonine, which is usually a limiting amino acid in other conventional cereals, which makes it a potential alternative source for protein and future food and nutrition security in the wake of climatic change. And it is basically native to Southern America, but now being cultivated in India as well. The Protein content of the grain is around 9 to 16%, which is again very high compared to other conventional cereals, and it has got good amino acid balance along with an good amount of unsaturated fatty acids and high insoluble fiber and minerals. It has got many different health benefits to its credit, and I have given a few references here. I will go to the structure of the grain. This grain is very small, around 1 to 4 millimeter in diameter, and the peripheral embryo is basically surrounding the perisperm. It is in a ring-like structure inside the grain, which constitutes a substantial portion of the grain, which is again not common for other grains. And this portion is rich in different nutrients. So keeping this in background, we have decided to develop a physical dry process to extract this germ particle from the grain and with good amount of nutrient recovery and also the yield, so that this could be utilized as an individual functional component. This is our workflow where we have utilized polished grain and optimized it for tempering time and moisture and standardized the roller milling process to get 4 different fractions starting with germ. And further, we have modified the process a bit to focus on the targeted germ separation. In this graph, I can say that it is evident in the initial moisture conditioning that is around 10 or 12%, that is very low. The grain fractionation is not very good, but with increase in the moisture conditioning, the germ yield is visibly increasing, which is optimum at around medium moisture milling condition. But after that, it is again coming down, and this again reflects in the color values, where we can see the germ color yellowness value is increasing till medium moisture conditioning, that is 16%, and afterwards it is coming down because of the dilution of the component with other fractions. Our chemical analysis value shows similar trend, wherein we can see that for protein, the germ protein is increasing from 12.55 to 30.85% with increase in moisture milling conditioning, and afterward it is again going down, and similar trend is visible for fat and minerals as well. So with this, we can conclude that germ is being fractionated at an optimum moisture conditioning, that is medium milling moisture. And this is our final workflow, where we have utilized this conditioned quinoa to go through the break system. At the first break, the germ is released from the grain, and in the subsequent 2 break system, the perisperm is being scraped out from the bran. At the end of the break system, we get the bran separately, and the rest of the intermediate fraction goes to the reduction system. In between, we have incorporated an aspirator to remove the residual bran that was contaminating the intermediate fraction, because of which, with only 1 reduction roll, we have got good germ flakes at the end of reduction process. So I can say that this process is a dry and physical process, which is also industrially scalable. This is our intermediate fraction photograph, wherein I can say at the beginning of the first break, the germ has been released, and at the end of reduction system, the germ flakes are formed. This table actually shows the comparative study between the manually extracted germ and our germ that we have extracted from the roller milling process that we have developed. Now, to compare the two, we have checked for the yield and other nutrient content. I can say the recovery of the yield is more than 80%, with more than 80% recovery of all 3 components, that is protein, fat, and ash, which concludes that our process could successfully extract the germ as an individual functional component, which is having good yield and purity. Now, further, to establish it as a functional component, we have done our functional characterization of functional and nutritional characteristics. The bulk density and solubility index are found to be higher in this in the germ than the whole quinoa flour due to its high protein content, and the same protein content also causes a good gelling power at around 16% level, whereas the whole quinoa flour makes a strong gel at around 22%. So this germ can be utilized as a gelling agent. For amino acid profiling also, we can say that there are a good amount of essential amino acids present in the grain, with a special reference to lysine and threonine. And the fatty acid composition says that it has good amount of high unsaturated fatty acids. So germ can be considered as a concentrated source of nutrient. And we have checked for total polyphenol content and antioxidant activity, where the germ shows higher antioxidant activity than the whole flour, and so is the mineral content, which has enhanced in the germ than the whole as compared to the whole quinoa flour. But with this being a nutrient dense component, we have one drawback of the germ being high in fat, which further hinders its shelf life. So we have decided to stabilize the germ to get a good shelf life for this. And we have utilized microwave and infrared treatment. We have taken 3 different microwave treatment, namely MRT 1, 2, 3, and 2 infrared treatment, that is IRT 1 and 2. The influence of the treatments on our germ has shown to reduce the lipase activity from 50 to 70% in all the samples. And further, we have taken a moisture sorption study to predict the shelf life moisture sorption study, where we have seen that till 64% of relative humidity, none of the samples have shown any mold growth. This is a isotherm sorption. It's a sorption isotherm curve where it is showing a sigmoid type curve, which is very common for cereal or other food ingredients. And after 65% of RH, it has gone up immediately, which kind of refers to the deterioration of the sample after that RH level. And a critical moisture content for all the fractions were found to be between 10.16 to 10.67% here. And with this data, we could predict a shelf life for both accelerated and ambient condition of our samples at a particular gram of samples with a specific packaging material. Now, to evaluate the software's program, we have actually done the shelf life study in accelerated condition, where we can see that over a period of time, all the samples has shown decrease in its brightness value and increase in redness value, which might indicate to the deterioration of the samples. And at each withdrawal, we have checked for water activity and moisture content, and we can say that for all the different samples, we have got different days of critical moisture content. That is 60, 75, and 90 days for MR 1, 2, 3, and 60 and 75 days for IR 1 and 2, which also is comparable to the data that was predicted by the software. We have also done our free fatty acid and peroxide value estimation during the storage period. I can say that the treatments had a significant influence of the free fatty acid release, where we can see that the control is much high, has released much higher free fatty acids than the treated samples, and the peroxide value has also shown to decrease in the treated samples. So with this, I can say that in the accelerated condition, in accelerated condition, the shelf life study that we have done has given around 60 to 90 days of shelf life for our germ, which is also comparable to the shelf life that was predicted by the software. This is a conclusion in general of my work, where I can say that quinoa germ was taken and for fractionation, and we could develop a novel unique model of processing for separating out the quinoa germ from the grain, which has above 80% of purity. And with the microwave treatment, we could stabilize the germ for further industrial utilization. The stabilized germ that we have now has got twice the protein and mineral, thrice the fat, and also it can be utilized as a food and pharmaceutical, as a functional ingredient and in food and pharmaceutical industries, that it has got enhanced shelf life now, and it has got good nutritional and functional characteristics. I'll end here. Thank you for your time.
Okay, thank you. You have completed almost within time. Okay, now if there are any questions, can you continue, Dr. Suresh?
Hello, sir.
Do you have any queries?
No, sir, you can go ahead. I think take the question from chair and co-chair. Other delegates can post their question, and that will be taken at the end of the session.
Okay. Okay.
Go ahead,
so,
sir.
Yeah, I can go ahead with 2 more questions. So, in generally compared to wheat germ, how much percentage this quinoa germ comprises in the seed?
So wheat germ will be at around 2 to 3% only, whereas quinoa germ reports to be around 25 to 30%. And even in our study, the roller milling process, we have got around 22% of the germ, sir.
Okay, okay. And you have mentioned somewhere that it also contains some oil content. How have you you said that unsaturated fatty acids were present in good quantity. Have you compared the saturated to unsaturated fatty acids ratio?
So we have done a GCMA study for this. From this, we have got palmitic acid as one of the saturated fatty acids, but most of them are unsaturated, like oleic, oleic, linoleic, and alpha linolenic. And sir, according to the reports, almost 88% of the fatty acids are unsaturated. Only 10% that is saturated.
Okay, okay. Because why I'm asking this question is, in case of wheat germ oil, the triglycerides are pretty high and they are not healthy. So in that context, I have asked.
All right, sir. But in yes.
Yeah, yeah. Okay. And the commercially, this what about the commercial status for this quinoa germ-based products? Are there anything available in the market?
No, sir, not yet. Quinoa germ has not been explored much, sir. Quinoa grain as such is being utilized, but not the quinoa germ. So, which was the background of our study, sir, where we have taken out this component, which is a nutrient-rich source, which could be utilized as a functional nutrient-dense component, sir.
Okay. What will be the percentage of carbohydrates, proteins to lipids in this total? In the germ,
in the germ?
Yeah, compared to rest of the seed.
Compared to the, sir? Whole grain?
Compared to the whole grain, yes.
Sir, in the whole grain, the protein is around 16%, but the germ we are getting, it is around 30% of protein. The fat in the whole grain is around 5 to 6%, whereas what we are getting is around 18%, sir.
Okay, very good. Okay, very nice presentation. Okay, Dr. Sakare, over to you. You can continue with the next part. Yeah, Dr. Suresh.
Yeah, thanks for your good presentation and taking us around the grain and developing a good process. I request you to kindly take out your presentation so that we can ask for the next presenter.
Sir, I have escaped actually, but is it still showing my presentation?
Yes.
It is still showing. So
is it?
Yeah, now it's okay. Yeah, now you can unmute yourself.
Sure, sir.
Now it is the next presenter. Next presenter is Miss Sonal Tiwari. She is also from CSIR CFTRI, and she is MSc in Bio. She has having a ICMR Senior Research Fellowship to her credit, under which she is presently working. She is having few publications to her credit, and her area of specialization is algal biotechnology and other things. She has presented poster at national and the international conferences. So with this small introduction, I request Ms. Sonal to add with her presentation, please.
How to? Okay. Okay. Tell I want to present. Sir, I want to present. Please allow me for slide share screen.
You are not able to share your screen?
No, sir.
Okay, I request the host to kindly help her to, or kindly allow her to present her or share her presentation.
Bodhankar team, kindly just enable her for sharing.
Yes, sir. Now she can share her. She is the co-host. Now she can
Thank you.
share her host.
Could you do it? Yes, ma'am. Ma'am, for video how?
Yes, go ahead. We can see your slides.
Screen more you can put.
You have to unshare it and stop sharing. Yeah. Okay. You go here. Click here. Okay. Now you share it again. Go to PowerPoint. Okay.
Good afternoon, everyone. I'm Sonal Tiwari, ICMR SRM, working under the guidance of Dr. Vikas Singh Chauhan in PCBT Department, CSI, CFTRI. The title of my this presentation is Effect of Sodium Azide on Cell Viability and Photosystem Cycling and Estrogen Accumulation in Hematococcus pluvialis. Now, what is the astaxanthin? Astaxanthin is a ketocarotenoid. It's also considered as a super antioxidant. It has the wide application in food, nutraceutical, and pharmaceutical industries. Nowadays, the astaxanthin market is day by day increasing, and it's expected to the compound annual growth of the astaxanthin will be increased by 8% in 2022-27. So now there's a fill gap between the demand and supply. So there's a necessary to rise the new research in new techniques for the production of astaxanthin and new source for the production of the astaxanthin. In this case, the Haematococcus pluvialis, this is microalga, which is already known as the richest source of natural astaxanthin. And it enhances the astaxanthin accumulation in abiotic stresses. But in industrial level, the astaxanthin production in this alga by using the LED light source. But using the LED light source is increasing the manufacturing expenses. So now it is a focus that what is the important. We have to search some new method and new abiotic stressor which increase the astaxanthin accumulation in Haematococcus without normal light condition, in moderate light condition. For that, we have to explore some other chemical method to enhance the astaxanthin accumulation in moderate light condition. Whereas the sodium azide, which is the inhibitor of respiration, photosystem second, and it widely used in agriculture for pest control as a mutagen. So we thought it can be used as an abiotic stressor for using for the astaxanthin accumulation. On the basis of that, we decided that our aim that we have to investigate the different concentration of sodium azide in Haematococcus for accumulation of the astaxanthin. In that, we also check the photosystem second parameter and oxidative stress in the correlation between the astaxanthin accumulation in the abiotic stress. Now we have to go Mattel's method. For that, first, for this alga is grown in normal light condition and normal media, and then after this alga reaches the maximum growth phase, that OD reach 1, then we inoculated this alga in different concentration of sodium azide in stationary phase, because in stationary phase only the astaxanthin accumulation is happen. In that condition, we check the cell viability through the MDT test and oxidative stress through the DCR dye method. Also, we check the photosystem second parameter through the PAM fluorometry. The astaxanthin content also analysis through the HPLC chromatography, and fatty acid profiling also we did through GCMS. Now result, the first figure is showing that microscopic pictures of the Haematococcus. The first A is showing the growth phase of alga. In that the alga will be look like a pear shape. The second one is when the cell is reached to the stationary phase, is change in the cyst form. The third image is showing that when alga started the accumulation of astaxanthin in the abiotic stress condition. So the last image is showing that in the condition of 1 millimolar concentration of sodium azide. The second one figure is showing the viability of cells in different concentration of sodium azide. As we've seen, the higher concentration of sodium azide is inhibiting the mitochondrial function. It is inhibited by the 1.7-fold. But when we're giving the 1 millimolar concentration of sodium azide, that viability is 90% cell survival. The same as in the oxidative stress, when the concentration is increasing of sodium azide, the ROS level also increasing. For that, also we check that 1 millimolar the sodium azide only increasing the ROS level 1.8. We also checked in media how the sodium azide is decreased day by day. At primary axis, we kept the lower concentration of sodium azide. We seen that when day is passing, the sodium azide concentration is decreasing. But in higher concentration, after the 6th day, there is no significantly changes in the sodium azide concentration. Now we have to discuss about the photosystem second parameter. In this, first is showing the ABS by RC. This is the average antenna size. This is the light harvesting complex which transfers the energy from chlorophyll to the reaction center of photosystem. In the stress condition, the antenna size will be increasing. Our data suggesting that in the higher concentration of sodium azide, that antenna size increase by 8-fold. And the second one, the results suggesting DIO by RC. This is dissipation energy. This energy will be released during the photosynthesis. So this energy also increase when we're giving the higher concentration of sodium azide. But there's the lower concentration, there's no significant changes in the dissipation energy. But in the 1 millimolar sodium azide concentration, that will be increased to 2.8-fold increase in dissipation energy. When we see the photosynthesis efficiency and electron transport rate in this different concentration, it also shown that higher concentration of sodium azide inhibiting the electron transport system very significantly. But till 1 millimolar, it decreased by only 0.8-fold. Also, we check the astaxanthin content in the different concentration of sodium azide. In that, the sodium azide is increased till 1 millimolar and it increased by the 2-fold as a control. Also, lipid content also increased 1.3-fold. We check that HPLC chromatograph showing that confirmation of the astaxanthin. The figure 9 is showing the fatty acid profiling of the 1 millimolar concentration sodium azide treated sample. In that, the profiling is not changed as compared to control, but the PUFA content increased by 2-fold. In that, EPA observed in 1 millimolar concentration of sodium azide. Also, we confirm the astaxanthin through the FKR analysis, through qualitative analysis. In that, we first this spectra is showing that pure astaxanthin is standard spectrum. The second one is showing our sample carotenoid extract. It is fully similar to our standard spectrum. So our studies concluded that our studies proposed that result the astaxanthin accumulation abiotic stress is correlated with the photosystem second parameter. In that, sodium azide also is correlated with the sodium azide concentration. So in that, I read some literature. In that, they are telling that one complex is there, oxygen evolution complex, which always present in the photosystem cycling, and this complex active in the presence of chloride ion. And some other literature it is suggested that sodium, when in the presence of sodium azide, the azide bind to this complex instead of the chloride ion. So we hypothesis that when we are giving the azide in different concentration, when we are giving the lower concentration of sodium azide, the azide is doing the competitive inhibition with the chloride ion. So it inhibiting in the limited moderate condition. So the electron transport rate is decreased by only 0.8-fold. But when we giving the higher concentration of sodium azide, the azide ion fully replace the chloride ion and fully block the this OEC complex. And that's why that electron transport fully decreased. It came 0.0001. So it decreased by very significantly. And that's why the cell death also happening. And the lower concentration is that electron transport rate is decreasing, and that is initiating that this oxygen inhibition, and that also generating the singlet oxygen, that giving the ROS. In ROS condition, that astaxanthin accumulation is happening in lower concentration. But in higher concentration, that ROS production is very high, and cell that is happening. For that only the astaxanthin accumulation is decreased. So our conclusion of this study is that lower concentration of sodium azide is effective in enhancing the astaxanthin accumulation hematococcus. Also, it giving the relationship between the photosynthetic down-regulation and increased level of photoprotection, suggestion about the further supported by the fact sodium azide exposure increase the ROS, thereby inducing astaxanthin as a defense mechanism. Also, our study possibility say that wastewater containing the sodium azide can be enhanced the astaxanthin production, and which can be reduce the cost of process. And this study showing that there's a need to be improvement some cultural condition, and we have to better understand the astaxanthin biosynthesis pathway regarding the photosystem, and we can use some other chemical also for enhancing the astaxanthin for the industrial production. Thank you.
Yeah, thank you, Sonal, for a nice presentation, and you have explained very nicely the mechanism lying behind this study also. So I have a couple of questions. Generally, sodium azide is considered as a mutagenic, okay?
Yes.
So, but you have used it in your study against this hematococcus, and you have demonstrated cell viability also.
Yes.
So, can you clarify this aspect? Did you find any such changes in the cell structure or shape? If not, what could be the reason?
Sir, actually it is a mutagen, but it will be muted if we regularly be doing the same stress. But we are giving this sodium azide in the stationary phase. We are not giving in the growth phase. In the stationary phase, it will be not cell will be not that much active form, so it will not changing the mutation. And we are using a lower, if in our study size lower concentration. And a previously study which is done related to the plant, they are telling it till 50 millimolar concentration, it's not changing that much mutation in their plants. So we use the lower concentration only, so it is not happening, that mutation is not happening in that, only giving the stress conditions.
Okay. And in one of your slide with reference to the astaxanthin production, I have noticed a concentration dependent response, where the highest concentrations like 10 millimoles, the production of astaxanthin or content is almost equivalent to the control. So is there any specific reason for this?
Sir, actually, in stationary phase, astaxanthin accumulation is happen, and we are giving the abiotic stress. But in the 5 millimolar concentration is high. The astaxanthin is accumulating, but because of it is lethal concentration, so cell viability is decreased, cell death is happening. That's why the astaxanthin is declined, because cell number is decreased. It is not that astaxanthin is not accumulating; it is happening, but cell viability is decreased. That's why the astaxanthin concentration is come to the control level.
Okay. Generally, when we are using this sodium azide, there is a term called saturation flash.
Yes.
Have you heard that one? Yeah. Whether that particular saturation flash based mechanism is also relevant in this particular observation or not. That's why I asked that question.
Okay.
Okay. And is there any rate limiting step with reference to the astaxanthin production in this one? Do you anticipate? Of course, you have not done any molecular, biosynthetic pathway wise
Yes,
how
sir.
astaxanthin gets regulated, but just I am asking out of curiosity. Is there any rate limiting step possibility is there in presence of this sodium azide treatment?
Sorry, I'm not getting your question.
No. For example, whenever you apply this, it's also like a treatment what you have given sodium azide like that. Okay. So you have correlated that with the constant at one particular concentration, this astaxanthin detection or fold increase is more. Okay. That
Yes.
means either some sort of upregulation might have happened in that conditions. So are you going to attribute that there is some rate limiting step possibility is there in presence of sodium nitrate, sodium azide treatment or not? That's why I'm asking. Or it is like any indirect phenomena or direct phenomena? Okay, that's why my question. That is my question.
Sir, actually, I did for regarding only photosystem parameter phenomena only, because it's mainly is bind with this oxygen evolution complex that I read in some literature. But nobody did the study regarding the concentration matter, how it is happening and why it's happening. So that's why I'm not gone through that one. I just read about the aspect of photosynthesis parameter only, how it is affecting the photosystem.
Okay. So do you mean based on this study that your sodium azide treatment could lead to what is called oxidative phosphorylation inhibition?
Yes.
Okay. That is what you have demonstrated in this one.
Yes.
Okay. Thank you. Very nice piece of work and a good presentation. Over to Dr. Co-Chair, Dr. Suresh.
Yeah, I have one question. Basically, when you talk about you have mentioned somewhere it is the low in cost of production. So just I wanted to ask, what are the other methodology that is available for astaxanthin extraction, and then what you are showing, how it is going to be a low in production, or what could be the advantages of using the sodium azathine for the factor which is going to help commercially. So this is my question.
Okay, sir. Actually, if we see regarding the stress condition, I already told in the industrial level, they are using the light source. So for light source, the cost is like 1 kg biomass production is giving the 8,000 rupees per kg. When I calculate regarding the sodium azide, it is required only 6.5 gram for 1 kg production of sodium azide. Sorry, astaxanthin accumulation. So it is only 6.5 rupees. Only 6.5 rupees you need, because the sodium azide will be available in 1,000 rupees kg. So if you use 1 kg production of biomass from sodium azide, astaxanthin accumulation, it requires 6.5 rupees. So it reducing the cost of. Also, one more thing I checked, which are not present in data, we checked that bacterial contamination also. Sodium azide inhibiting the bacterial and fungal contamination also reducing. So it is industry level, where when we are going in the outdoor cultivation, is reducing this very problem nowadays for cultivation is bacterial and fungus contamination. So that is also reduced by this concentration. That also I observe in my study, which data is not here, but for that this question I just told, it reduced the cost of in the industrial level.
Okay, thank you for your presentation.
Thank you, sir.
Yeah, we will go to now next presenter. So next presenter is Miss Subhashri D. She is from the Niftam Tanjavur, and she is going to talk on 3D printing of plant-based meat alternative source from the indigenous sources. She is working as a senior research fellow at Tanjavur. She is having the qualification M.Tech in food technology. She has area of specialization in molecular cloning, plant-based functional foods. She has having 3-year experience of research, 5 research articles and 3 chapters. With this, I request Ms. Subhashri to go ahead with her presentation.
So good afternoon, sir. Am I audible?
Yeah, you are audible. Your slides also
Yes.
visible.
Yes, sir. Good afternoon to everyone present here. My oral presentation is on 3D printing. Hello, sir.
You please show your full screen mode. Your slides, you put it in full screen mode. F5 with a press.
Okay, sir.
Yeah. No. You have to.
Sir, is it fine now, sir?
Yes. Then continue.
Yes, sir.
Yeah.
Yes, sir. My oral presentation is on 3D printing of plant-based meat alternative from various indigenous sources. Why alternate meat? As we all know, addressing climate change is the very need of the hour. We all know that rearing of livestock and processing of meat has large impact on greenhouse gas emission from the feed production till digestion, manure, and till transportation. And one more reason is the continuous increased supply for meat and the growing population. There are several approaches to mitigate that, but on the other hand, one such solution can be slight modification of human diet to include plant-based meat extenders with red meat, which can hold a huge potential in addressing this issue. What are the drivers of plant-based protein market? As we all know, this protein market has been a tremendous increase rate. The growth from 2019 to 2020 is almost %. Some of the drivers include instances of intolerance for animal protein, increased big population, new consumer aspirations, significant investments in plant-based companies. There are several methods in the production of TVP, such as extrusion, spinning, and simple shear flow. During all these processes, an internal structure alignment formation is observed based on the material supply. The development of acceptable texture in analog is often the biggest challenge faced by the producer. A typical meat analog consists of water, protein, lipid, polysaccharide, fibers, flavoring ingredients. Protein functionalities such as water and oil holding capacity, solubility, emulsification, foaming, gelation are essential conditions for meat analog formation. They are dependent on the various types of protein. We all know that the supermarkets and online stores are filling with various commercial products like from sausages, burgers, till chicken nuggets and popcorns. From earlier years, we have the alternatives like tofu, tempeh, seitan, etc. Nowadays, companies like Beyond Meat, Evolution Meat, Redefined Meat, Impossible Foods, etc. are concentrating on production of meat analogs, various meat analogs, including seafood, from protein, fat, carbohydrate, and fiber. The main point is they are using isolates and concentrates. In this study, our main research focus is to develop a 3D printed, plant-based, soy-free, gluten-free, conveniently producible, affordable meat alternative. Because several people have gluten intolerance and some are allergic to soy, in this study, we have concentrated on soy-free and gluten-free product. The methodology of the study include study on several native protein sources for the different protein content. The selected protein sources were studied for their printability using an in-house developed 3D foot. The printing material supply was further analyzed for its thermal, functional, and rheological properties. Various compositions were studied and the influence of hydrocolloids and certain oil seeds on printability was evaluated. The texture of the printed plant-based product was studied in comparison with other meat analogs. As from literature, we know that Pulses are very rich in sources of protein, essential vitamins, and minerals. They exhibit functional properties like foaming, emulsification, water holding, and gelation. Pulse proteins have essential amino acid and they're also gluten-free, which is safe from people for gluten intolerance. They have major storage proteins in the form globally. Vicillin and leguminase are the major in mung and faba bean. To design and print a proper meat-based product, the printability and protein content of various indigenous sources should be considered. The printability was performed through extrusion supported by a controlled air pressure system. Among them, mung and faba showed better printing structures at the printing conditions of 1.2 mm nozzle diameter, 4 to 5 pressure, under the printing speed of 300 mm per minute. The mung and faba composite was added with additives like gum arabic, sunflower, pumpkin, and chia, it was found that all the 4 composites were printable under the same printing conditions. When the rheology of the ink was studied using a rheometer and a parallel plate geometry, it was observed that with a decrease in viscosity with increased shear rate. This result explained the shear thinning behavior of the material supplied. The DSC composite class indicated the thermal stability. DSC is performed with heat rate of 10 degrees Celsius per minute from 20 to 200 degrees Celsius. The result was found in concordance with previous studies stating that the unfolding of native proteins is between 70 to 100 degrees Celsius. The secondary structure of proteins can be estimated using FTIR. It was found that the printed sample contained both amide 1 and amide 2 regions. The protein content of the printed products were estimated using gel method. It was found that the protein content of mung faba gum arabic was 24 and mung faba chia was almost near to 23.87%. Variation of fill pattern can lead to differences in texture. It was found that in this study, 100%, 75% and 50% of fill ratios were experimented. It was found that in mung faba gum, 100% fill ratio had better structural stability, whereas in faba sunflower and pumpkin, 75% infill had better structural stability compared to 50%. The 3D printed samples were steamed at 80 degrees Celsius for 2 minutes before textural analysis. The textural analysis showed that the hardness, adhesiveness, gumminess, and chewiness of the post-printed sample were determined. In this result, it was found that mung faba pumpkin, mung faba sunflower texture was almost similar to the control alternative. This ongoing research work, this study concluded that mung and faba bean flour can be considered for 3D printing of meat alternative based on their protein content and functional properties. The material supply exhibited shear thinning behavior, and the texture of the soy-free, gluten-free 3D printed plant-based meat alternative was similar to conventional meat alternative. Additionally, varying infill percentage was found to have a positive impact on the textural profile of the 3D printed meat alternative. Further, the amino acid analysis and food digestibility of the 3D printed samples have considered. Thank you.
Okay. Now, before I hand over to the coach to continue, from the consumer's sensory acceptability point of view, so I have one question. Generally, in this 3D, of course, we are using plant substitutes or ingredients to make this 3D printed meat alternatives. But regarding the taste and mouth feeling wise, what would be the consumer's sensory acceptability preference or like that?
Sir, we know that 3D printing of meat-based alternative will give you the fibrous layer-wise structure compared to your meat. Meat is generally fibrous. The animal protein is different from plant protein. But by using plant proteins, we are trying to mimic that fat-like mouthfeel from the lips. When we're using oil seeds, that flavor can be attained to some more meat-like texture and flavor.
Okay. So if so, generally it takes, I heard that it takes a long time to complete on 3D print to make a beef steak type imitated plant-based thing. If that is the case, that means the time is one constraint, and there are certain other limiting factors like the material what we are using, the complexity of the model, generally what we adopt in making this 3D print. All these matters a lot. So, if from this point of view, how does the cost matter from this 3D printing based?
Sir, in this case of our research work, we are not going for protein isolates or concentrates. We're using the whole plant-based composite as whole. So by economy, we are using the, and in case of printing, this design as such is printing speed is around 300 mm per minute. So based on that, as time is one constraint, but it is still feasible in a pilot scale.
Okay.
Yes.
Okay. Over to person, Dr. Suresh.
Yeah, thank you, sir. It was a really nice presentation. I have some few questions. You talk about gluten-free.
Yes, sir.
What is meant by the gluten-free?
Sir, not using wheat or any soy while during 3D printing, because if wheat only, the gluten will not be there. So here in our case, we are using only pulse proteins, which are mostly composed of bacillin and leguminous. So we are claiming it as gluten-free.
But if I want to tell a product as a gluten-free, what is the requirement by FSSAI?
Sir?
What is the requirement from the FSSAI or the government body when I am calling it as a gluten-free?
Clean label, all analysis should be done accordingly.
How much gluten is allowed?
No gluten at all. No gluten at all.
There is a some FSSAI standard. They says if gluten-free means this much, below this it should have the gluten content.
Yes, sir. But since we are not using, so we are telling it is not.
Yeah, but you should know it as you are claiming that it is gluten-free. So any product, when you are talking the gluten-free, 20 ppm and below, they should have the presence of gluten in that one. Below that. Okay, that could be contamination during your processing, or even though you are telling maybe the equipment or the processing or your product contamination.
Okay.
That's one
Yes,
thing. The second thing, as you told, this is by the 3D printing, and generally whatever the meat analogs are available into the market, it is from the extrusion technology.
Yes, sir. Yes, sir.
So, as sir has told, how it will be cost effective. Okay, that is the one thing. And then as if you take a soya protein, it will be again a protein source which is cheaper in rate. So if you cost of the soya protein is very, and then you are using some other pulses, which will be very costly. So it could be the cost of raw material plus the cost of production. How you are going to justify that?
So likewise, as I told, since we are aiming for soy-free, because some people may be allergic to soy, and there are several existing products on soy-based meat alternative. Here in this case, since we are not using isolates, concentrates, we are cutting down cost of purification, production of protein concentrates there. So the economy will be reduced in that part. So more and concentration should be done on 3D printing, the feasibility of how to scale up it to a large scale.
Okay, thank you.
Thank you, sir,
for your presentation. It was a nice presentation. Now we have the last presentation. We have the last presentation from Ms. Kokoli Pegu from ICT Mumbai, and she is going to talk about the application of hydrodynamic cavitational effect with different orifices of milk preservation. She is having 5 research publications, 3 chapters, to her credit. She's M.Tech in Food Engineering and Technology. Now I request her to kindly go ahead with her presentation.
Hello everyone. Thank you, sir. Thank you, Suyash sir, for the introduction. And welcome to my presentation. I'm Kakoli Pegu, and I am a research scholar in food engineering and technology in ICT Mumbai. My presentation topic is application of different orifices for hydrodynamic cavitational effects in milk preservation. So here the novel approach is utilization of hydrodynamic cavitation technology for processing of milk for the purpose of preservation of the milk. So let's look into the overview of the presentation. First, I will start with the introduction, where I will give a brief discussion about the milk as well as the new technology, that is hydrodynamic cavitation, and the materials and methods used. Secondly, we will go for the materials and methods used in the experiment and the results and discussion of the thirdly, we will go to the results and discussions, where we will discuss about the outcome of the experiment conducted, and lastly I will summarize it. So coming into the introduction part, see, milk production in India is contributes about 18.5% of the world production, and it ranks first. And previous year, like 2020 and 2021, it is seen that about 5.6% of the production has been increased in India. So as far as in the pictorial, we can see that milk contains of various essential nutrients, that is protein, water, sugar, fat, mineral, these which helps in which act as a primary source of diet for the growth and nourishment of infant mammal, and act as a vital source of energy intake for adults. But at the same time, these nutrients present in the milk, as well as the physical properties, that is the specific gravity and pH is 6.7 to 6.9, which gives a suitable environment for the microorganism to enumerate. So the properties of milk makes it either a positive as well as bad, positive as well as negative thing. So when we are talking about milk quality, then the milk quality is dependent on the chemical reactions, physical reaction, biochemical reactions, and microbial reactions. Here in this presentation, the carried out experimentation is on microbial reactions, mainly on the pathogens, and the source of contamination for microbial is from the environment, the feed, the cow feeder, and the milking equipment. Going forward, the main question is why we need novel technology. As in the earlier session, Rastogi sir have described about the need for the novel technology. Adding up to that, despite the advantage of the heat treatment for killing microbes as well as enzymes in the milk processing, it does cause adverse changes to the flavor, color, and nutritive value of the milk. So the need, again, the need is like industrial demands for more consumer demands. So industrial, what they demands is, they demands for economically processing technology, non-thermal treatment, long shelf life, natural like processed product, and consumer, with the consumers demands minimal process, additive free, highly nutritious, natural, and longer shelf life. So in considering novel non-thermal technologies, it has been seen that in the scalability as well as the efficiency of the technologies, hydrodynamic cavitation has been shown to be better in comparison with other novel technologies such as the microwave, pulse electric field, ultrasound, and plasma. So let me introduce what is hydrodynamic cavitation is. Hydrodynamic cavitation is similar to that of the ultrasonication, but the medium for the generation of the cavities is in here is the pressure difference as well as the simple geometry used in it, like Venturi throttling bulb, single and multiple hole orifice plate. In the diagram, we can see that the cavities are generated when the static pressure is reduced
reduce and falls below the liquid vapor pressure in the vena contracta of the cavitating device, then the cavities generate nucleus are formed, expansion to the maximum radius, and collapse with the recovery of the downstream pressure. So this is basically the cavitation phenomenon. And coming to the materials and methods, we have used two strains, that is gram-negative bacteria and gram-positive bacteria. Gram-negative is the E. coli, and the gram-positive that we use is the S. aureus. So in the first of all, we have recovered it from lyophilized cell and is inoculated in known amount to the milk, that is 10 to the power 6 CFU per ml per 3 liter of the milk. So here is this is the cavitating device we have used, the cavitation hydrodynamic cavitation machine used. So here this is the tank where we put the raw milk. Here we are using actually not the raw milk, we are using sterile milk, UHT treated milk, 3 liter of each UHT treated milk, and then we are passing through it and passing through this line and going to the cavitating device. Here it comprises of this is the main line and this is the bypass line, and here the cavitating device is placed here, that is orifice plate is placed here. How it is like flowing, I can show the video. So it will be passing through the tube, and this is the cavitating devices we have put in that, and the flow of that. The actual collapse of that is not shown here, but in here the collapsing bubbles, how it is, the collapse of the bubbles where it produces localized pressure about 100 to 5,000 bar and temperature 500 to 15,000 Kelvin and millions of locations. And due to this, there is a generation of physical effects as well as chemical effects, giving in the physical effects which it gives Sox waves, liquid microjets and interfacial turbulence, and in the chemical effects it gives the free radicals, which these physical and chemical effects break down the cell wall of the microorganism, break down and releasing the chromosome, just deactivating the microorganism. So, and these are the 4 plates we have used of different diameters, and the flow geometry, orifice 1, orifice 2, orifice 3, orifice plate 4. So it has different diameter in it and geometrically different diameters, and it has given, the table 1 gives us the flow geometry of 4 different orifice plates. So here we have to look onto the alpha value and beta naught value, which is an important parameters for the orifice, which gives the shear layer, which accounts to the shear layer of the cavitation, and beta naught, which gives the scale of turbulence affecting the cavitation intensity. And at the same time, this is the table 2 is of the flow characteristics of 4 different orifice plate. So in here we have with the input of pressure, increased input of pressure, the flow rate as well as the orifice velocity increases, but the cavitation number decreases. Here the cavitation number is an important parameter where it gives the cavitating intensity, which defines the cavitation intensity. So higher number of cavitating intensity, it has to be in some range, because higher number of cavitation number gives the bubbles, generate the bubbles, but it doesn't collapse, it just keeps on oscillating. And in the reduced, when the cavitation number is very less, it also has a cushioning effect, we can call, which is because of what called large generation of bubbles, due to which the cushioning effect occurs. So in order to have a proper inactivation, we need an optimization for that. So in the optimization process, what we have done is we have used an RCD response surface methodology was applied, and two independent variables were selected, that is pressure and dwell time, pressure from 3 to 7 bar and dwell time for 5 to 40 minutes. And this was used to generate a quadratic polynomial model for these responses. The responses we considered were inactivation of E. coli and inactivation of S. aureus. And a numerical optimization technique was applied in order to optimize the process parameters for obtaining process sampled with desired response. And the process was mainly aimed at overall desirability function, achieving maximized overall desirability function, and the equation is given as follows. The relative importance was given to each response and its desirability was computed. As a whole, we have targeted the maximum inactivation of E. coli and S. aureus and a minimal impact on the temperature. Constraint limits and relative importance of study parameter were decided according to the desirability of the properties. So here is the results, and coming to the results and discussions. Here I have detailed in the table 3, detailed the coefficients of all the polynomial model, quadratic polynomial model. Yes?
Yeah, actually you have crossed the timing. It is the 10 minutes is over.
Just give me 2 minutes, sir. Just 2 minutes.
You can go to the conclusion because time is one of the parameter for the evaluation.
2 more minutes. Okay, the time had complete.
Yeah, 2 more minutes here. Yes, 2 more minutes.
Yeah.
So all the developed models possess a R square value and adjusted R square value, which is more than 0.885. So it signifies that the developed response were in good fit with the experimental data. And all the models have F values above the 2.65 and P values for model were less than 0.5, signifying their adequacy. So same goes with orifice plate 1 and orifice plate 2, orifice plate 3 and orifice plate 4. So constant term were also significant for each of the model. However, some of the A square value and B square values were not significant, but the model was significant. And these are the graphs that are showing the 3D plot showing the effect of process parameters, that is pressure and time on the log reduction of E. coli by 4 different orifices played in the and these are the constraints which they have suggested the optimal predicted values, and we have experimented that, and it has been validated because the difference was not more than 0.5. So it had the predicted values and the experimented values were validated. So coming into the conclusion, there is the expense or less than 5% deviation. So it has a significant. Then in single hole orifice plate, there was 2 single hole orifice plate and 2 multi-hole orifice plate. So in the orifice plate would have single hole orifice, we have attained 2.6 log reduction, and in the multiple orifice plate we have attained about 3.3 log reduction for E. coli and 2.7 log reduction for S. aureus. And the reduction were basically dependent on the flow characteristic, as I have discussed earlier, the alpha and the beta value, and the flow characteristic, that is the cavitation number also. So cavitational effect on it is dependent on flow geometry and flow characteristic of cavitating device used. So this technology, by changing the flow geometry and flow characteristics, we can achieve more of where in liquid product we need 5 log reduction. So changing those properties, that can be there has a potential to reduce the microorganism. So with it, I acknowledge DST who has funding for the project and for the experiment, and FETT department, ICT Mumbai, and ICFOST AFSTI. And thank you so much. Thank you so much for the platform.
Yeah, it's Ms. Kakoli, very good piece of investigation. This one, you have used this hydrodynamic cavitational effect for milk preservation. Otherwise, what are the other applications wherein this method is commonly used?
The hydrodynamic cavitation, right?
Yes.
Yeah, in other liquid food, basically liquid food it is.
Other than food, is it having any other
juices in apple juices, orange juices, this had been studied.
no, but there is a non for other purposes like industrial effluents treatment, especially this hydrodynamic cavitational method is commonly used.
That is now used for that cloud point extraction also.
Exactly. That's why I'm asking, other than food purpose. Okay. And how do you create cavities during this one by in this hydrocavitational method? How do you create that pressure-based things and other things? Just I'm asking, no need to show, just you can tell.
Okay. What happens is when the liquid flow through the vena contracta, that means the orifice, through the whole of the orifice. What happens is when
Okay,
it flows
I got it. You have used orifices. Other than orifices, are there any other things that they use commonly for creating the pressure and cavity?
Yes. Venturi has been used, and I myself has used Venturi, and I published a paper through it, and throttling bulb can be used.
Yeah, and also vortex diode and other things.
Vortex diode can be used. Yeah.
So how do you say that this orifices what you have selected is the best method, best suitable thing compared to other things?
Sorry, sir, the voice is breaking. Can you repeat? Sorry.
No. Actually, as you have used the orifice to create the pressure in your study for milk preservation. But otherwise, as you said, there are other methods like vortex diode they use, rotary type devices also they use. So how do you say that your method is good for milk preservation? Have you tried with other like vortex diode and other things also?
As far as review, I can say that I have not tried with other, but I have tried with ultrasonication.
Okay.
Ultrasonication I have tried, and at the same time, considering the ultrasonication and the hydrodynamic cavitation, here it is not included. One of my paper, it is included that the scalability. See, in ultrasonication, the scalability is little bit difficult as compared to the hydrodynamic cavitation. The processing volume is large in hydrodynamic cavitation, so it the costing amount also it get affected.
Okay,
so counting those things.
Yeah, I got it. And generally milk preservation is mainly what we do is by pasteurization at high temperature, short time or like that.
Yes.
So, by using this method, how is it better than this general regular pasteurization method, or what is that?
Yeah, better. Considering the inactivation, we can say better for now, because as I have mentioned, the reduction is only 3.3 log reduction. But in that case, in pasteurization, we get 5 log reduction.
If so, does it have any influence on nutritional quality and safety?
For nutritional properties, it doesn't have any influence. It doesn't change because it doesn't act on the hydrogen bond. Hydrogen bond means they all act on the vitamins and all these low molecular compounds which are made up of hydrogen bonds. So it doesn't act on that. So the nutrients is not affected affected as compared to the heat treatment. So hydrodynamic cavitation does not affect much on the but minor compounds, that minerals and vitamins where it get degraded in the heat treatment.
Okay, thank you. I will go over to the coaching person, Dr. Suresh.
Thank you.
Yeah, I have a few questions. What is the mechanism here in the milk preservation by using this technology?
This is basically the pathogenic microorganism killing or inactivation of the pathogenic microorganism. The two strains which I have selected, E. coli, and for testing for E. coli, that is gram negative, and gram positive bacteria, that is S. aureus.
But what is the mechanism? How it will get killed?
Okay, so it will have a chemical and physical effect. When the bubble burst, means what happens is when the bubbles are created, then there is a development in localized hot temperature as well as pressure are developed. That is very high, at very millions of points it is developed. So in that point, what happens is both physical and chemical effects takes place, like physical, which include microjets and shock waves and all. In chemical effects, it is include the free radicals. So these microjets hit on this is called asymmetric collapse actually, when the asymmetric collapse happens when the molecules and the particles in the what call milk. So particles, let's we consider as the microorganism. When it is when the bubble collapse in the surface of the microorganism, the microjets produced burst out the cell wall of the microorganism, just releasing those cytoplasmic as well as the chromosome of the microorganism.
Yeah, okay, but as you know, the chairman has said, no, it has to be again see from the nutritional point of view, as you are telling the kind of pressure development and the temperature development which is responsible for the preservation. This is
that pressure,
chemical changes and the physical changes into the are responsible for that. The same physical and the chemical changes also will be true for the nutritional point of view. So I think that also need to be studied to see the efficiency. Again, as he also told, okay, it has to be compared with the conventional process of preservation of pasteurization, and
yes,
need to be studied, and the cost effective.
Yeah. I will note down that, sir. I will note down
because
that.
Cost effective is also a very vital thing, being a staple food and then regularly consumed. So consumer is looking for not single price increasing into the price of the milk. So that has to be considered. Overall, it was a good presentation.
Yeah, a couple of questions are there from the audience. I think only 2 questions. I think both are for this last presenter only. One is cavitation also occurs in existing homogenization of milk. How your process differs? Is it okay or should I repeat?
Yeah, I can see the comments. Cavitation also occurred in existing homogenization of the milk. This is actually how my process differ is the here I'm not using any what call heat as well as the conventional homogenizer they use is like I have compared with that. So in the reduction of the what call this fat globules, the reduction was less as compared to that, and this hydrodynamic cavitation also give the properties of homogenization of the milk. So it's an advantage we can say, or add-ons we are getting with the inactivation as well as the homogenization, making it the milk more stable.
And the last question, I think, is how to deal with the cleaning issues in throttling devices, as we need these things with the food products.
The throttling devices means what I use is orifice plate. So it is mainly of stainless steel plate. It is not a big issue in the cleaning because we have to run through the CIP process. And I have done it by CIP processes, and the cleaning is not an issue. It doesn't stuck in that. If the diameter is too less, or then it might be a problem. But in our device, what we did is the throttling device, the devices we use can be removed. Means we can change the devices for that, and the tubes can be cleaned by CIP process.
So with this, I think all the present participants have completed their presentation. Just in 1 minute, I would like to compile the things. Altogether, 4 participants have enthusiastically participated and given their presentation, and also very well defended the questions, so whatever the chairperson and co-chair and whatever audience has asked. At the beginning, Ms. Amrita Ray has taken the quinoa germ and nutrition powerhouse, how effectively it can be used for nutritional purpose, that she has demonstrated with very good characterization of the and development of the process that is extraction and stabilization. This is followed by the second presenter, Ms. Sonali Tiwari. He wherein a lot of basic components also she has considered. By doing so, the effect of sodium azide on cell viability and photosystems too, she has demonstrated, and how effectively this will be considered for the astaxanthin accumulation in Haematococcus pluviolis. She has demonstrated. Otherwise, such as studies or some preliminary studies, some other researchers have earlier carried out in chlorella, and this is the astaxanthin pigment is one of the important antioxidant one. So in that aspect, she has given her investigative report in this. The third presenter is Ms. Subhashri from Niftam Tanjore. She has taken the 3D printing of plant-based meat alternative from indigenous source. So how effectively we can use this plant-based meat to as an alternate to the traditional regular meat. And in this case, the mechanism things involved in developing these things and costing wise and all these things, the points she has addressed. And the last presenter, Ms. Kokoli Pegu, has taken the application of hydrodynamic cavitational effect with different orifices for milk preservation. Since, as I mentioned in my comment, this generally used for the industrial effluents, but this also can be a potential tool in preservation of milk. That what he has demonstrated in that presentation with very good defending. So within I thank the organizers of the ICFOST for giving me an opportunity to chair this session. And now for the remaining remarks, I would like to request the co-chair, Dr. Suresh, to conclude this one.
Yeah, thank you, sir. As you have briefed about entire session, it was a good technical talk from the presenter all across the India, and good innovative technologies they have put forward through their presentation. With this, with the permission of the chair, we will conclude. I thanks chairman for taking out the time and chairing this particular session with a very short period of time from the ICFOST side. Thanks to you, thanks to all the audience and the presenters. Because of their technical presentation only, this session could be become much more important. So with this, I conclude the session. I thanks ICFOST and I thank you all of you. Thanks, and continue with the other sessions that is going on parallelly, and then after this session. Thank you very much.
Thank you, sir. Thanks.
Over to Technical Committee, Aurangabad.
Good afternoon, everyone. So next session will start at 4 p.m. Dr. Prakash, sir.
Yeah, I wanted to attend plenary talk actually. How to go there?
Sir, it's in Hall A.
Yeah, I don't have link actually for Hall A. My system it is not opening.
Either the link share kar de. So 1 minute. We are
You-
sharing link for Hall A.
Exactly. You send it on this number, this chat box only.
Yeah, sir, we are sharing in chat box.
Wonderful.
Dr. Prakash?
Yes.
Sir, are you going to share your presentation or we have to share your recording?
Whatever you feel, if recording work, let us see. If it don't work, then I will present from here.
Yes. Can we try right now?
Yeah, that we can do.
Yes. Thank you, sir. Thank you.
Good evening. If there are only 2 recorded presentations, at least you can tell that you arrange the recorded presentation during the conference.
तो stop कर. हाँ, दोनों.
$26 minutes. Good evening, everyone.
Sir, are you able to see the screen?
Yeah, I can see.
And audio?
I'm very happy to be a part of 20th ICFOST, which deals with the emerging and adaptable technology for sustainable agri-food industries and economy. Wellness greeting from CFTRI. What happened?
Dr. Prakash?
Yes.
Is video is clear?
Only a few minutes I could see. I hope it is clear.
Voice is clear?
Yes, yes. Only voice was little less.
Okay, okay.
So you just check from your side.
Yes, sir. Yes.
If difficulty is there, please let me know before only on my WhatsApp number.
Yes, sir. Yes.
That should not. But sometimes your system also know that audio get hanged actually in between.
Okay, okay. I'll check once again.
Exactly. You are checking here right now or
Yes,
separate?
yes. Right now, sir.
Good evening, everyone. I am very happy to be a part of 20th ICFOST, which deals with the emerging and adaptable technology for sustainable agri-food industries and economy.
So now it's clear?
Representing from CFTRI. Yes, yes. It is indeed a
Dr. Prakash.
matter of a great pleasure to talk in this section, biotechnology and fermentation technology. I will be sharing my research activities on a very important area. Yeah, it looks quite all right, but we are only 3 people, I think, so maybe I will try presentation directly. Veena, can you hear me?
Sorry, sir.
I will try to make presentation directly, I said, if it is okay. Can you hear me?
Yes, sir. Sorry, sorry. I can't hear you, sir. Yes. Yes, sir. Please tell me.
Sir was the senior executive director.
Yes, sir. Yes. Dr. Prakash.
Yeah, we will try for the video. In case if it not proper, then I will be ready to make a presentation directly also, I said.
Okay, sir. Okay. Can I share first or you're sharing first?
First you share, you check.
Okay. Okay, sir. Okay, done. Okay, sir. Okay. Thank you, sir.
Hi, everyone.
Shubha, are we in the right room?
Yes, we are in the right room.
How many such rooms are there?
There are 3 such rooms. We can enter only one of the 3 rooms. We are in Hall B.
Okay.
Hi, Dr. Prabodh.
Hi, Devendra ji. Hi.
Hi, Nicole.
Hi everyone. Good evening. Good afternoon.
Hello. Hi, Ms. Smita.
Hello.
Very good evening. Glad that you could join us for the session today.
Thank you. Thank you for inviting us. Hi, Nicole.
Hi.
Yes, Anand, you're in the right room. Good evening, good afternoon, and welcome.
Thank you. Shubha, how many have joined?
We are waiting for Varun and Karthik to
वो
join.
स्मार्ट प्रोटीन का जो है ना उसमें लिंक भेज देना ये.
Yes, मैं भेजती हूँ. ICFOST team, whoever is here, please let us know prior to going live. Okay, give us heads up, or rather, we will tell you when it's okay to go live, and please go live at that time.
Okay, ma'am.
शुभा एक बार डिसाइड कर लेते हैं हाउ द सेशन वी विल टेक इफ वरुण हैज जॉइन.
Varun should be joining in a minute.
Okay, great. Who have confirmed Devendra ji is there? I could see him. Karthik, are you there?
Karthik is also not here yet. I'll just call him and follow up with him.
Devendra ji, welcome.
Hi, Dr. Prabodh. How are you?
All well, sir. All well. Anand ji is there?
I'm here.
Oh, great. Anand ji, welcome.
Thank you.
Smita ma'am.
Hello, sir. Good evening.
Smita ma'am is there?
Yeah, I'm here. Are you
Oh,
able to hear
welcome,
me?
ma'am. Welcome, welcome.
Thank
I
you,
am
sir.
not able to see you, but Dr. Mukund.
He's just joining.
Okay, great. So we are waiting for Karthik, Dr. Mukund, and our Varun.
Yeah.
Okay, great. सचिन नहीं मैं
Veena, are you here from ICFOST team? Who's here from the ICFOST team? Please identify yourself.
Ma'am, myself Vaishnavi.
Vaishnavi, can you share the YouTube link for the current session with me? Or put it in the chat box here?
Yeah, just a minute.
Yeah, just put it in the chat box here,
Yeah.
please.
Yeah.
Hi, Varun. Hi, oh, this is
welcome
Karthik.
Varun.
Karthik is looking really dapper. Hi.
Hi Karthik.
Hi everyone.
Hey, Shubha just wanted to check the parallel session is started the other room.
I don't know. Vaishnavi will need to tell us. They may be just about starting. I don't think they've started yet either.
So can we put our some basic rules so everybody will be on the same page?
Ma'am, just check your chat box.
Yes, got it, Vaishnavi.
Yeah.
Thank you.
Welcome.
Yes, Prabodh, go ahead. I think Nicole already shared one round of communication in terms of the session order, but anything that you want to add?
Sorry, Shubha, you are saying?
I'm saying Nicole has already shared one session structure, so to say. So we will, once we start the session, you can start speaking, and or rather I will introduce and start off, introduce you and hand over to you.
No, I think what we will do, are we on live or it is just our...
We are not yet live.
Okay, so this is a practice session.
Yeah,
so welcome everyone. So we will be going live in next 5 minutes, but we really want to thanks to Good Food Institute and our dear friend Varun and his entire team for hosting this session with us. Actually, this smart protein session is, we thought about only GFI. We could not have completed this session, thought about it without GFI. So what we will do, I am a chair, my colleague Shubha is a co-chair. Shubha will welcome us. She will introduce us in one slide. I will give the opening remark. After that, then Varun will talk as a keynote. Devendraji will talk as a keynote. And then Shubha will open the panel discussion, wherein all will be a part of the panel, including Varun and Devendraji and all other dignitaries, including all today's panelists, including Smita ma'am, then we have Karthik, then we have Anandji, and also Shubha, who are there?
We had one more
Present.
person.
Then we have Dr. Mukund.
Dr. Mukund.
And Nicole.
Yeah, Nicole will be the moderator.
Yeah.
What,
So my
what
only
we said-
request to Nicole, kindly include Varun and Devendra ji as a part of panel. So the right questions, as per the discussion, Varun also can share his thought, and Devendra ji also can share thought. Anybody has any query or question or suggestion? You can unmute yourself and please speak.
Yeah, just wanted to convey our thanks again to AFSTI and all of you for your partnership here, and looking forward to this session. And I will say I'm looking forward to Devendra's comments on the panel. I will be mostly silent after I do the initial keynote. I think we have a great number of guests here. So Karthik, Smita, Dr. Goswami, Anand, really fantastic speakers who are doing great work. So I would love to highlight their work. Thank you so much. And Devendra, I shouldn't forget Devendra, of course, on the panel. Yeah.
Okay.
So are we good to start?
I think we should start.
Vaishnavi, can you take us live, please?
Yes, ma'am, sure.
A very good afternoon to all our delegates today. We welcome you to the session on smart protein. This session, which is being jointly conducted by FST Mumbai chapter and the Good Food Institute as part of the 28th ICFOST, has been sponsored by Samyog Foods, their Prolicious brand, so to say. This session on smart protein sits at the very core of the ethos which we developed when we created the entire theme for ICFOST on sustainability. Smart protein is indeed a paradigm shift if we are to look at feeding the billions that we have to. I'm not quoting any numbers, I'm not quoting any values. I leave that to the extremely erudite and experienced panels and speakers whom I will be welcoming shortly. But suffice to say that to all of us as food scientists and food technologists, we appreciate extremely well the role that protein plays, not just in nutritional adequacy, but in satiety and in flavor when we develop new products. There is, it's a core integral part of any product development for consumer delight. How this requirement of quantity and quality of protein can be met in a manner which is sustainable and safe for the environment, that is what today's session is based on. It is my great pleasure and honor to welcome the chair for today's session, Dr. Prabodh Halde. Dr. Prabodh Halde requires no introduction. I normally do not get into introducing him because that eats away into almost an hour of the session. Having said that, Dr. Prabodh has been the past president of AFSTI. He is currently a member of the Central Advisory Committee of FSSAI and the regional chair for AIFPI. He's represented India on various codex committees, on various international scientific panels. And I welcome you, Dr. Prabodh, to please take the session forward.
Thank you, Shubha. So am I supposed to speak now, Shubha, or?
Yes, Prabodh. I will welcome the subsequent speakers as we go along. Over to you for your introductory and context setting for the session today.
Thank you. Thank you. And first would like to thanks to sponsorer, our dear friend, Chawla ji, who is also actually a great human being and supporter for the vegan industry. Their brand, Prolicious, they have just started. Devendra ji is there. Prakash ji could not join. This session is a smart protein in association with GFI. So I welcome first my co-chair Shubhaprada. I would like to introduce Shubhaprada. He is the director in charge of ITCFSN. She is food technologist, over 24 years of experience and expert in food processing, food safety. Now, along with us, the India in charge of GFI, Varun Deshpande, is also there. I welcome Varun ji. I welcome Devendra ji. I welcome Nikolay. I welcome Karthik. I welcome Anand ji. I welcome Miss Smita ma'am. And I also welcome Dr. Mukunda. I also welcome other GFI coordinators who are present in the session. Friends, when we thought about ICFOST, just some background about ICFOST, this is 28th ICFOST, which happens every year. Association of Food Scientists and Technologists is the apex association of food scientists and technologists. As we are aware, the farmers' problem and the farmers' agitation which India is going through, there will be only solution if farmers start getting more remuneration. And Government of India has started doubling the farmer income as one of the thought and one of the program. I don't see it will be happening unless you do the value addition. Subsidy, giving us subsidies is not a solution for the farmer's problem. Value addition is only through the food processing, advancement, utilization of the various technology, and that's why appropriate processing is important, which is a value addition. Now, in the ICFOST, we thought about smart protein, a session jointly with GFI. As we all are aware, in the COVID time, and particularly in India, not only in India, but all across the globe, today the protein demand have increased by 34%. Because as such, India, just a minute, Shubha, I'm getting a call from the organizer. Hello. Sorry, there is one more parallel session starting that has not started. The chairman has called me why it is not started. They all are in the queue, but nevertheless, this happens because of the COVID. So what I was saying, in this smart protein, what we have thought about during the COVID time, everybody realized for immunity, the building block of the body, and we call as amino acids, and which are the protein, are so important for your immunity. There is no point of taking the medicine if your basic protein requirement is not completed. Let me tell you, as per the RDA, we require 55 gram to 65 gram minimum protein per day. Indians are lacking 40% of the protein, so we are able to cover only 60% of the RDA in average. So India is lacking in the protein. We have been told all the time that milk is a good source of protein. But let me tell you, milk only contains 3.5% of protein. I'm not against the dairy industry. Dairy is one of the great source of protein. I agree. But along with the dairy, then there is a good source of plant-based protein, which we have ignored in long way. From long time, we are actually not giving importance of the plant-based protein. When we talk about plant-based protein, it's one of the great alternative to the animal protein. There are many thoughts about animal protein is good or bad. Should we consume or not consume? But I'm not going into the religious belief. I'm going to the scientific belief that animal protein making requires more water, more energy, more land rather than the plant-based protein. So sustainable way is the plant-based protein. Again, we are not saying, should we replace 100%? No. As per the estimate in US, only 1% animal-based protein has been replaced with the packaged plant-based protein. So there is a huge way wherein we can go in India. So if US is 1 to 2%, I don't know, Varunji, you can please confirm me whether it is 1 or 2% or more than that. But yes, there is a good scope for plant-based protein. Just to give you some food science, there are essential amino acids which body cannot produced within. You require external intake of those essential amino acids. They are namely histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. So this is a second year BTech. I remember these are the, because we used to actually mark this because of the marks. But these essential amino acids are so essential for your body. And there are non-essential amino acids which body can capable of making, like alanine, arginine, then asparagine, aspartic acid, cysteine, glutamine, glycine, proline. Now the beauty is that plant has ability to give all kind of essential amino acids. There is a myth because in our school syllabus we have been told protein means egg. It is true, but protein means soya also. Protein means moong also. Protein means there are so many plethora of plant-based protein are available which your digestibility is better. Availability is better. So today, I am not saying we should be going for any actually faddism. Only plant-based protein should get their right platform to showcase what they are. Let the consumer be a choice maker. It is not that something is good and something is bad. Let's not paint only. I was told in 1932 when Gandhiji was being told that you have to eat something non-vegetarian if you want to save, otherwise you will not get saved. Let me tell you, Gandhiji is the one who started. Varunji, this is very important part. I have given this talk in there. He is the first person who has actually written in Harijan, that time, that how to use the soybean and how to make soya paneer to increase the value of the protein in your diet. He has written in 1932 in Harijan. So then actually the protein-based importance, and Gandhiji, by the way, was a great nutritionist expert by practice, not by his education. He was an advocate, but he was a very great actually the leader for the nutrition, and he used to say about the plant-based. He was talking about the plant-based. Then there was no veganism, but he was the person who was demanding for the plant-based. Nevertheless, we have a great actually selection of the speakers thanks to Varunji. I appeal to the food technologist. I appeal to all the speakers today in your journey, what you are doing, what help you required from the food technologies. Please speak up and you please share your challenges, your problems, your solutions, your successes. And we are eagerly waiting for, at the end of the session, what we have to give to the government, because outcome of this will be shared with the government. What are the things which you required from the various scientific institutes like CFTRI, DFRL, ICT, CFT, and other institutes, and also for the common man. What is the message? So thank you for giving me this opportunity. I will be available at the end of the session for a closing remark, and I really look forward that this association of AFST and GFI will continue for better tomorrow. Better tomorrow, I am saying, and recently today only somebody has forwarded me one ad, Tata ad. The ad says about, they have given some colors to the parent and they said you choose the color and you draw something, and they all have selected bright colors. Then they said second team is coming, please keep some colors for them, but nobody was in reminding of what colors to be kept for the second team. Second team were their kids, only the black color and the white color were remaining. And then they compared the drawing out of both the teams. The parent team had all greens and bright color. Everybody clapped for them. But the next generation was with only black and white. We hope that we will be passing to our next generation something good if not better, at least which they deserve. So sustainability is important, and thus plant-based protein is very, very important. Thank you, Shubha. Thank you, and I welcome my colleague, Varunji.
Thank you very much, Dr. Prabodh. In your side, you really brought across the importance, a very powerful ad, the Tata ad that you referred to. All of us have seen it. And indeed, it is a responsibility for all food technologists, for all food scientists to focus on taking forward a sustainable food industry for our future generations. Thank you so much for your very, very pertinent introductory remarks. My pleasure now to invite Mr. Varun Deshpande, Managing Director at Good Food Institute India, one of the most passionate people I've had the fortune to interact with. He instills in everybody he interacts with a drive to do a little bit more. Welcome, Varun. And as Dr. Prabodh said, we really appreciate the effort from GFI, from your entire team, in putting together an excellent lineup of speakers and an excellent session that we look forward to. Varun has numerous awards and achievements. He's been a fellow of the Patient Safety, a SARC fellow, and a Health Innovators fellow. He has experience in working across various global systems and is today building GFI over the last 5 years in making healthy, humane, sustainable food system possible for us in India by working towards plant-based and cultivated meat alternatives. Welcome, Varun, and we request you to please take over the session and deliver the keynote.
Thank you so much to our AFST colleagues, to Subha, Dr. Halde, and to everyone in the audience here today. I'm going to be very quick and go through a number of slides here. I really want to hand over to our guests with on this excellent panel. And thanks as well to my colleagues at GFI India, Nicole and Devika, for putting all of this together. So I'm going to very quickly go into my slides here. And as I say, I'm going to speak very quickly. But as we all know, we are assembled here today to talk about smart protein, which is a new paradigm of sustainable food innovation. As the AFST team mentioned, we are the Good Food Institute India. We're working collaboratively with AFST on a number of initiatives. And what we do is we build this smart protein sector across business, science, and policy. And we have a global network of organizations. So there's a GFI US, GFI Brazil, Israel, Europe, Singapore, and we're setting up in Japan, Korea, et cetera, et cetera. The main question that we're here to discuss today, as we all know, is how are we going to feed 10 billion people by the year 2050 through systems which do not continue to break the planet? And unfortunately, our current supply of protein, which is mainly sourced from animals, so our conception of protein that comes from animals, that is meat, eggs, and dairy, presents a number of challenges in these dimensions. So when we think about sustainability, we think about safety, we think about security of protein and of our food supply, there are a number of challenges that come from the animal protein supply that mean we should try and diversify our intake of protein. So just a couple of examples here, which I won't go very deeply into, but scientists from the United Nations, from the Eat Lancet Commission, from a number of different organizations, the FAO, etc., have all stated that any of the things that we care about under the umbrella of sustainability, so whether it's species loss, biodiversity loss, deforestation, ocean dead zones, ocean acidification, greenhouse gas emissions, land use, water use, any of these things that we all care about, industrial animal agriculture is one of the top 2 or 3 most significant contributors to all of those things. As one example, it contributes more to climate change than the emissions from all transportation on the planet combined. Equally, we actually use a huge amount of antibiotics, about 70% of global antibiotics going into farmed animals as opposed to humans. And we've just seen new research that has come out that shows that in 2019, which is the latest figures that are available, 1.27 million people globally already died from antimicrobial resistance. That's more than, or nearly more than HIV and malaria for that year combined globally, which is a huge challenge that we currently face, right? And why all of this is happening is very simple. We need to produce a huge amount of protein. And unfortunately, animals are an inefficient and an ancient protein production platform, which we need to make much better. So chickens take in 9 calories of input to give you 1 calorie of output in the form of flesh or meat. So they take in feed like corn, soy, wheat, etc., and they give you flesh in the form of meat, right? And chickens are actually the most efficient animal that we farm for meat. So cows, pigs, these are much, much worse in terms of their efficiency. So we're actually using huge resources, land, water, emitting huge greenhouse gas emissions, needing to grow these animals very close together, which creates zoonotic disease, antimicrobial resistance, etc. And this is particularly important in a country like India, because our trend of meat consumption is actually, and meat, eggs, and dairy consumption is actually very high in terms of moving upwards, driving the global demand over the next decade or decades. So we'll need to produce about 50 to 70% more meat by the year 2050. And by the way, the global population will only grow by 30% in that time frame, but we'll need to produce about 70% more meat in that time frame. And a significant amount of that growth, as I said, is happening in India. And this is natural because as incomes rise and people aspire to eat more high status forms of protein, meat, eggs, and dairy are right up there in terms of what people are craving, right? And as we all know, look, India is a predominantly vegetarian driven culture is something of a myth, right? We do have a lot of meat consumption, a lot of egg consumption in the country. So our entire theory of change around this is, if we're going to need to produce so much additional meat, egg, and dairy over the next decades, and it's creating so many challenges. And just by the way, focusing a little bit further on those challenges, I think we all know that there are also outbreaks of things like avian flu, things like African swine fever that have started happening in India as well. This actually disadvantages the farmers even more than it disadvantages people like you and me. So we might sit in our homes in cities like Mumbai and Delhi and say, okay, for a couple of months, we won't eat chicken, right? But for the farmer, they have to get rid of their entire livestock, their entire stock of poultry during that time, which is a huge economic loss to them. So our theory of change is very simple. We think that we have to address all of these problems. The sustainable development goals are laid out here on the screen for you, and things that are completely relevant to our food system. So instead of telling people to eat chana and not chicken, or eat broccoli and not beef internationally, we focus on providing solutions that taste the same or better and cost the same or less. And you'll see that with all the stakeholders in the ecosystem of smart protein that are coming on the panel here today. You'll see that our focus is very simple. We want to give people what they want, but made in a different way. So producers and consumers have a simple choice of a switch rather than a sacrifice. And smart proteins present in 3 different categories, and they offer very promising solutions to these problems, and they offer that promising switch. Mostly, I think most people will have heard of plant-based meat, eggs, dairy, and we have a few exciting people on the panel here today that can talk about those things. There are also fermentation-derived proteins and cultivated proteins. And I'll go very briefly into these. Plant-based proteins, or plant-based meat, eggs, and dairy, are meant to go far beyond the previous generation of, let's say, soya nuggets, or previous generation even of soya milk, and get to a much better taste profile and sensory profile and cultural profile of what they can provide. So they're made from plant or crop ingredients like soy protein, pea protein, coconut oil, etc. And they're meant to provide, as I say, all the sensory and cultural resonance of their animal-based counterparts. What's happening over the last 10 years is this market has grown extremely rapidly. So if you look at only plant-based meat, and of course there's also eggs and dairy, but only plant-based meat, any of these companies like UBS, JP Morgan, A.T. Kearney, they all say that it's going to be a multi-billion, hundreds of billions dollars worth market by the year 2035. The reason this is happening is because the industry has moved very rapidly, right? So we've seen, this is an international landscape, really. We've seen some of the largest meat and food companies in the world. You'll see on the screen there, Nestle, JBS is the largest meat company in the world. Maple Leaf is the largest meat company in Canada, PHW in Europe, Smithfield, the largest pork producer in the world. In fact, 9 out of 10 of the top US meat producers have invested in or started their own line of plant-based meats. We've also seen a lot of movement on the early stage landscape, and I'll talk a little bit about this further and how it's pushing forward the industry. But I think all the food scientists in the crowd would appreciate that there's still a lot of work to do, right? And the great news is opportunities for optimization exist across the entire chain of the value chain of plant-based food. So this is an example maybe for plant-based meat, but it also exists for the other categories. So optimization at the seed level, at the protein extraction level, at the raw material optimization, functionalization, as well as the texturization level offers a huge amount of promise. And we need all the talent we can get at every level of this value chain from a scientific research standpoint, from an engineering and industry standpoint, to take us forward in this direction. The second category, as I mentioned, is fermentation, and everyone knows what fermentation is. If you've had yogurt or kimchi or kombucha or something more exciting like beer, you know what fermentation is. You know that it's been existing in the food industry for millennia, actually, but even in the modern food industry for centuries or decades, right? So we're talking about very specific applications of fermentation within the smart protein sector. There is traditional fermentation, which uses microorganisms to ferment foods and get you something that can be applied in the smart protein landscape. There is biomass fermentation, which is growing the organisms themselves and producing, let's say, a bacon substitute, as you can see on the screen from them. And then finally, there is precision fermentation, which uses the microbes themselves as a host to give you a protein or something that you want to eat. And I think if you're in the audience here today and you've done work on metabolic engineering or production of enzymes or insulin or any of this, you know that precision fermentation is also growing very rapidly. Same story here. There's a value chain. There are opportunities for optimization, and I won't go very deeply into all of this, but just to underscore that across this entire value chain, we need much more research, innovation, commercialization, and talent and investment flowing into it to support all of that. Just to give you a picture of how rapidly, by the way, the landscape is growing, even in fermentation, we've seen very rapid growth in the number of companies entering here, but these are all global figures and we need much more coming out from India. So I hope that the people in the audience will take inspiration from the people on the panel today and maybe join their companies or start new companies of their own, right? As an example of some of the companies that are exciting that you can look up in the global landscape, there's 3F Bio, Nature's Find, Quorn. These are all doing whole biomass fermentation where they're producing fungi at large scale and producing mycoprotein and meat substitutes, etc. from them. On the right there, you'll see Perfect Day, which produces milk proteins using microbes as a host. So precision fermentation, by the way, founded by two Indian co-founders. And then a similar story where we're seeing large companies invest in this space as well. And then finally, cultivated meat is produced directly from animal cells. Many of you will have seen this now becoming a reality. So it's like farming the cells rather than farming the animals themselves and slaughtering the animals. And once again, this won't be a surprise to you. Across the value chain or the production chain of cultivated meat, there are opportunities for optimization and specialization. And we are going to hear from Dr. Mukunda Goswami, who's doing exciting research in this area as well. This has also moved very rapidly. So I know it sounds like science fiction as a particular category within smart protein. It sounds the most futuristic because you're growing cells rather than growing the animals. But it's actually moved very rapidly. Within the last 10 years, we've seen the first burger that was eaten live on TV by Professor Mark Post. And since then, there have been 70, 80 plus companies that have entered the space, which is really exciting. Equally, we're seeing these large companies get involved in the space, you know, the largest meat, food, industrial companies in the world that are investing in these startups, etc. And where we think it will go, and this is the really exciting part, we think we are maybe in, you know, we're in 2022 now. So we've seen one country in the world has approved cultivated meat for sale, that is Singapore. We hope that there will be regulatory approval in multiple other countries. But most importantly and excitingly, we have to still take this technology of cultivated meat and bring it to a large scale. And that's where countries like India can come into the marketplace and really help to scale up a new industry. Important to note that the cost of these technologies, this is of course about cultivated meat specifically, but the cost of all of these technologies is coming down very rapidly, and that does not happen automatically. It happens because very talented people like yourselves in the audience, like the people on the panel today, work on these problems and focus on increasing the functionality, increasing the taste, increasing the nutrition while bringing down the cost of these products. So this is happening very rapidly within cultivated meat, as you can see on the graph there. I'm not going to dive very deeply into these numbers. And we've just talked about 3 different categories, right? And I know it was a lot compressed into a brief amount of time, but the important thing to remember is ultimately it's all going to be meat, or it's all going to be eggs, it's all going to be dairy. We'll see hybrid products, and it's all going to occur along a spectrum. So as an example, we are already seeing precision fermentation derived dairy proteins that are being put into otherwise fully plant-based formulations and launched in markets like the US or in Hong Kong, etc. So a small amount of whey protein that is produced through precision fermentation is being added to a plant-based vegan ice cream and served as an animal-free dairy alternative ice cream, which is really interesting. Just a time check, Subha, do you know how much time I have left here?
3 minutes more.
Got it. So yeah, I just want to go over the momentum that's happened in the Indian market before I close out. Interestingly enough, the Indian market, and I'm going to focus on plant-based here because that's what's already out into the market in India. Indians, especially in the early adopter cohort of consumers, are actually very perceptive to these products. So you must have seen, if you're following this space at all, you must have seen over the last few months and maybe over the last year, there have been multiple launches. So we have a lot of now market data on how things are going. And Indians are actually telling us, at least the early adopters who are young, upwardly mobile, high disposable income, living in tier 1, tier 2 cities, etc. Maybe they've studied food science and they understand how these products are made and they're excited about that. They are very or extremely willing to buy, let's say, a plant-based meat regularly, right? And while the previous generation of plant-based meats was kind of like your grandparents' soya nuggets or like a katel product, a jackfruit product, now we are seeing a next generation emerge where they're much more focused on matching the sensory profile that consumers actually want. So just as a few examples here, you will see companies like Evo Foods, Shakahari, Good Dot, Blue Tribe, Imagine Meats, etc., launching in the market, which are really exciting, right? So just to highlight a few of those launches, and Anand, who's the founder, CEO of Shakahari, is here on the panel today. You can see there that at least the visual profile, and I hope that some of you in the audience will have tried or will try some of these products. The visual profile is absolutely beautiful. You can see that they've got different types of keemas, biryanis, burgers, etc. And they're actually launching in retail. So you can see, or they have launched in many retail points of sale. So you can see that on the right, an in-store activation is what it's called. Similarly, other companies like Greenest, where you'll see a retail display there on the left that's fully filled up, and you'll see some of their marketing materials on the screen. And then another example of Imagine Meats, which was started by Ritesh and Janelia Deshmukh, who many people know. And they have launched with 9 different products, and they're also out there in the market. We're also seeing now, aside from Ritesh and Janelia, of course, we're seeing more and more celebrities, sports people, etc., start to endorse these products or look into this space, which is very exciting. Shah Rukh Khan announced the launch of Imagine Meats on October 14th, Ganesh Chaturthi this year, or last year, excuse me, and Neeraj Chopra has joined Good Dot as a brand ambassador, which is very exciting. And then I think many of you will have followed that ITC also announced the launch of their incredible range of plant-based meats. All of this is fantastic, by the way, for all the startups as well, because it creates a lot more category excitement or category awareness. And I'm sure you'll hear them talk about that on the panel. And then finally, we've seen a lot of innovative promotions as well. So Blue Tribe Foods had an ad on Hotstar during the Cricket World Cup, which is really exciting. That was the first ad by a plant-based company during the Cricket World Cup. And then on the right there, we've seen Swiggy, with the advisement from us again, launch a separate tab for plant-based meat on their app, on their Instamart service in their app, which is currently with 2 companies, but they'll be expanding that soon. So this is all really exciting stuff that's happening in the landscape. It's still very, very early, but there's an opportunity for us to grow together. And I hope that we can really work together across industry, academia, and government to advance this exciting new space. And I'll stop here. There's a lot more that we could talk about, but maybe I'll leave that to the panelists to bring their own expertise and their insights. Thank you so much.
Thank you so much, Varun. I think a brilliant context setting, brilliant platform setting, I should say. You've given all of us appreciation of the scale not just of the consumption we see of meat products, of the kinds of issues there are, from energy to farmer livelihood to emerging hazards, and the solutions and the options that there are in developing smart protein into a viable business model. Really appreciate that power pack.
Fantastic. I wonder sometime where you got your food technology degree and what kind of technical ability you are upgrading every day. Fantastic presentation, Varun.
I spent some time with you early on. That's how I learned everything.
No, but Shubha, I think anyway, we will proceed with this presentation, but we should have some kind of course along with GFI for our institutes, and also Varun, as we discussed, some kind of scholarships and some kind of PhD sponsorship. I think you please, my request, this kind of knowledge which GFI has all across the globe, we should be passing it to India, and India got a great talent. Thank you
They
for
have a
wonderful presentation.
fantastic precedence in doing it with National University Singapore. I've gone through that course and it's really brilliant. So definitely, Prabodh, we should work with them in bringing something to India. Thank you so much, Varun, once again.
Thank you.
Totally engaging talk for all of us. Taking this session forward, I'm delighted to welcome yet another energetic and young, passionate plant-based protein advocate. I welcome Mr. Devendra Chawla, the founder for Samyog Health Foods. Under their prolific brand, they are focused on plant-based protein space and have made available a range of products which satisfy the Indian palate. I love their products personally. They are meet all the chart requirements that most Indians look for, and he's himself been a very active member of AFST in Mumbai chapter in creating an outreach and opportunity for students to intern with their organization, in sharing his knowledge, sharing the knowledge that Samyog has with students, and in growing the fraternity. Mr. Chawla has his bachelor's degree from Kelly Business School, Indiana University, with further post-graduations, and a lot of experience prior to joining the food space in finance and analytics. Welcome, Mr. Chawla. We are delighted that you could find the time to join us, and I hand over to you for your keynote address on today's session.
Thank you so much. I'd like to start by thanking AFSTI and GFI for putting together such a fantastic event. So today we're talking about smart protein. Varun gave an amazing talk about smart protein and how it works with substituting meat, eggs, and dairy. I'll start by just going over the definition of smart protein again. So smart protein can be defined as food products made using plant-based, cultivated, and derived ingredients for substitution of meat, eggs, and dairy. Personally, I believe that a substitution of carbohydrate is also needed, especially in the Indian environment in the smart protein space. So why the need for protein in India? Currently, we've got 77 million diabetics in India, and 5.8 million people die from non-communicable diseases every year. The risk of coronary artery disease in India is 6 times that of China and 20 times that of Japan. PEM is another big problem in India, which is protein energy malnutrition, and it leads to half of the deaths in the under 5 category. So this is a big problem in India. And it also causes stunting amongst children, and it's the reason for 48% of stunting in kids under 5. And all of these problems mentioned above can actually be solved by correcting the protein balance in foods. And so this can be done with some of the smart proteins that the panelists are going to talk about, as well as using regular vegetarian proteins. Today, I'm going to go over some examples of proteins that are being used in India in this context. As you can see, carbohydrate and visible fat consumption is a lot more than what's needed in the diet today, whereas proteins are lagging behind. So how can plant proteins help in this scenario? A diet rich in protein and fiber with good exercise actually helps in combating diabetes and the other non-communicable diseases. Eating a diet rich in plant proteins helps with reducing the risk of cancer, diabetes, cardiovascular disease. And certain amino acids have anti-hypertensive effects, which help with reducing cardiovascular disease. So why opt for plant-based sources? There's a nutritional advantage. The nutritional advantage from plant-based sources is coming more actually from the fat side of eating meats versus plants. And meats are very high in saturated fats, and this causes a lot of problems, especially with heart disease. And by replacing that with plant proteins, people can live a healthier life and be more in control of their health. In addition to that, eating plant-based diets is a way of showing compassion towards our fellow creatures on the planet. Like I mentioned, it helps with preventing lifestyle disorders like heart disease, diabetes, etc. And it's a step towards sustainability because we will need less land to feed everyone on Earth. This in turn will also make it more affordable for everyone in our society to get the nutrition that they need. So let's talk about some plant-based protein products in the market today. We start with some of the factors that are important in a plant-based product succeeding in the Indian environment. So health, taste, and price are the three most important factors with any food product. A product should be healthy for the people who are consuming it. If it doesn't taste good, we as Indians know that no one's going to eat it. And of course, if it's not in our budget, we're not going to buy it. So one example of smart protein in India is soya chap and soya chunks. It's made with soya beans, either through extrusion or through a mixture and curing process for the chap. And it's got characteristics very similar to meat and is actually used as a meat substitute in North India and in the northeast of India. It's also gaining popularity now in the west of India. So this product is eaten both by vegetarians and non-vegetarians. It helps them get their protein, and it's something that is extremely nutritious and tastes great. So because of that and the fact that it's more affordable than meat, it has taken a big market share in the country and now has a market value of 1,200 crore for soya chunks alone. This said, there's still a lot of room for expansion of this market because it's still very north and west focused. So the east and south have a lot of expansion potential. Another big switch happening is in food products and supplement products. Historically, whey protein was a big part of this market, which we're now seeing move towards more plant-based proteins, including pea protein. Over here on the screen, you can see some examples of companies which have made newer variants of their products to account for the increased demand for plant-based proteins. Some of the issues with whey protein that come up is that it can cause bloating and diarrhea. 60% of Indians are lactose intolerant, and therefore it doesn't really suit their systems, and it can also cause issues with the GI tract. So some of the companies that are working on this space are listed on the screen, and they're trying to switch from whey proteins and getting protein from dairy-based sources to making their snacks and supplement foods with plant-based sources of protein. Lastly, I'd like to talk about the carbohydrate to protein switch. I think today a lot of work is being done in the nutraceutical sector on increasing the nutritional value of foods, especially now with plant proteins, to make foods higher in protein and also in some micronutrients. I believe that there's a huge potential here in the snacking market because everyone likes to snack and everyone's starting to snack more and more. People thought that people were snacking a lot because they were leaving the house a lot, but we found that staying home in the current scenario has actually added to people snacking as well. So this is a trend that's here to stay. And if we can get our protein requirements from our snacks through the day without compromising on taste, I think it would lead to beneficial health outcomes for people. Here are a few of the brands working in the space, including my own brand, Prolicious. So moving forward, looking at things that are needed for the plant-based protein space to succeed, one is investment. Currently, the space is receiving a lot of investment and a lot of attention from the world, which is very promising. The second is research, and I'm sure a lot of you in the audience are going to do some amazing work in furthering the research being done in this space to make sure that plant-based proteins can reach their full potential. Another point needed is parity between price, because as long as plant proteins are more expensive than the regular products in the market, the market size will always stay niche. But if price parity can be met, as we've seen with products like the soya chap mentioned earlier, the market size can expand tremendously. And lastly, we need to develop, new supply chains for novel ingredients. For example, in India, mushrooms and jackfruits are two ingredients that we have that can be used a lot in this space. I'm sure there are a lot of other ingredients, including indigenous ingredients that maybe not a lot of people know about, which everyone in the audience as food technologists can go out and find and research and bring into the space. So today, alternate proteins are perhaps in the same place where the internet was in 1995, where people had started to hear about it, but there was still a lot of potential left of things to be discovered and potential for people to make new concepts to improve the lives of everyone. Some other products in the plant protein space are soy-based products like tofu and tempeh. Today, you see a lot of people replacing their paneer with tofu and making some great tofu burjis. Another product which is from the Asian context is seitan, which is made with wheat gluten. One of the issues with this product is that it's got a lower PDCAS, but it's got an amazing texture and taste. And actually, Indians have been using this product for a long time as well, and calling it Mukundwadi and Sepuwadi. So the protein transition in India is definitely on its way. While Indians do love their dairy and meat, there's definitely a gradual switch happening, which I expect to continue as a trend moving forward, especially with the great work that GFI and a lot of the startups on the panel today are going to talk about the work they've been doing. In addition to that, big players are also looking at the protein market with HUL having entered the protein space and ITC having launched a plant-based meat brand. Smart protein and sustainable protein are extremely important in India, and increasing their usage can also help with reducing the burden of NCDs in the country. A little bit about us. We've launched a couple of products in the market which have got 2x and 3x the protein of the regular products in the market, and we've tried to match the taste of the underlying products using only plant-based proteins. Our goal is to help rebalance the protein ratio in foods using plant-based proteins while also reducing the GI and keeping the joy of taste. If you'd like to reach out to us, you can reach us on @itsprolicious on Instagram. We have a website, prolicious.com, and you can reach out to me personally at devendra@samyukfoods.com. Thank you so much, everybody.
Thank you, Mr. Chawla. If I may say, you have brought the entire opportunities to India in showcasing what are the numerous products that are already in India and how they can grow, and addressing the very real malnutrition concerns that India as a country has been dealing with for some time now. Thank you so much for bringing all of these global concepts of plant protein and putting it into an India perspective. Varun is giving us the Prolicious Khakra, मेरी तरफ से चाय सबके लिए. Great. And
I promise I don't have a brand deal with Prolicious, but it really is it is very delicious khakra. It doesn't feel like a protein khakra, it feels like a khakra. So congratulations to Prolicious on launching these products.
Devendra ji, thank you. And we had a COVID, and thanks to the khakra sent by you, it was a great food for during COVID. And the evening time snacks, and our protein requirement of 32% of the protein requirement was being made by your khakra. So thank you, Devendra ji, and we wish you all the best. And Shubha, he is also one of the food technologists turning from the CA to food technologies, the way he has presented the technical stuff.
I was like, okay, I need to go back and study up a little bit more. You guys are absolutely inspirational in the way that you have internalized the food science concepts. Really brilliant. Thank you so much.
And rather, all our speakers, because I know personally the other speakers too, like Karthik, and I'm also eager to listen to them, but they're also turned into the food scientists and technologists, and they're talking such a science. But the great part, Varun, what these people have done, they converted science into the commerce and money. That is more important. So really great.
Thanks everyone for your kind words, and most of what I've learned from GFI and AFSTI. So thank you so much for all the learnings.
Really kind of you, but appreciate the work you've been doing and the fantastic talk right now. Thank you so much. To bring in a little more interactive discussion and interact with people who have made these into viable businesses in India, we're delighted to introduce our panel for today. To take the session forward, I'm delighted to welcome Ms. Nicole Rock. She will be the panel moderator. Nicole is a senior innovation specialist at GFI, and she brings her experience in pharma, biotech, commercialization of technology, and innovation promotion to furthering GFI's business purpose in bringing about sustainable protein development resources in the country. Welcome, Nicole, and I hand over to you to take forward the panel discussion.
Thank you, Shubha. And thanks for the great presentation, Devendra, as well. Looking forward to learning more about you during the course of the panel session. Very quickly, I'm happy to introduce the rest of the panelists as well. We have Smita Devigere. She's the founder of Devigere Biosolutions, which is a biotechnology startup producing plant-based functional clean label protein concentrates for plant-based egg, meat, and dairy applications from local Indian pulses. Next, we have Anand Nagarajan. He's the managing director of M by S Square, a venture building platform. Anand is also a relentless entrepreneur and has started multiple businesses and has scaled multiple businesses across India. Anand is passionate about sustainability, and his platform has currently 4 investments in energy, agriculture, food, and finance. And we're most excited, of course, to talk to him about Shakahari, which is a plant-based meat company that we'll be talking a bit more about during the panel. Next, we have Karthik Dixit, CEO and co-founder of Evo Foods. Karthik's been an environmental vegan for the past couple of years now, and previously worked at an online grocery delivery platform, as well as India's first cultivated meat company. And now he's bringing his talents to Evo Foods, where he's creating a plant-based egg substitute. And then finally, we have Dr. Mukunda Goswami. He's a principal scientist of fish genetics and biotechnology at the Central Institute of Fisheries Education. He has more than 20 years of experience in fisheries, stem cell research, and fish cell lines. He's also currently involved in developing mussel cell lines for several indigenous fish species. Delighted to have you here. Thank you, everyone, for joining. I'm going to get straight.
Sorry, Prabodh here. We need to also invite Devendra ji as a part of the panel.
Yeah. Devendra will be part of the panel.
I did not reintroduce him because I just finished his introduction, but Ms. Chawla very much part of the panel, yes.
Great. So I'd love to get started with a round of questions about what each of you do. Devendra, it was really nice to hear during your presentation previously a bit more about Prolicious, but I would love for you to tell us a little bit more about your journey and your jump to trying to feed people delicious and accessible proteins through your snacking format of high protein snacks.
Hi, Nicole. Yeah, so actually the journey started with around the time when I met Varun for the first time. We have a common friend who's also looking at the plant-based space who introduced the two of us. And around that time, my dad had also been diagnosed pre-diabetic, and making a switch to increasing protein in his diet has actually brought his parameters back in line. So we looked at the plant-based space, and we looked at meats and everything. And then we actually thought that there's a big potential in just increasing the protein in daily foods, because that seems to be something India needs at a cost-effective, in a cost-effective way. And that's how we went about launching Prolicious, and that's where the journey began. And now we've got a couple products in the market, and we plan on launching a lot more products where we've increased the amount of plant protein in foods and reduced the carbohydrate.
Thank you so much for that. Karthik, jumping to you. Eggs, of course, are a widely consumed protein category across the country and has high penetration rates across the income pyramid. What opportunity did you envision when you started Evo Foods, and where are you today on the path towards that vision?
Thank you so much, everyone, for having me here. Yeah, I think, when you look at the plant-based meat market globally, right now what we are seeing is, it's maturing right very fast. And it's not even just 1% of the total meat market, right? And when you see at the egg market, it's a total, probably around $230 billion industry globally. Over 100 billion eggs are produced in India, approximately in the last, I think yearly consumption in India is really high, or production is really high. So I think eggs are, a very unique category as compared to plant-based meat or plant-based dairy, because in eggs, you have to really focus on, managing the right balance between nutrition, taste, texture, as well as affordability, which is the most important part, I guess, for the India market at least. So what we envisioned is we have so much crop biodiversity over here in India. We have countless number of varieties of mung beans, chickpeas, legumes, and whatnot, right? So why not take leverage of all of this and create products not only for the Indian market, but also for the global market? And that was the vision behind Evo Foods, and that's how we began. And the choice with eggs was pretty simple. Eggs are seen as less offensive, usually while switching, or, the switch is quite easy with respect to eggs. Nobody's as passionate about their eggs as they are about meat, let's say, while switching. So that's what, intrigued us about the plant-based eggs as a category. And most importantly, it is a very tough category to crack. If we crack it, then, if we really crack it, then, the world would be our oyster. So I think that was the motivation behind going ahead with eggs. And it's a huge, I would say, it's not even just 0.01% of the total egg market as of now, if you compare that with plant-based meat. So there's a lot of room to grow. It's vastly underserved and under-tapped as of now. It is evident from the number of players in the space. Of course, the challenges which I mentioned, having the right balance between taste, texture, nutrition, as well as affordability, will matter a lot. And that's why you are seeing a lot of companies now innovating in the sector. A lot of companies are trying to match that. And I think over the next 4 to 5 years, there will definitely be more players in the space, which we really want, because we want the pie to get bigger, and more people should come in and create different kinds of plant-based eggs. What we are doing is we are leveraging Indian crop biodiversity. So we have created Evo egg out of mung beans, chickpeas, peas. So those are the 3 main ingredients. And the concept is, these are the ingredients you have been having for the last 2000 years in your families. Your grandfathers had this. Now all these great ingredients, all this nutrition is in the form of an egg. So that's the concept we are selling to the Indian consumer. And so far we have received excellent feedback through taste tests on different parameters like taste, texture, aroma. And we have done several tastings with restaurants as well. They're very, very eager to have this as a part of their menu. So we have partnered with more than 20 plus brands as of now, and slowly we'll start gaining momentum. We are launching it into the Indian market in the first week of Feb, which is a really good thing. Of course, there were a lot of challenges, but yeah, those are the kind of motivations we had for creating a plant-based egg.
Thanks so much for that, Karthik. I'd love to bring Anand on now. Anand, you're of course managing partner of a venture building platform, but you're also CEO of Shakahari. You guys launched last year, and you are already seeing incredible momentum currently as you're scaling across the country. Could you tell us a bit about your journey?
Sorry, Nicole, can I just say something about Karthik? Because
sure.
I've been seeing his journey from when he came as a student to Mumbai, and he ventured out in the lab-based meat, and then accidentally moved to the other product. And I really congratulate Karthik, and Karthik is very humble. He's trying to explain how he has done, but I think every entrepreneur can take a lot of learning from the Karthik, how one should be determined. If you have a dream, a person who comes to the Mumbai with the dream and with the hard work and sincerity, you can get a success. And I think Karthik is the example of that standing. And really, Karthik, we are proud of you. And we wish your testing session is yet not completed. And now the entire panel, you should send us the product and we'll test.
Absolutely.
Thank you, Karthik.
Thank you so much, Prabodhan.
Karthik, it has been a pleasure to just watch you grow over the last couple of years. Anand, to you now. You've scaled multiple companies, but really want to talk to you about Shakahari and your journey towards setting up a plant-based meat company, and what's working well for you at the moment.
Hey, thanks, Nicole, and everyone on the panel. I think like everyone else, I have a Varun story here, right? So it's probably a year and a bit when I was on a call with Varun, and he was like, I think my co-founder actually said, hey, listen, this Good Food Institute, and this guy called Varun, I think we need to get in touch with him to know about plant-based meats. There was a random email, and I think a day later, or the same day evening, I think we were on a call with Varun. And to be here on this panel a year later, having launched product and in about close to about 300 locations around the country, I think it's been a very quick journey. So I think what's working, obviously GFI support is working, right? I mean, it's doing a fabulous job. Took us from 0 to 1 in probably a very, very short time, right? So we've done, in our platform, we've gone and built business in sectors that we had absolutely no knowledge about. And the learning curve is quite steep, right? But then it still takes 6 months to a year for you to be able to take it. But then I think GFI's inputs over there have been fabulous in kind of bringing that down to about a month and a half for you to get to know what you need to know and then be out there and launching products soon. So that's overall in the sector, I think it's absolutely exciting, right? You've never seen a sector where both the incumbent and the startups compete at the same point in time. Right? You see EV, you see e-commerce, you see any of the other sectors. The incumbent continues to do what they're doing and startups compete, or the incumbent changes and no startups come in. But I think the plant-based protein space is fabulous, right? I mean, you've got all the big majors having deep investments coming out in plant-based meats, and you hear of a brand new startup almost every other day trying to compete in this space. So I think that's absolutely working for it. Timing, I think, is fantastic. Apart from the devastating pandemic that we've had, people's awareness towards and curiosity towards the food that they're having, what they're consuming, sustainability is big. I haven't had a single conversation with someone in the last year, and having said plant-based meat, they have not taken a double back, come back and have a conversation with us saying this could be, just a random neighbor to an investor, right? I mean, everyone's interested in the space. It's on people's radars, right? And I think sectors very rarely go through this, and you have time periods when these start becoming, and I think plant-based proteins got that window now, which makes it absolutely exciting for us to be able to come in and launch product and companies in this space, right? So that's what we think is working in this sector. Almost everything right now. You've got talent, you've got investor, there's money in it, customer base is there. I think it doesn't lack anything right now.
And Anand, I think your products really do speak for themselves in mimicking taste, texture, aroma of meat, and is 100% vegetarian. So that's something to speak more of as well during the course of this panel. Smita, we often talk about the potential for India to be a plant-based ingredient sourcing hub for the world. And at Devigiri Biosolutions, you've been working to develop some of these high protein functional ingredients for the sector for a couple of years now. Could you tell us about how things have progressed in the sector overall and for you as well?
Okay. Good evening, everyone. Thank you, Good Food Institute, and then the Food Committee for having me here. To begin with, what we are making from past couple of years, the research, what we started with was in a conventional protein processing method, be it in soy protein or any dairy protein, we use a lot of chemicals such as solvents, acids, alkali to extract them. While doing that extraction process, the protein loses its functional nature. It actually becomes denatured. Our main purpose was to omit all these process. Why can't we extract the proteins using only water? One is we can skip all the chemicals. The other one is we can retain all the functionality of our proteins in its intact manner. So that was our purpose and vision many years ago. So it has taken a lot of trials, R&D, failures to come to this level, where today we have 30 tons of processing capacity of plant protein per month. So this is a very difficult and very challenging journey. We actually face challenges and failures through day in and day out. But finally, what we have come out with the product, our proteins are completely soluble in water. We can just mix them. They forms a very nice foam, not only for nutrition aspect, even for the functionality or the purpose why proteins are used in different applications. It also serves that purpose as well. So today we are very proud of the product, the way we are able to get it. It is nutritious, clean label, sustainable, highly functional, and versatile. So the application need not to be just in food. It could be also in sports nutrition. It could also be in skincare. Any other application where protein is required, we could use those proteins today. So this is where we are today, and we just started with our initial small traction and sales from the last 2 months.
Thank you, Smita. It's honestly been so exciting to see you post about, I've been seeing your posts on LinkedIn about your new product launches and things like that. And it's honestly so exciting to see. I think we may have lost Dr. Mukunda. So when he is able to join back in, I'll bring him into the conversation. But I'd really love to talk about, sorry.
Yeah, I am here.
Great.
Good evening. Yeah.
Good evening, Dr. Goswami. So
yeah,
the Central Institute of Fisheries Education, of course, was his recipient of a 66 lakh rupee grant in 2021 to conduct research in cultivated seafood. What do you think is driving this sort of momentum and increased interest in the smart protein sector, especially amongst the research community?
Yeah, good evening. Thank you, GFI. And thank you so much for giving the grant, and which might be the first time in the fisheries sector, a cultivated meat. So I have just joined the journey. I have to go a long way. Before this, after the first introduction, I wrote one mail to Professor Mark Post, and he mentioned about the GFI, and immediately I mailed Borun Deshpande, and he responded quickly, and then Dr. Claire from GFI. So that's why before that, I didn't know about this. I have been developing and characterizing cell lines, and I have been using those cell lines for other than cultivated meat. I didn't know about this. Then I have been motivated and inspired to take up this work, and participated in the grant process along with my collaborator from Virginia Institute of Technology. And then really this is so far we have been knowing about the fish, meat and all, which is in the original form. But again, now I have been hearing so many things about plant-based meat. So now people will be thinking how it is possible in plant and meat, then fish and meat, cultivated meat. So there are so many things and so many exciting products are coming. Even as a scientist working in this area, I don't know many of this, and it's a very good thing to know about this. So that's what my humble request to all those who are involved in this process, to make awareness, to know that more and more people will know about this, including the scientific, those who are working in this area. Suppose I have been doing this work, cell line and then come to know that this can be used for cultivated meat production. Then I have started my research. So now my team in my laboratory, so I have been engaging masters and PhD students for doing this kind of research. And definitely when I'll be getting something, because this is, I need to go a long way, because so many things are there, characterization of those cells and mass productions of those cells and ideal myocytes, and then collaboration with some other faculty members, then those things will be required. So, but before that, there is a momentum. People are knowing about this cultivated meat. This is a great thing. Because of this grant I have received, so now I have been talking people around this, So this is itself a big thing.
Thank you so much for your work. I think it's so important that the research community gets behind this smart protein sector, because it's really about building out that foundational scientific background before even the entrepreneurs can jump on board. So thank you, Dr. Goswami, for your work. I want to move now on.
Can I add one more thing?
Yeah.
Because see, it's animal protein. Among animal protein, fish has been contributing a lot, and this industry has been growing as one of the fastest food growing sectors in the world. So we are getting fish from open water, but which is declining, and then we are producing fish from aquaculture, which is conventional. There are many challenges. So if you can produce the fish, which will be a very climate resilient system with this cultivated meat, so definitely it is going to see change, and then a paradigm shift will be there in case of food production. Thank you so much. Thank you for giving the opportunity.
Well, thank you. Thank you for being here. So just moving on to ecosystem needs, the smart protein industry we've seen over the last year has finally moved into this phase of market activity after years of ecosystem building work, as well as, disruptions from the pandemic. And new markets like India have fundamental challenges across product development, pilot scale manufacturing, market testing, distribution, and even regulation. I want to just go through to each one of you and ask you, what some of the biggest challenges you faced across these areas. So Devendra, if we could start with you. One of the major challenges that people do highlight is, a lack of fundamental infrastructure, especially when you're doing product development. So how did you overcome some of these challenges, especially during the R&D stage for Prolicious, when you were trying to conduct experiments, when you were trying to get customer feedback and sort of improve your products before you were able to launch?
So going on ground is one of the best ways to do things. So whenever we needed to do research, I'd actually go visit DMart and Nature's Basket and see what's moving in both places. With some products which don't exist in the market that may be tougher. A lot of do have a lot of imported products though, so over there import substitution can be looked at. As far as the R&D part, working with partner labs helps. So the government has a lot of labs that can be accessed as well. Visiting supplier labs is also helpful. So I remember doing a lot of trips to Gujarat to figure out our technology, and we also worked a lot with AAK Kamani at the time.
Got it. Thank you for that. And I think that's useful information for anyone in the audience as well that's sort of thinking about, creating new products and, how you can get around some of these challenges. Karthik, as you're gearing up for launch, what would you say are sort of your major needs now?
Yeah, absolutely. I think a lot of foundational, let's say, infrastructure is still not there when innovative products are concerned. So most importantly, I guess, if you are starting a plant-based tech company, you are going to face a lot of challenges while, searching for a pilot facility, while searching for a co-manufacturer. So I think all of that needs to be improved. Let's say, there's a manufacturer or, there's a pilot facility who wants to rent out theirs. There needs to be like a platform in some way or the other where we know in which part of the country, let's say, in what quantities, our facility can produce. So these type of solutions will definitely solve a lot of challenges for entrepreneurs like me. And if let's say the market is concerned, I think, we definitely are looking forward to launch into more and more cities. So probably, let's say, access to excellent logistics providers, access to, distributors who can take our product forward, and access to, excellent research facilities as well. Whereas we can, let's say, create a normal formulation first and test it out at a larger scale, in the scale of, let's say, hundreds of liters first, to see if that works, and improve it further, right? Because it's a game of improvement. Once you have a tolerable product in hand, and once people start to accept it, let's say your initial adopters, then of course you need to improve that product even further to create that kind of impact. and these type of, let's say, facilities or help would be really instrumental in building smart protein sector from the ground up.
Thank you for that. And at this point, I'd really like to bring you back on, Anand, because you've been able to scale quite quickly. And like Karthik mentioned as well, lack of infrastructure availability has been a huge problem for this sector. So what has been your sort of major difficulty in getting the ball rolling here, especially when you were considering scale up across the country, and how did you get around that?
Yeah, I think it's got a lot of things, right? So we'd like to focus on what we have a lot of, right? And I think every time we talk about this sector, especially our product lines, or frozen product lines, because they mimic meat, and we still come with a very, very old concept saying, oh, there isn't a frozen supply chain in the country, which is like Schrodinger's cat. It's both true and untrue, right? I mean, it may not be there in BC cities, but then in the major cities where we're looking at launching, we've not had a problem with it, right? Frozen supply chain, last mile delivery. I think there's a lot working for it on the front end. Retailers' acceptance of this product, giving us shelf space, I think working really well. So there's a lot that's working for it. What could be better, obviously, is something that Karthik touched upon in terms of saying, what we're missing is a little bit of these facilities that can do a little more product trials coming in. We have our own in-house facility in terms of the flavor and taste solutions, because that's core to our business. We have those trials in-house. But then obviously in terms of product format, how do you move from R&D kitchen to production trials? I think there's a space gap in between that's there. High moisture, we keep talking about that a lot, saying, where's high moisture coming in? There are a lot of global supplies. I mean, supply chains messed right now because of COVID, but then that's for every sector in terms of saying, how we have raw material supply chain and inflation coming in because of that. But I think those are transient issues that get solved. But the rest of the ones that we call issues, I believe we should look at them in crowds like these as opportunities for people to come in and start putting up those point solutions. Like a co-working space for food product dev, if you may, right? Something like that. Or coming in and more research in terms of specific formats that people are starting to work on in smaller pockets, and then start feeding them into larger distribution chains. I think there's a lot happening in those spaces. You've got Thrasio type models that are coming. So you could just have a product, small distribution online, and then you've got, platforms that are ready to buy out those brands quickly. So it quickens the cycle of innovation, ideation to product launch. So I think a lot of things working, but then there's still point areas that are huge opportunities that we should be looking at and saying, people in the crowd could actually be looking at and saying, I want to go do something there.
Yeah, completely agreed. I think it's good to highlight, obviously, what has been working, but also, where more work can be done and where more work is required. Smita, I wanted to ask you, some of the biggest hurdles you have faced as a startup working really upstream in the value chain, because, functional ingredients from India, indigenous functional ingredients really have the potential to bring the cost basis for a lot of these products a lot lower. So I really want to ask you, what sort of hurdles have you faced in order, and what can be done more to help you scale up faster?
See, initially what we started was completely to challenge the existing traditional system. So we ourselves don't know where to begin with. So it has taken a lot of trials. So initially to switch with only water, we use only pulse flow and water to extract the protein. Once we actually able to do the lab scale, which equipments are like, how are we going to scale it up? So that was a major setback, and which equipments to use, because everything was very much new. And there was nothing already existing solution or existing setup in any other country, even to copy it out or like to do the similar trials. So that was the most challenging part. Like we have to use our own innovations and what all the thinking process with the existing facilities, how we are able to scale it up. But with a lot of trials and with lot of the networking, and we are able to come out of the challenge pretty quickly is what we could say. So scaling up was actually a hurdle. And then next was once we are able to scale it up and then have a product in the hand, where all it could be used. So we don't have exact facility to measure this protein functionalities in India. So if somebody asks like what is its homing capability, or like with respect to numbers, we cannot give it. With respect to the nutritional content and parameters, we have NABL certified labs to get it analyzed. But functionality is something where we have to apply and see whether it works or not. That value system or the analysis lab is still missing it out. We do not have it now. If we need the values, we have to send it for the other countries, which a bootstrap company like us cannot be able to handle such big costs. So that was one more hurdle. So I have to take out all those things, but we have to come up with our own methods to show that, see, look, our proteins are functional. So what I went, instead of showing them the physical values, I started creating a product. So see, this is what a regular protein can do. This is what our functional protein can do. So that helped us to come up with the hurdles what we are facing today.
Thank you for highlighting that. I think I really want to move into talking a bit about talent development, because I think this is a great platform to do that. The sector, of course, is scaling up overseas, and Indian talent, of course, is at the center of this growing sector. Many of the founders and research leaders in the field come from India, which of course mirrors other industries too. But we need far more talent entering the space, and particularly building it from the ground up in India. And this talent, of course, extends to many areas of science, technology, entrepreneurship. Dr. Goswami, since you're at the center of this entire research ecosystem, what steps do you think are necessary to create a pool of scientists and researchers who can really steer growth for the smart protein sector? Sorry, Dr. Goswami, you're on mute.
Yeah, before responding to your specific question, just I'd like to highlight one thing, which is, as many of you are involved in producing smart protein and all, because I am down with COVID, still I'm COVID positive, and many people are talking about that you reduce the amount of carbohydrate and increase the number of proteins and all. And those kind of whatever products you are talking, already Dr. Kartik and Dr. Devendra, they have produced so many things. So this is the time to catch it up, to make available more plant-based proteins, or maybe some kind of these proteins. And I don't know how many of these are available, commercially available in the maybe next in the supermarket and all. This is first. Second, regarding the point you are asking about to speed up this research, what I have been thinking about that, when we're talking about the sustainability of any sector, food sector, at the same time, we need to think about the sustainable research. Suppose I have got this grant, so maybe 66 lakhs and this. So do you know how much this amount I can use for actually to take up this myocytes or this maybe cells to that cultivated meat, you know very well. So this is just, I'm going to dig out and exploring and characterizing those cells. Okay. So I think if I'm in Mumbai, in place like Mumbai, okay, I'm very good enough. I have good experience in producing those fish cells. But at the same time, we need to work many things, no? Because if you are going to produce cultivated meat, you need to think about culinary effect like aroma, taste, food, all those things. Then again, serum-free, the food optimization of those ingredients, no? Chemicals, reagents we are talking. Suppose serum will be there, FBS will be there, and acceptability will be a problem, even though we are removing the serums at the final stage. So to speed up this research, we need a very good kind of collaborative research should be carried out. Suppose I don't have the all facilities in my laboratory, maybe I can buy something from this grant and all. So here IIT Bombay is available. So even I have started my work and I'm getting some good growth of the cells. But now I'm collaborating with here IIT Bombay. So they are making some scaffolds. So today only in my laboratory, they came and they set up it. So I'll be using those scaffolds. Maybe I will be able to use some kind of instrument which is not available in my lab. Maybe in ICT Mumbai is also there, which is a very good partner of this GFI. So GFI should take initiative so that we all the scientists working in this, we should work in such a way so we make this research sustainable. So whatever outcome will be coming, okay, this grant I am getting, then my grant will be over, my work will be over. No, it's not like that. So I have engage my MSc PhD student in this area team that I'll be using them or maybe another 5 years. And this kind of collaboration will be there, GFI supports will be there, sustainability will be there, then only we'll have some kind of in our hand. Otherwise it's just for doing research. Some kind of thesis submission will be there, some kind of publication will be there, and then you end of it. And then we'll not be reaching to that what we are thinking about, to speed up the research to get the ideal product to make cultivated seafood or cultivated fish.
Yeah, thank you, Dr. Goswami. I think you brought up a really great point. I think the industry is in like a pre-competitive stage where everyone really needs to be working together and collaborating together with the research ecosystem, with the entrepreneurial ecosystem, in order to lift all boats and really see this sector commercialized in the scale that we are seeing it in other parts of the world as well. And for a pre-commercialization sector like cultivated meat as well, it's so important for everyone to be working together at this point. Smita, I'd like to bring you in here. We have an audience of varied skill sets and talent pools. So I'd really love if you could talk about specific skill sets that are relevant to what you do exactly.
Yeah. See, basic, first to begin with, the very basic understanding of science and the basic molecular understanding of what is there in your ingredients, basically. For example, if you're working with the pulses, the basic nature of it, what proteins are, what carbohydrates are, what starches are, and what it is there, and what are its types, and then basic science understanding, and then the basic understanding of the animal cells and then the plant cells, and how we are gonna create a similar kind of a structure or a protein or the nutrition. Once we have a very basic knowledge, one very strong basic knowledge is the first in any subject, basically in whatever the field we are going to be there. And then building upon that, already there are n number of research available in all the research articles about different kinds of, even it could be microorganisms based or plant based or pulse based. The research is already there to pick those research and then to convert them into the knowledge and then to convert it into the viable product. So this is actually, it keeps coming when we actually start working on that. But first basic to begin with is the very basic understanding of the science, and then to start building upon that.
Thank you. And Karthik, I would really love for you to just talk about how you've been able to draw on your own skill sets to get started in the smart protein sector.
This is a very tricky question. I would say, I started with luck. Because I met all these amazing people really early in my journey, Dr. Prabodh, as well as Varun, who I've known since the last 5 years. So I think luck matters a lot for sure. Apart from that, it's just the ability to pitch your vision. I think that matters a lot too. If you want to start something in the sector, rather than explaining what you're doing now, explain what you're going to do. Or what it will look like 10 years from now or 15 years from now. I think that will really help build momentum across different people, right? Not only investors, possible team players, or possible co-founders. You have to really pitch in, and you have to really be passionate about the sector to be working in it. Apart from that, I would say the ability to just believe in yourself and go in that journey while chasing that bigger purpose. For example, my passion is to, my purpose has always been to remove animals out of the food equation. And that's going to take a long time, right? You need to have that kind of faith in yourself that at some point things are going to get hard. This is a very hard journey. I think all of the entrepreneurs which are there in the panel, I think they'll agree. Things will get haywire at some point. And, during this time, actually your patience and your ability to believe in yourself will really matter. Although, these are usually generic skill sets, but be patient. I think, patience is always a skill to develop. Whether you are a student, whether you are an aspiring entrepreneur, I think it takes patience to build a company which can last for, a decade, 2-3 decades, 5 decades, etc. So I would say, just patience and humility will take you a long way.
Thank you, Karthik. Anand, if you have anything to add to that as well, coming from not from a food background, and you've built out a really great team at Shakahari. So what would you advise anyone starting out in this sector and building a team?
I think there's a lot of great talent there. We need to look at comparable talent and then see how we can bridge the gaps. I believe our food scientists need to be like our entrepreneurs, curious. You made a very interesting point. It's not yet in a competitive space. So there's a lot of research that's done globally. I don't think we need to start behind the 8 ball of go back to the basics and saying, where is that? A lot of these panels, we end up talking about, we've got our own protein sources in India. Work needs to be done on seeing, what are protein sources that we can work in India. I think that's going to be a huge, huge opportunity for people to go in and start even coming up with credible, commercially viable theories in terms of saying, okay, here's exactly how we're going to take these protein sources, right? Soy has only that much legs. And something that we've been seeing inside Shakahari right now is saying, how do we look at a no soy product line in the very near future, right? We're not talking about years down the line, but we're saying in 1 or 2 quarters, how do we have a no soy product line? And how do we start moving in that direction in terms of, again, there's price sensitivities that come in.
When we talked about any material to be used for the biopolymers, we need to have it.
Fantastic, Nikolai. Fantastic panel. Fantastic panel.
You can just round out by, Anand, if you can round out your views, and then back to you, Devendra, just to talk about, getting people excited to really take that jump into enterprising and venture creation, and then we can round out.
The best part is with so many startups in the fray, right? There are internship and job opportunities with, this is not like going and working for one of the majors that you have to go through 17 levels of hoops, right? I know we're hiring like crazy. We're not able to find enough people coming in. I'm sure a lot of the other panelists here wouldn't mind being hit up on LinkedIn saying, listen, I'm a food scientist. Can I come in and work at your space? It's probably a phone call away for people to get those opportunities coming in. And I think if there are those kind of food scientists on this call on the other side, I think they need to look us up on LinkedIn and just hit us up and say, listen, can we come and work with your companies? And all these startups are looking for this kind of talent now.
Thank you for that, Devendra. Any advice for our audience looking to jump into the world of entrepreneurship and venture creation in the food space?
Yeah, so there's a few important in getting a startup to succeed. Okay, one is finding people with similar values to work with. Okay, and then knowing what skill sets you know and what skill sets you don't know, and hiring people or partnering with people who have the complementary skill sets, but are still aligned to the same vision and have the same drive to achieve a certain goal. Post the team building part comes the mentorship part. So once you've been able to start finding people with the same values and beliefs and the complementary skill sets, then also going out and finding extremely smart people who can mentor you and disagree with you so that you can come to the best conclusion and move the business forward in a quick manner with the right decisions is something that I feel is extremely important in the entrepreneurial and startup process.
Thank you so much for that. I'm just going to check with Varun if he has any parting thoughts before we hand back to Dr. Prabodh.
Hey, thanks everyone for that wonderful panel. Can you hear me well? Nicole, am I? Yeah, okay, yeah. Great. So I just wanted to, I actually cut my comments short earlier because I really wanted to hand over to Devendra and the panel to give their expertise as well. I just want to round out what everyone was saying because I think it's important for us to underline some of the issues here. But firstly, I think just to show what's possible, I'm just throwing a slide on the screen here. And I know it's got a lot of numbers there, but this is basically a slide that shows the environmental impacts of some of these foods compared to what we currently have. And it, I think, underscores for us, especially as we recover from the pandemic, as we look to build a better food system over the next decade, there are orders of magnitude, many-fold improvements in terms of land use, water use, air pollution, chemicals and waste, and greenhouse gas emissions that come out from these proteins. And so diversifying our protein supply is absolutely critical. And that's true of plant-based meat that's already in the market. And it's also true of, at least at a theoretical level, cultivated meat that would be made with renewable energy compared to their conventional counterparts. But when we look at the amount of investment or support that has got into the space over the last 10 or so years, the total combined R&D into meat alternatives has been about $1 billion, which sounds like a large number. But then when you compare it with a very similar industry, renewable energy, you'll find that in 1 year, 2020, over $500 billion with a B, that's not a typo, $500 billion with a B of investment went into renewables, and over $32 billion in addition to that in public R&D funding went into renewables. So we think that's great, right? Renewables make a lot of sense to invest in. And we think that actually clean meat and clean protein should get as much attention and support as clean energy. And that's really our opportunity here. So if you look at some of these comparable numbers, right? Renewable energy and alternative proteins, we think that there's an opportunity to get to parity. So you look at on the right there, or the second to last column on the right there, less than $10 billion in investment. So not R&D, but investment in history, versus trillions of dollars in just 6 years that have gone into renewables, right? The good news is that countries all over the world are taking a stand here. So countries like Singapore, Qatar, Denmark, USA, Japan, Korea, Israel, UAE, etc., Canada are playing a huge role now in advancing this space. But there is a huge amount of work for us to do. And we think that India should also take a stand. Everyone in the audience, whether you're coming from science, business, or policy, we would love to work together to make India a major powerhouse and leader within this sector. We do have, as some of the speakers were saying, this huge crop biodiversity, talent pool, biomanufacturing and other manufacturing and industrial opportunities here. And just to underline, this is my last slide, but just to underline some of the points made by the esteemed panelists, as well as Shubhaprada, Dr. Halde earlier, we should be doing things like supporting open access R&D and infrastructure building through centers of excellence, research grant programs, university curriculum, creating a conducive policy environment for this, and building a talent pool and skills across the value chain. So we would love to work together. We have a lot going on in each of these domains with AFST, with the panelists here today, and with government and other industry players. And we'd love to get together and really build out this mission for smart protein over the next decade. Thank you so much. And you can reach out to us through AFST or just at india@gfi.org.
Wonderful, Varun. Wonderful, Varun. And I think we are for 24 minutes delayed our program, but I think smart protein required smarter time and more time. And as you have said that investment in renewable energy is more, but I think we will give more time to you because it is very important that we should get heard. But silver line about Varun, before you join this GFI in India, but if you see the growth of protein industry, plant-based or lab-based or aqua-based, the growth within India in last 5 years is doubling every 1 year. So I think we should see that as a silver line rather than comparing with the other sectors. I agree, comparing with other sector is always important, but as a food particularly sector, R&D spends are less than 1.2%. Vis-a-vis pharmaceutical is 9 to 10%. So anyway, there is a way, there is a silver line, and we need to keep active about this and we need to keep talking about it. Shubha, wonderful. Thanks for your coordination. I really thanks all the speakers. They actually gave their thoughts so vocally and also expressed what they need from the association, from the society, from the government. And anyway, we will come out with some kind of outcome of this session. I would like to thanks to GFI also, Varun and Nikolai and entire team who have supported this. On this platform, I am also appealing, Varun, if we can do some kind of MOU with AFST, which we will be taking it forward. So year and year, we can take all our joint program together and you become a natural partner for not only this one of the conferences, but then whenever it will come about protein, whether it is a plant-based or lab-based, we will be partnering together. So I really thanks everyone. I don't have any closing remark because Varun has nicely shown the last slide of the Varun is nothing but the over discussion which we are doing together. I think you have summed up very well. Thank you. Take care of your health. And I really appreciate your concerns, your advice, your knowledge and interest in the field. Thank you. Over to Shubha.
Thank you so much, Dr. Prabodh, for those concluding remarks. Varun, of course, summed up excellently well. And I love the fact that we are looking at an opportunity of $500 billion. You will be, I'm sure, having, after this session, have inspired very many students. We will see our next crop, if I may use that term, of success stories like Karthik, Anand, Smita, the entire entrepreneurs who came together today to share their knowledge. Thank you, GFI, once again for a brilliant session. And we will close the Smart Protein session with this. Thank you all. Stay safe.
Thank you, everyone. Take care.
Thank you. Bye, everyone.
Hello, Subhadji. This is Prakash Alami from CFTR.
Hi, sir. How are you?
Fine. What about you?
So you are attending both the session. I could see there also.
Attending many sessions. Though people made me very busy. Now I am co-chairing the session, so please attend.
Thank you, sir.
Don't
Our apologies. Our session went a little over time. We started a little bit late. Our apologies for keeping.
I am worried that Professor Thorat has to be searched now somewhere.
There Professor Thorat is with us.
Thorat sir, pranam, namaskar.
Namaskar.
Actually, Thorat sir, this online session is like you go to one of the marriage hall where 4 or 5 marriages are happening. You don't know which is your actually bride and the couple, and then you enter into the one marriage hall, take a lunch, and then you realize that is not your marriage hall.
In spite of having interest to attend all that, we could be able to.
Thorat Sahib, namaste.
नमस्ते डॉक्टर साहेब. काय नाही आता तुमच्यावर जबाबदारी सगळी आता देशाची यायची त्याची आम्ही आता सपोर्ट करणारे माणसावर.
करायचं काय वेळ आहे का आता? Nishata, are you coordinating this?
Thank you, sir.
Sir, I'm the president for Mumbai chapter. I'm a food technologist from CFTRI, and I work at ITCFSAN, which is FSSAI's training center in Mumbai.
Nilesh Amrutkar sahib, namaskar. Kaise ho?
You are MSc.
Yes, sir. 98 batch.
We have just finished our smart protein where I was chairing, and
yeah, anyone from the organizers file?
Sir, Vaishnavi is here.
Yeah, if they can just give us a green signal, then I go with
Vaishnavi.
Yes, ma'am, we can start the next session.
Is it okay? We can start.
Yes, sir, we can start.
What is your name?
Vaishnavi.
You are from the IT side or what?
Yes, sir.
Wonderful. So good evening, everyone. I hope I am audible.
Yeah.
Also, wonderful. We are in this track 2 of a technical session number 23. And this session name is food biotechnology, food microbiology, and fermentation technology. Fermentation. I take this opportunity to welcome all the delegates first for this session specifically. From Mysore, of course, our headquarters, then Jalna, Aurangabad, Mumbai, more importantly, and of course Parbhani, and any other places in India also. So the chair of this session is Professor S.S. Thorat. If Professor Thorat can just show his hand, it will be easier for us to identify. Yes. And I have a great pleasure to introduce the chair of this session. Professor Thorat is a former head Department of Food Science and Technology, Mahatma Phule Agriculture University, Rahuri. He is accomplished a food technologist by his education itself, M.Tech in food science and PhD again from CFTRI Mysore. More than 33 years of experience in teaching as well as research and extension in the area of food science and technology, focusing on food microbiology, quality and safety. Steered several committees at national and state level. That includes few of them. I would be happy to read them. A member in the subcommittee appointed by the governor, Maharashtra government, to oversee the organization of Avishkar. Expert panel member in FSSI with reference to the alcoholic beverages, contaminants, biological hazards. Also, he served as a member in a Bureau of Indian Standard, FAD system, in a food group. In fact, I am now in the 17 in the water. Then he is also associated with was associated with the Ministry of Labor and Employment Government of India in formulating the skill development model for food processing. Several of these committees in the Maharashtra government that comprises of the food safety and drug administration. Then ex-member scientist in the Maharashtra Council for Agriculture, nominated member in alcoholic beverages, as I said, nominated member coordinator for ICR NTA for the Food Science and Technology Ministry of HRD Government of India, member Academic Council. Several of those papers from his research activities were presented in the conferences, and they were at least 5 which was selected as the best paper award too. Professor Thorat has delivered till now the more than 60 innovative talks, and also acted as chair and co-chair, and I am very happy that he is the chair of this session, where I have to be a co-chair with him. Published more than 80 papers and around 140 articles, authored 11 books, developed 16 recommendations for food process technologies, guided 29 M.Tech students and 11 PhDs. He is a recipient of fellowship of ICR for his studies starting from the B.Tech till PhD, and he extensively worked in the area of food microbiology, fermentation technology, quality and safety. Professor Thorat is very generous. I can see in his CV that he has donated more than 35,000 rupees to the NAM Foundation. I hope next time AIFSTI should approach Professor Thorat to sponsor one of the sessions also, I believe. With this, now I hand over to the chair to tell us about this session first, and then about the speakers also. Professor Thorat.
Yeah. Thanks for nice introduction, lengthy introduction. And indeed, as I am retired, I become very happy to listen to you. See, I welcome all the speakers, co-chairman, and participants for this technical session. As Dr. Prakash has already narrated the things, In this program, as per the report, there are two more speakers, including myself and Dr. Prakash, Nagendra Shah and Professor F.A. Masoodi from University of Kashmir. So there will be 4 expert talks.
Sir, only 3 lectures.
I think this Shah has made
tomorrow.
Tomorrow.
He is talk tomorrow because now it is already late night for him.
Right. So there will be only 3 lectures. 3 lectures. So before starting the lectures, I will introduce Dr. Prakash Halami, who is working as a chief scientist, and he is head of microbiology and fermentation technology, where I did PhD. So I am proud of Dr. Prakash. He is again having additional charge of food protectants and infestation control department. He did his MSc molecular biology and biotechnology from IRI, then PhD in biotechnology, Raman Research Fellow, USA. He has total 28 years of experience, and he is a member of Abiotic Residue Technical Committee, FSSAI. Then FAD 14 committee member and convener in Bureau of Indian Standards, expert advisor to many laboratories in India, fellow member of societies which are related to microbiology and biology, senior scientist award, microbiologist society. He received he received number of awards, few of them Senior Scientist Award of Microbiology Society of India 2021, Lalji Gurjo Smarak Nidhi Award of AFST 2013. He has delivered invited talks around 60 in national and international conferences, webinars 15 during this COVID period, and published more than 115 papers, written 12 book chapters, and he has 4 patents to his credit related to biotechnology. He has guided 11 PhD students and MSc MTech around 80. He is recipient of GICI fellowship, DAAD DAD fellowship also. And very important thing, he is serving to the nation, particularly region of the CFTRI, as a nodal officer for holding the responsibility of COVID testing center at CFTRI Mysore. And he is coordinator CFTRI surveillance project. When I was doing PhD, he was there as a scientist, and I'm proud that he became head of that department. So with this small introduction, shall I go for a presentation or shall I introduce Masoodi sir also? What's your opinion, co-chair? Prakash. Prakash. Hello. Am I audible? Prakash?
So you can introduce the next speaker also, and then I will start my presentation.
Yeah. Then other speaker, he is also senior.
And we can have a question and answer at the end of all the 3 speakers.
Yeah. Dr. Professor Farooq Ahmed Masoodi, he is working as Dean Academic University of Kashmir. He did, hello sir, Masudi sir. He did MSc from PIU Ludhiana and PhD in food technology from GB PIU Pantnagar. He has 230 publications to his credit and received many awards, ranked among top 2% scientists of the world by Stanford University USA in 2021. All India Food Processors Award. Then Best Paper Awards also he received many. Career 360 Award in 2017, and he has visited a number of countries for presentation of the technical papers and attended conferences in Japan, UK, Bangladesh. And very important thing, he organized 8 symposia at University of Kashmir. And he has to his credit 6 projects from different financing agencies as a principal investigator and 8 projects as a co-PI. Then he is a member of number of board of studies and academic council of a number of universities in India, and panel member in FSSAI, food additives. And he is also working as an expert in DBT projects sanctioning. So with this introduction, we will start the technical presentations. So I request first Dr. Prakash. Dr. Prakash.
Yeah,
Dr. Prakash, you can start your presentation.
They have to give me access for the presentation. They have
Yes,
to
sir,
disable my connection.
Sir, can we share your presentation?
Yeah, that is what my screen is disabled.
Sir, are you sharing your presentation from your side?
Yes, yes.
Okay, sir.
Your side is disabled, no?
Yeah, it is disabled right now.
With permission of chair, I have to seek one clarification, Professor Thorat.
Sir, please share your screen, sir. You can share now, sir.
Can everyone see my screen? Is it okay? Chairman sir, my screen is visible.
Yes, sir. Yes.
I take this opportunity to welcome Professor Farooq Masudi also for our session.
Thank you very much.
Masudi sir, can you hear me?
Yes, absolutely, you are audible.
I can't hear you. I think you must be mute, I think. Good evening, everyone.
Okay, sir, unmute your this mic.
No, already muted. Am I audible now?
Bharat sir, can you hear me?
Yeah.
Wonderful. Yes.
Yeah, you can start.
Thank you. Thank you very much. Sometimes in between my actually system gives a trouble. So I hope it will go smoothly this time. For this technical session number 23, I have a pleasure to deliver this invited talk. So first of all, I would like to thank the ICFOST and 28th ICFOST for giving me this opportunity. In the series, I believe this is my third invited talk in AFSTI conference. Previously, I spoke in Parabani, and before that in Amritsar, and once after this will be fourth one, I would say. And I selected a topic, vaccine as an emerging adaptable biopreservation technology for sustainable food products during COVID health emergency. I specifically emphasize this last three words since I am associated with the COVID testing as well as the zero surveillance project of Span India CSIR project. How bactericin or the biopreservatives derived from the food grade microorganisms can be useful to extend the shelf life of the perishable product, especially in the COVID health emergencies, because we know that last 2 years we have seen several times the lockdowns, the disturbance in the food chain establishment, the closure of several of the shopping complexes, shopping markets. How actually this, the very old biopreservation technology can be useful now, you know. And from this angle, I am trying to put forth my view. Though my laboratory works out predominantly on the aspect of the gut microbiota, you know, where we are looking for the health and wellness of an individual, consuming again a right food, consuming a food which is incorporated with several of the friendly bacteria. I have only some 20-25 slides which I prepared for a 20 or 25 minutes presentation, and even actually I recorded, which was some 26 minutes presentations. So what I am actually going to start with the notable revolutions which you have seen in 1960s. You know, several of these revolutions, green revolutions, which took place in our cereal and millets, and the Norman Borlaug's contribution in this green revolution, and from an Indian perspective, the M.S. Swaminathan's, you know, in the developing the wheat varieties, the rice, several cereal and millets. So definitely we have the surplus food production now as a primary agriculture is concerned, but with reference to the secondary agriculture, what we see is the food loss. So post harvest, which is again the one of the important area of CFTRI, where I am here now from last 28 years, and then what we see actually in the post harvest losses, you see majority them in the perishable products like meat, fish, dairy products, you know. The same losses you will see in the cereal, though you will see that they are mostly the dry products, but the losses are there in the post-harvest stages. Not exactly because of the microbial contamination, but you will see the pest, storage pest, because from last 1 year, I am actually associated with one of this important department of food production and infestation control, where we are actually trying to address how the food losses can be minimized. And this is a big challenge. So with this background and with the present status of food safety is concerned, you know, from food microbiological angle, we see the very important problems emerging foodborne pathogens. They are just attacking our processed food. They are attacking our fresh food. Then we see a very classical problem in microbiology, the drug resistance. Drug resistance, though it is a clinical, but due to the overusage of the antibiotics, now we see that drug resistance actually entered in a food chain, and then you will see the bacteria which are actually found in a food. VRE, vancomycin resistant enterococci, MRSA, methicillin resistant staphylococcus aureus. Staphylococcus is very common in our food products, or the bacillus cereus. So such drug resistant bacteria, how we are going to treat? What is the method to spread? And this natural spread of antibiotic resistance, as we see, not only in the clinical setting, but it is in the environment, it is in the food, it is in the animal husbandry, right? So these are actually some of these pathogens which are actually common in animals, veterinary field, in animal husbandry, in the poultry, as well as in the food. You know? And today, the whole world is engulfed with this tiny virus. and disrupted several of our activities. And then definitely right now, I think we are in very much peak. For us, you will see that Mysore actually receives almost reports almost 2,000 to 3,000 positive cases. Our department actually now, in fact, most of our students are actually sleeping. They are with a very high fever. Very critical situation actually in whole Karnataka. In Karnataka, actually, we report 30 to 40,000 cases. Only in Bangalore itself, we have almost 20,000 cases. Very, very serious. This article actually made my work a little bit easy. How I can connect my topic with the COVID-19. Okay, so we see the distortion in the economy, the primary sectors, the essential items, and then you will see that several of the perishable food items are unable to reach. Each and every household do not have the refrigeration. Each and every processed food do not have the preservative, and if we add the preservative, we see several their effect, and that is what actually FSSA actually looking for, how we actually chemical preservatives can be reduced. How the chemical preservatives they affect our health, and what is actually the remedies for that. And this is what actually I am proposing or suggesting, how the food grade microorganisms can be brought it in the practice and saved. And this is why actually I am going to tell about this novel molecule, which is not a wonder, but to be exploited. So as far as their classification is concerned, we have basically only class 1 and class 2, but there are few reports actually with reference to class 3 and 4 also. So these are ribosomally synthesized antimicrobial peptides. Basically kills closely related microorganisms. With reference to the historical perspective, the bacteriocin like polycin from E. coli was identified in 1928, almost at the same time when penicillin was discovered. Nisin was the first antimicrobial substance identified in 1928 from a dairy bacteria. Nisin stands for an inhibitory substance from Lactobacillus lactis. Several such molecules have been identified, and we have actually like the subtidine. So you can see that IN represent that it is a bacteriocin. Similarly, the pediocin, acidocin. So based on the genera from which that antibacterial substance has been identified. I had actually the opportunity to work with this Professor N.T. and during the 2000-2002, and he was actually the first person. His group was the first in the world to tell that bacteriocins are the antibiotics, or these peptide antibiotics are gene encoded one. Okay, and why gene encoded? Because our conventional antibiotics are produced by multi-enzyme complexes. On the other hand, bacteriocins, especially the class 1 bacteriocins, whose genetic basis was not available before 1988. So this is actually the first paper in Nature, describe the gene encoded peptides, and they have proven this hypothesis in a bacteriocin epidermin produced by a Staphylococcus epidermis. So this is actually the structure of epidermis is, which has, you will see, the several lanthionine bridges, at least the 3. And this lanthionine bridges, how in a protein gets incorporated. So we see basically serine and threonine get dehydrated into dehydroadenine and dehydrobutyrene. This dehydrated amino acids gets conjugated with the cysteine, the neighboring cysteine residue by the thiether bridge. So this thiether bridge, you can see, is a distinct than the disulfide bridges, because disulfide we see the 2 sulfur groups, but here it is the single one. And what is the significance with reference to the biological activity or their thermostability? That these thiether bridges are much more stable at a high temperature, as well as for the proteolytic cleavage. And this is the reason why actually nisin or any antibiotics are heat stable, because they have the thiether bridges built in them. So this identifying this kind of a mechanism or post-translation mechanism, was very important to make genetic engineering possible while synthesizing or producing this kind of molecule. And so this is how actually the nisin is. So nisin is a pentacyclic antibiotics with a 5 thiether bridges, And this 5 ether bridges, as we see, are post-translationally modified, as I told here. And this actually provides much more rigidity, heat stability, and better antibacterial spectrum. And as I told that since these are gene encoded, it facilitated engineering them and producing in a bulk as required. And that's why actually we can produce these molecules in a larger quantity in a fermentation. On the other hand, using the genetic engineering principle for producing the antibiotics is much more tedious. As far as their application is concerned, antibiotics cannot be used since we use them for the therapeutic purpose. And once we are using for the therapeutic purpose, we know that excessive usage of them, there is a possibility of developing the resistance, and that's what actually I was talking in my introductory slide. Now, similar to nicene, there is another molecule known as subtiline, which is produced by Bacillus subtilis or the spore-forming bacteria. So nicene is produced by the acid-producing bacteria. Subtiline, it is the spore-forming bacteria. And then, if you see, their genes cluster is similar, and they have spectrum is similar. So, in other words, the subtiline characterization or study at a molecular biology approach, or the subtiline biosynthesis is one of the important milestone in studying the nicene as a model system with reference to their gene organization, with reference to their expression and regulation, as well as their application also. This is actually one of the reports from our laboratory where we have seen the introsine production by Enterococcus faecium. And in this case, actually, what happens is, just like nicene and subtiline, introsine A is also produced by the mechanism of signal transduction. And how this can be actually evaluated is shown here, that how the induction, how the introsine production is being self-induced. So the culture filtrate, in the culture filtrate, presence of introsine acts as a signaling molecule. How this can be demonstrated, that you have a inoculum prepared, you centrifuge those cells and you remove the culture filtrate, wash the cells with the water, and then if you plate that one, you will be actually able to see the cells which are washed with the water produces a small zone compared to the cells which are plated with the culture filtrate. In other words, the culture filtrate has the lower concentration of introsine, that itself acts as an inducer for the production of introsine. Okay. This is actually another example with reference to the pediosine, which we have demonstrated in our laboratory, that the pediosine production is basically interspecific. But we have seen that pediosine has been distributed widely in a different genera and species of a lactic acid bacteria. You will see the very interesting story with reference to the pediosine production from our laboratory. What I am going to tell you is that the pediosine production is well known or well characterized from the Pediococcus acid lacticea, as well as to some cases Pediococcus pentoscaceus. However, in our laboratory, we demonstrated that this bactericide is being produced by a third isolate like Streptococcus equinus or the Enterococcus, as well as the Lactobacillus plantarum. Lactobacillus plantarum production was reported, but we demonstrated Lactobacillus plantarum producing a pediosine from the carrot. Now, how actually this work is significant, because the diversity of the lactic acid bacteria which you isolate are obtained from a different sources, they actually gives the wider adaptability, because Pediococcus acid lacticea basically identified initially from the fermented wheat. So you will see that the Pediococcus acid lacticea has a better adaptability in a wheat product. However, our study shows that the lactic acid bacteria, which has the ability to produce pediosine in a different ecosystem like vegetables or the dairy products, so this actually provides the wider adaptability when you design the preservation strategy, because pediosine is very, very effective against Listeria monocytogenes. And Listeria monocytogen, everyone knows that it can actually grow in a refrigerated condition. It can actually grow in all type of a food material, starting with the vegetable, the meat product, the dairy products, and many more. So we have actually studied the phylogeny of a pediatric producer using the information available in our laboratory, and this was actually very it was a totally new information. We saw that how this gene cluster actually differs from the non-pediatric. So you will see the reference culture, Pediococcus acid lactacea H, reported from your university, Wyoming University in US by Professor Vivek Ray, and our Pediococcus acid lactacea culture NCIM 5424, yes, similar operon, but Enterococcus faecium, or Lactobacillus plantarum, they totally had the pediasin operon comprises of only 4 genes, POP A, B, C, and D. But you will see specifically the flanking genes. So these flanking genes actually are associated with exchanging this Pediococcus locus, exchanging this pediosin operon in a different cultures. So that actually information is reported from our group. Similarly, we actually checked the plantaresin. Plantaresin is another important culture because the several of this vegetable fermentation, you will see that Lactobacillus plantarum is a very common culture found, and then you will see that Lactobacillus plantarum now has at least 25 different genera and has at least 350 species. We have recently developed such a database exclusively for the Lactobacillus plantarum, since it has a high number of a diversity. I am talking here with reference to the bacteriocin produced by Lactobacillus plantarum, and then you can see actually the different cultures. When we did the PCR, we could see the amplification of a different size. What does it indicates? That this different culture has a different type of a bacteriocin operon, number one. Next, actually, we did the sequencing of this plantaresin operon, and we could actually establish that our culture, these are actually our culture, had the distinct plantaresin operon than what people have reported. So this actually has provided the very new information with reference to the diversity of not only the bacterial culture, but the antimicrobial peptide produced by the culture. And this culture actually we isolated from the vegetable sources. What Lactobacillus plantarum diversity reported previously was from either dairy source or the meat products. Now I will go with reference to using the biosensor technology for screening the antimicrobial compound produced by these cultures, the bactericid produced by this culture, how rapidly we can characterize with reference to their mode of actions. So you will see a very simpler procedure with reference to the Nissin production, where the signal transduction mechanism is being used, or signal Nissin is being produced by the signal transduction mechanism. So how it works? When the Nissin is there in the culture filtrate or any inducer, in other words, it actually activates or gets recognized by the histidine kinase, which is specific for that antimicrobial substance. Here, let us consider Nissin. This histidine kinase, which is recognized by, which is being recognized by the inducer substance, as I said, Nissin, activates the response, phosphorylates the response regulator, and this phosphorylated response regulator will activate the gene, a promoter of the gene, which is specific only for the production of that antibacterial substance. So this is actually why Nissin activates its own biosynthesis. This is the mechanism. Why Subtilin activates its own biosynthesis. This is the mechanism. Why Androsin activates its own synthesis. So this is the mechanism. So when we actually, if we fuse the beta-galactosidase gene, structural gene like this, you will be able to identify that the substance found in the extracellular substance, extracellular media, has the property or ability to induce this gene. So based on this, one can design a screening strategy exclusively to select the Nissin. So you have a Nissin promoter, you have the gene cassette like histidine kinase and response regulator, and then you have this engineered culture, you have the positive and negative test control, and then you have positive and negative control. You can identify in a high throughput several thousand culture within a few hours of time, just like a ELISA test, just like a glucose oxidase for monitoring the glucose level in the body, So this test actually facilitate to identify a specific compound for their mode of action. So accordingly, using this principle, we design 5 reporter bacteria. Number 1 is the bacteria which actually can sense the cell wall antibiotics having the cell wall activity, inhibiting the cell wall. So we use here for standardization the penicillin, and we see the blue coloration. We don't see if we use any other antibiotics. So antibiotics which acts on the cell wall, we actually measure the blue coloration. Another reporter which we developed was specific for the protein synthesis, YGI. So we use the neomycin as the standard or reference substance, and we validate our result. Then for the DNA, so we use the nalidixic acid, and then any substance which will inhibit the DNA synthesis will show the blue coloration. Similarly, for RNA synthesis, the rifamycin here, YVGS reporter, and then FAB triclosan. So if any of these substances are available in a 5 set of experiment, we will be able to tell rapidly what is the mode of action of the given substance. When we assay by a conventional agar-well diffusion method, we will be able to tell only the inhibition zone that do not tell the mode of action of the substance. But here we will be able to tell rapidly what is the mode of action of the substance. Okay. Based on this study, we have actually the specific reporter for nisin and then subtilin also. Why I have to tell this one? Because we screen such a large number of nisin producer as well as subtilin producer, and then we could actually identify some of the variants in that which are present naturally. Okay. So using this subtilin reporter, we characterize one of the novel culture, Bacillus licheniformis, producing a subtilin-like antibiotics. So we identified that molecule by the analytical HPLC, and then subsequently by doing the mass spectra, and we could actually make out tell that not only the Bacillus subtilis produces subtilin, but Bacillus licheniformis also. Bacillus licheniformis, which is basically a probiotic culture, also has the ability to produce a subtilin-like antibiotic. So this is actually totally a new report available from our study. Similarly, we use this methodology to screen large number of nisin variants. So as I was telling that when we do the agar-well diffusion assay, you just see what I can say inhibition zone. But when we use this reporter bacteria, you see this blue coloration, and this blue colorations will specifically tell whether this inhibition zone is because of the nisin, because of subtilin, because of the cell wall antibiotics, because of the antibiotics inhibit the DNA, inhibit the RNA, inhibit the protein synthesis, or fatty acid. Very simple. So similarly, we screen the nisin producer from a different sources, and I will not tell much story, but just to tell that a nisin A producer we obtain from the meat. Again, nisin A producer from the soya product, and then you will see a very interesting story of nisin Q. Some 5 years back, nisin Q in one of the 8th or 9th variants identified for the nisin was from the milk sources, but we identified nisin Q from the fermented fish, and this is actually a totally new information we report, and this was actually possible because we used the biosensor to screen the culture and then subsequently combined with the molecular biology tools. And when we have analyzed the genome of the this particular culture, we could able to actually tell that this nisin Q is a new nisin Q is a new and novel antibacterial peptide or nisin variants, and comes from this fermented fish sources. So similar methodology actually we use for the subtilin production. One of the subtilin production, I already told that Bacillus licheniformis, which is again from the dairy source. We have characterized the subtilin producers because Bacillus is basically a soil bacterium. But then you will see that Bacillus you can find in a soybean fermented food, because we know that soybean is a alkaline fermented food, right? Radish, fermented rice, and even idli or dosa batter. Idli dosa batters are again the mixed fermentation. It is not only the lactic, but it is a lactic bacillus and yeast fermentation. So in a dosa batter, actually, you will get a nicotine-like variants, nicotine-like antibiotic producer, and that's why actually this kind of substances being naturally preserved or can act as a preservative when we actually ferment them with the right culture, in other words. So these are actually the several different experiments to tell that our culture produces a substitute-like or nicotine-like variants, found even in our several of the fermented products. So just to combine this story and tell that what exactly we wanted to tell. So one of this important milestone is that we identified the Bacillus subtilis producing a interspecific subtilis producers. Similarly, we identified the Bacillus licheniformis culture, which produces peptide antibiotics and has antimicrobial activity similar to rifampicin. So why this rifampicin comes in a picture? Because rifampicin is the only among the very few antibiotics which are available for treatment of Mycobacterium tuberculosis, and this works on inhibiting the RNA biosynthesis. So since we have a large number of antimicrobial peptides which acts on the cell wall, we have a large number of antimicrobial peptides which acts on the protein biosynthesis. We have very limited set of such molecules which acts on the RNA biosynthesis. Our laboratory actually report this culture NCC2514, has the ability to inhibit the RNA biosynthesis. So other accomplishment includes Bacillus licheniformis, because bacitracin production by Bacillus subtilis is reported. We tell that Bacillus licheniformis also has the ability to produce the bacitracin. And bacitracin, we know that it is commercially available for treatment in the animal husbandry. I already told about Bacillus licheniformis, subtilis-like antibiotics, which we have named as a sublichenium. Then Bacillus licheniformis, a peptide antibiotics inhibiting RNA biosynthesis. Where are the results? These are the results. How we compare the beta-galactosidase activity with reference to the rifampicin, and then you will see the 50 microliter of fruit culture filtrate is equivalent to 50 microgram of a pure rifampicin sample. So we are actually presently working out identifying the biosynthetic gene of this peptide. So similarly, we have several other molecules, we are different variants, and this variants actually has a different antimicrobial spectrum, just like Bacillus licheniformis, which actually we said that it inhibits the antibiotic resistant bacteria, and the antibiotic resistant bacteria just now in the news that almost 20 lakh people per year they are dying, a very big number. So such, and by 2030, I believe we are actually may experience almost 50 lakhs people will die because of the antibiotic resistant bacteria. And this antibiotic resistant bacteria cannot be killed by the antibiotics because they are already resistant to those antibiotics. So we are actually finding out the antimicrobial substances from natural sources, from the fermentation broth, from the microbial origin, whether they can actually kill or can be used for controlling those bacteria. We have actually one of this very interesting story about the enterocin, which will kill the Escherichia coli, because gram-positive bacteria, Dactylicin of the gram-positive bacteria, do not kill the gram-negative bacteria like E. coli. But we are actually here the result, which actually tells that if you treat the enterocin, combination of enterocin and lipase makes the gram-negative bacteria lyse. We have the result for that. Okay. Similarly, we actually identified the diversity of antimicrobial substance produced by Bacillus culture obtained from the fermented food. So such cultures can actually act beside their diversity. What I'm trying to tell you here is that such a diversity or such a different novel molecules can be obtained from the bacteria of a fermented food origin, and this bacteria can be used as a bioprotective or protective cultures beside their ability to ferment the food. Okay, so this is what actually In addition, we actually use this baptizing of the bacillus culture in incorporating in the plastic LDPE films, and we made this plastic as a bioactive plastic. So what is the bioactive plastic means? Bioactive packaging material is referred with reference to which has the ability to inhibit the pathogenic bacteria. So initially we check against Listeria monocytogen, but then you can actually see that this antibacterial peptide, which is incorporated in the LDPE film, has the ability to inhibit the growth of Staphylococcus, Bacillus, Micrococcus, Listeria, and many other pathogens also. We identified recently one interesting culture, Bacillus subtilis, from the soya chutney, and initially we saw that it inhibits, makes a very wider zone, very big zones, against the Micrococcus luteus, Subsequently, we saw that the concentrated culture filtrate of this bacterium was able to kill some of the gram-negative bacteria. And then actually that was surprised because, as I told, the gram-positive bactericid do not kill the gram-negative. Now, how this information comes? What is the scientific basis? We know that Klebsiella pneumoniae, Shigella, or Salmonella are gram-negative, and they are getting inhibited just like how Micrococcus luteus. So we saw that this culture has the ability to produce a dual antimicrobial substance. One, a sublikenine of the subtilin, and another is the subtilosin. And due to the synergistic action of these substances, there is a possibility that this pathogen or gram-negative pathogens are getting inhibited. So this is what actually a recently report came from our group. Premila is doing a PhD with me with the SASIR, and then she published this paper in a LWT. I think she is online also. Yeah. So by combining these activities, there was actually a call for proposal. I have just 2 more slides, Chairman sir. Not very long.
Okay. Carry on.
Translation actually wants to utilize these biopreservatives. So we have the sublikenine produced by Bacillus licheniformis, the subtilin and subtilosin, and Nisin Q. So what should be done next? Now, so we have actually the this proposal with the DST, a process for fermented production of bactericin, and to demonstrate the biopreservation efficacy. And we want to actually make this antimicrobial substance in a fermenter, in a bulk, and see which are actually the product, food commodity, the perishable food commodities can be treated and shown that they can also be stored. Their shelf life can be extended. And for this purpose, we have this at present, our work at a technology readiness level at 4. And we actually made this proposal to DST just 15th January was the last date. 13th we have submitted. I think it will be here. January 13 is there. And Unique Biotech Hyderabad and Star Herbs Bangalore, they came to collaborate with us, who will be basically doing the scale-up studies, doing the downstream processing, doing the helping us to standardize the methodology for the biopreservation. And then we see how best we can also contribute to extend the shelf life of the perishable food product, in other words. Everyone will ask what is the conclusion of this presentation. So in a literature, bactericin or the this bactericin like molecules, especially the Nisin, everyone knows the Nisin has been used from 1950 in canned and dairy products. Clostridium especially, because in canning, spore farmer do not die. Spore remains viable. Clostridium, which are actually associated from or comes from the Clostridium botulinum. Right? It's here. Similar to the pedicin, you can see being used, in several of the seeds. All these dairy products in Europe, US, you will see the consumption is very high. So most of the bactericides are used in the dairy industry. We extend the shelf life to ensure that the product is free from Listeria monocytosis, because initially I told that Listeria monocytosis is a pathogen, can grow in a refrigerated condition in room temperature and even 37 degrees and all. Similarly, bactericin very successfully used in the meat industry, though we don't use much meat product as a fermented or the for a longer time, but then you can still see one or other day. I think meat products storing or preserving will be one of the important aspects, I think, for the among the Indian consumer also. Now you will see in the Europe, US, this is introcin, bactericin, genic or pedicin has been used in several of these meat products. So I have some of the example with relation to vegetable products also. The Nisin has been used, pedicin, enterocin also, and then you can see that in the several vegetables. Salad is there, fruit juices are there. because these products we don't sterilize. These products difficult to remove the microorganisms, and that's why using these antimicrobial peptides or the culture which produces this antimicrobial peptide is very much important and required, because each and every food technology or food processing methodology do not eliminate the microorganisms unless and otherwise you heat kill them. Each and every food products is not pasteurized or sterilized or the heat process. So which are not heat process, definitely there is a role. Each and every food commodity cannot be stored in a refrigerated conditions. So with this, I just quickly introduce my biopreservatives here from the lab. Then Professor Thorat already introduced my good activities also. And then last group is the food protectant and infestation control, which is also very important with reference to the food protection, from the store grain. With this, I thank the organizers for giving me the opportunity. I thank the chairman also for not telling me the time is limited or anything. Yesterday I was just prepared with the 25 slides. I will quickly read with the saying by the Alexander Fleming. I don't know how it is can be correlated with what I was telling. It is the lone worker who makes the first advance in a subject. The details may be worked out by a team, but the primary idea is due to the interpersonal thought and perception of an individual. Sir Alexander Fleming. Thank you very much. I look forward at the end of the session for any question and answer, from my presentation. Thank you. Thank you, Chairman, sir.
Thank you, Prakash, for nice presentation. I congratulate because we also worked with our PG student, this biopreservation by lactic acid cultures and bacteriocins and all. But the work you carried out, because we were of the opinion that they are only active against gram positive and there are limitations for this preservation. So through your painstaking efforts, you could be able to identify the strains or as well as biotechnologically manipulating the genes and all that. You could be able to get very good bacteriocins. Another issue regarding biosensors, this cellular biosensor, this is also, I appreciate your work. And regarding inhibition of the cell wall synthesis and protein synthesis and all that, beside this hindering the RNA biosynthesis, this is also wonderful research. Another thing, packaging again, you have quoted these bacteriocins and bioactive packaging also we have developed. So these all are very need-based areas, and future is looking for such type of technologies. So I wish you good luck for getting the funds for the scale up of this, because that is the need of the day. Otherwise, this research will be there in the lab. So it should come to the benefits of the society, and hope it will come out of such technologies in future. Thank you for nice presentation. So next, myself.
Yeah, thank you, Professor Thorat, for those nice words and best wishes. Hope we can make it can contribute to the food industry, to today's consumer, and to the nation in large. As I already introduced the chair plus come a speaker. So I would request Professor Thorat to go ahead with his presentation on fermented food as medicine. Professor Thorat, please.
It is, the as per the demand of the ICFOST, I prepared this. So I will share that video, and I will be here for the queries. You can share it. इथे चालू कर. बरं. विचारायची गरज नाही ना.
काय विचारायची?
विचारू का? Is it audible? Prakash? Is it audible?
Yes, sir, Professor Thorat, it is audible.
Yeah, okay, okay.
Sir, you can go ahead with your presentation. We can hear you clearly. Please go to first slide number 1. Introductory slide. Title slide, I mean.
Dr. Prakash, we were given to understand that our recorded presentation will be played.
What's the problem? Hello?
We were given to understand that we got our presentation recorded yesterday or day before yesterday, and we were given, I was given to understand that recorded presentation will be played there.
I could not. Hello?
Hello, Dr. Prakash?
Sir, hear me? Thorat sir, can you hear me?
Ha.
Now you start presentation. Somebody is talking, the background is there. Either you can make your presentation on your own.
Acha.
According to the slides, not at all issue.
So, shall I go for fresh presentation? Okay.
Yeah, you can start with the
Yeah,
fresh
okay.
presentation only. I think that would be better.
Just a minute.
Professor Thorat, you are mute. Yeah, you can
Full
start
screen.
presenting this one only. Yes.
Yeah. No problem.
Yes. Wonderful.
Is visible.
Yeah, good.
Okay.
Please go ahead.
So I have selected this topic, fermented food as a medicine, because everybody is speaking now. The diseases which are prevailing in the society, enormous amount of the diseases, they are coming up. Never diseases, they are coming up because of the contaminated food and other reasons also. So we will go through one by one. What are the causes? See, in spite of our good agriculture production through white revolution, then blue revolution and agriculture green revolution, we have record production of food grains, then fruits and vegetables also, milk also, eggs, meat, poultry, and all that. The country has also witnessed recorded production of the sugar. So in spite of all that, our population is suffering from number of diseases. See, we can define the disease as any abnormal condition that causes disruption in the functions of the body tissues, organ, or entire organism. And each and every disease is recognized by set of specific set of symptoms. Normally, there are a number of ways to classify the diseases, types of the diseases, but I took here 3 types of the diseases mainly: nutritional deficiency diseases, communicable and non-communicable diseases. So nutritional deficiency diseases, we learned in our 12th standard or 10th standard that number of these micronutrients because of their malnutrition, we suffer from number of deficiency diseases. Nutritional deficiency diseases, it is estimated that more than 2 billion people suffer from hinder hunger, that is micronutrient malnutrition globally, with nearly half living in India. So it's very alarming situation. Recently, the published Global Hunger Index 2020 indicated that among 107 countries, India ranks 94th. So our condition is not better than Nepal, Pakistan, Bangladesh, and Indonesia. So we have to think for the better nutrition. If you see the micronutrient deficiency, particularly vitamin, number of vitamins, they are deficient in our diet, and we have to take this daily because these are not synthesized in the body. So as per ICMR's recommended dietary allowances, we have to take in our diet, we have to include these vitamins in our diet. So vitamin A, 62% population is deficient, riboflavin, vitamin C, calcium, also 65% deficient, and folic acid 35% deficient. India is a zinc deficient country. Because of deficiency of this, 8 lakh deaths are happening annually due to zinc deficiency, of which 4,50,000 children are dying because of zinc deficiency. So this is list of the diseases which are caused by a number of vitamins: vitamin A, C, D, E, B1, B2. I will not go into the details. For example, vitamin A deficiency leads to blindness, and that person will be infection prone. So minerals also, similar way: calcium, chromium, copper, iodine, iron, magnesium, phosphorus, and zinc. They are required for the regulations of the body functions. If you see the health status, before 1990, the communicable diseases because of unhygienic conditions and contaminated food and water and all that, the percentage was around 54%. Those are communicable diseases, and non-communicable, it was 38%. If you see the situation after 2016, the same has been reversed. Communicable diseases are reduced to 27.5%, and non-communicable diseases around 62%. So non-communicable diseases, short form I will use NCDs, contributed to 61.8% of all deaths, while the communicable diseases contributed to 27.5% of all deaths. Non-communicable diseases kills 41 million people each year, equivalent to 71% of all deaths which are occurring due to different reasons. Random genetic abnormalities, heredity, lifestyle of the lifestyle or environment, contaminated food, etc., can cause non-communicable diseases such as cancer, diabetes, asthma, hypertension. Number of diseases like this. If you see the communicable diseases, they are grouped into endemic, epidemic, and pandemic. You all know about this. because of COVID-19. Again, everybody is aware of pandemic diseases which are occurring in number of continents. Those are pandemic, epidemic, local this, and endemic, very in pockets. So such type of diseases, they are occurring in the maybe infection of cholera, Shigella, Staphylococcus aureus, and all that. So as per the records, 25% of the deaths are mainly due to infectious diseases globally, which includes tetanus, measles. Out of this, the respiratory infections, they contribute much more. See, this is the vicious cycle. If a person is undernourished, then he will be prone to the infection. And once infection occurs, there will be malabsorption. In spite of taking good amount of the balanced diet, the malabsorption will be there. Again, this malnourished people or population will suffer from the infections. We have seen that more than 62% diseases are NCDs. Why there is increase in the NCDs nowadays? This is because of free radicals, which are oxygen containing molecules that has one or more unpaired electrons, making it highly reactive with other molecules. Radicals can have positive, negative, or neutral charges. They are formed as necessary intermediates in variety of microbial biochemical reactions, which are essential. But when generated in excess or not appropriately controlled, this radical can break a havoc on broad range of micromolecules, which are performing essential or vital roles in the body. Free radicals are also called reactive oxygen species, and excess of these in human or plant causes the oxidative stress. So I have shown this picture where these are very unstable, highly reactive molecules. This is because of free radicals. They are increased in our environment and food also because of enormous use of the pesticides in agriculture, fungicides, and other plant protectives. Then for treating the animals, veterinary drugs are used. Their residues are coming in either milk or meat. Non-permissible food additives. See, Food Safety Authority has given the list of permissible food additives and their limits also. But some of the industries, they might use excess use of permissible food additives. Then adulterants is a big issue. And cleaning chemicals which are used for cleaning and sanitizing the equipments, those residues also, they are coming in the food, and they are increasing the amount of free radicals. The consumption of refined and processed foods, trans fats, artificial sweeteners, certain dyes, adulterants, contaminants, additives, heavy metals, chemical residues, all these are contributing to formation of free radicals. So as I told you, these are the reactive oxygen species or reactive nitrogen species. So first column, these are the names and the second symbol. Again, third column is reactive nitrogen species and their symbols. So number of these reactive oxygen nitrogen species, they are playing role. So oxidative stress in the body, as I told you, if there is imbalance between antioxidants and reactive oxygen species, then the free radicals will take part in the reactions, and abnormal reactions will take place in the body. See this, as I told you, this electron transfer chains, mRNA damage, lipid peroxidation, mitochondrial activities. So these generate ROS, reactive oxygen species, and if they are much more, then person will start aging. So this will lead to membrane alterations, lipid protein damage, and ultimately the organelle dysfunction, which will lead to cancer, osteoporosis, dementia, atherosclerosis, obesity. So these free radicals, what they are doing, as I told you, these are unstable species. They will try to steal one or more electrons from the healthy atoms, which are required for vital functioning in the body. And the very purpose of this will not be served if free radicals will take the electron from the healthy atoms. So this oxidative stress will damage the cell. So these are the causes of the oxidative stress. In short, the diet, smoking, alcohol, pesticide residues, exposure to toxin. So number of these reasons are there to create the oxidative stress. In addition to this, damages immunity also. You know, there are two types of the immunities, innate and adaptive immunities. And these are the different elements of those immune systems. So because of damage, of this due to free radicals, brain will be affected, heart, kidney, skin, multi-organ failure, joints, and all that. So there is heavy damage because of this free radicals or reactive oxygen species. So there should be balance between generation of, because the reactive oxygen species, they will be there in the body. But these are to be removed or eliminated. For example, this glutathione, plasma glutathione peroxidase, then superoxide dismutase, they are there in the body, which will neutralize the ROS. In addition to that, other oxidants, vitamins, for example, C and E, these are to be supplemented in diet, and other antioxidants are to be supplemented in diet to neutralize the effects of reactive oxygen species. So to live the good life, as I told you, the reactive oxygen species and your antioxidant balance should be there. So this what antioxidant do. See, these free radicals, instead of taking the free radicals from the healthy atoms which are required in the body, the antioxidants will offer the radicals, so electrons, sorry. And once the electrons are accepted by the free radicals, they will be stable. And nowadays, everybody is aware. And if you go to doctor, the patients are asking, sir, prescribe me some antioxidants and all that. Such a awareness is there. So instead of getting antioxidants from the doctor, you can include the good diet, so that through that you can have a number of antioxidants. One of the groups of the antioxidants which are there in the food, they are polyphenols, stilbenes, phenolic acid, lignin, and all that. So it's very high number of these phenolic compounds are there, which are present in food. Only we have to categorize the food which are having high this antioxidant activity. See, the fermented foods, they are very good for the health because they are partially digested because of the enzymatic activities of the microorganisms. The complex compound will become converted into simple one. And in addition to that, the bioavailability of the vitamins will be increased because they also form the complex. So they will be reduced through the action of the organisms. These vitamins will be made free and they will be available to the body. In addition to that, your minerals also, they are present in bound form. They will be released and will be available for the body. In addition to this, bioactive peptides, they are synthesized. A number of these bioactive compounds are synthesized during the fermentation. One of them is anti-hypertensive. These are immunomodulators, mineral binding effects, anti-hypertensive, and ACE, angiotensin converting enzyme, which is a receptor for these viruses, including your coronavirus also. So this is to be inhibited so that spike protein will not enter in the viruses. So these are anti-proliferative peptides as well as opioid peptides. So number of these peptides, they are formed, which are having functions, desirable functions in the body. In addition to that, dipeptides, number of dipeptides are formed in fermented foods, which again possess ACE inhibitory capacities. So these I already explained. So amino acids, the number of amino acids, they are again synthesized by the organisms. The enzymes also, number of enzymes, they are synthesized by the organisms. And that's why the complex compounds are converted into simple one, and they are very easy for the digestion. Then conjugated linoleic acid. This is very important, vital again for the lowering the LDL cholesterol, promote immune functions, and bone formation also. So number of these organisms, they enhance the production of CLA, conjugated linoleic acid, as well as omega-3 polyunsaturated fatty acid, omega-6, and all that. So prebiotic, probiotic, already Dr. Prakash has have the presentation how these are useful. Then polyphenols, these also number of polyphenols, they are formed in fermented foods. Malolactic fermentation, this ferulic acid is formed during the malic acid when it is converted to lactic acid, causing the production of novel compounds, trans-ferulic acid, and some flavonols, which are present in wine, because this type of fermentation is there in wine, malolactic fermentation. And in alcoholic fermentation, resveratrol, epicatechin, catechin, caffeic acid, all these are formed. Meat and meat products also, they are good sources. As I told you, the bioavailability of the fermented food will be increased. So bioavailability of zinc, last two lines of the slide, zinc and ferrous minerals in fermented pulses can be increased by 50 to 70% and more. Vitamins, B-complex vitamins, they are synthesized in the fermented foods. So deficiency of which causes diseases, vitamin K also, then folate, riboflavin, pantothenic acid, pyridoxine. So all this. So here are a few products, fermented milk products, wherein the formation of health promoting compounds, phenolic compounds, then gamma amino butyric acid, GABA, which is useful for the neurotransmission. Then CLA also, folate. And this ACE inhibitors also, angiotensin converting enzyme inhibitors. So these are again fermented milk products, wherein these compounds are there. So grain-based fermented foods, again these essential compounds, they are there. Here also the same. So almost all fermented foods, they will be having health promoting compounds. One paper I could be able to get this information, this thiamine, riboflavin, niacin, pyridoxine, all these are increased. See, this is the milk, and this is the fermented buttermilk, yogurt, and kefir. So wherein you could find there is increased amount of these vitamins. This is published in Journal of Applied Microbiology. So during fermentation, the microbial metabolism enhances micromolecule digestibility, improves bioavailability. Mineral present in plants have very little bioavailability due to their formation of complexes. with phytic acid and all that. So these are released in the fermented foods and they are available. So probiotics again, these are there in the intestine. They are immunomodulators. Then they have metabolic effects. So these are better drugs. They are good and bad bacteria. So management of good bacteria is always better. So this is already explained by this. So normal flora in the intestine contains harmful as well as good bacteria, and probiotics. They are the beneficial organisms. So mechanism of action, already Prakash has narrated this. They synthesizes the bacteriocins, hydrogen peroxide, pyroglutamins, and short chain fatty acids, which are acting as antimicrobials. So this is again one of the beauty of the probiotic culture. They accommodate the places in the intestine, and there will not be place for the bad bacteria to accommodate there, and they will be expelled from the system. So competition for the nutrients will be there. So if good bacteria are there, then bad bacteria will suffer from the undernutrition and they will be expelled. In addition to that, they synthesize some immune compounds also. So probiotics, they should pass all the hurdles which are there, and they should get into the gut, and they should survive there. So these are bugs which are better than drugs. So wine also during aging, a number of these peduncle oaks are used, or sessile oaks or white oak. These are used for aging of the wine, which are very good sources of the compounds which act as antimicrobial as well as antioxidants. So there is huge list of this. These are identified in wine. Then beer also, it contains, because lager beers, which are aged beers, they will have more amount of the polyphenol content. So these are cancer protective polyphenols, cardioprotective resveratrol. So resveratrol, this is known now that this protects the infection, cardioprotective, prevent aging. So red wine are good source of this. So these are the actions of the resveratrol. So as I told you, immune functions also are strengthened by vitamins as well as the minerals. So vitamin D, for example, calcium triol helps to restore the immune functions of the macrophages. So each and every these vitamins, they are having role in building the immune systems. Vitamin B6, vitamin B12, folate, zinc, minerals also, they are helping to build the immune elements to fight against the diseases. Selenium, then magnesium. So we can say that microorganisms contained in many common fermented foods can serve as micro factories to generate nutrients and bioactives with specific nutritional and health functionalities. See, Maimonides, he has quoted, live sensibly. Among 1,000 people, only one dies a natural death. The rest succumb to irrational modes of the living. So 1 out of 1,000 natural deaths. Hippocrates, this is father of modern medicine. So because of bad diet, diseases are happening in the society. These are not the punishment or something like that. So he let food be the medicine, or medicine be the food, quoted by Hippocrates about 2,500 years ago. Is certainly the tenant of today and is receiving overwhelming response now. Philosophy behind is focus on prevention, then cure. Thank you. Thank you for giving me the opportunity to present this small presentation. I think it will be beneficial for the students, MSc, PhD students, and all that for planning, because fermented foods, these are very ancient, and you may not to prove the safety of this. And number of these ethnic fermented foods. Again, Masudi Saab is going to present that after me. So thank you for your patient hearing and giving me the opportunity to present this small presentation. Thank you, Prakash, for co-chairing.
Thank you, Professor Thorat, for such a nice, wonderful lecture, which you have shown how the aging actually is the matters. And then we know the Tilly Metchnikoff theory, the longevity of life. And then very simple reason, because of having a better bug in our gastrointestinal tract, and that better bugs comes from the daily consumption of the fermented food. And as you said, that definitely we are now looking for the prevention, whether it is a COVID or diabetics or the cardiovascular or high blood pressure, fermented food, and fermented food. Just to tell that one of our former employee, D. Milo by name, he turned this week 100 years. And means his birthday has been celebrated recently. So just I thought that most of our colleagues from CFTRI, they are aware about that celebration, because we can see a large number of messages, compliments for his birthday wishes. We know that there are several thousands people in Japan who are actually crossed the 100 years, and very simple reason, because of the high amount of consuming a fermented food. We supposed to consume actually 100 to 200 grams. Just a few days back, we had a webinar on fermented food, and then that is what actually I was specifying particularly, where our consumption is within 100 grams, 50 grams, 10 grams. Most of us, we don't consume also fermented food. Just to tell the viewers that, and just to support the Professor Thorat that he was telling, we have just recently accepted review article on therapeutic potential of fermented food. In Journal of Applied Microbiology, I will share the copy with the several readers. I just appreciate the pictorial representation which Professor Thorat was giving. Very nice to get convinced and understand how in the gastrointestinal tract the probiotics moves. Just like how our vehicle find difficulty go in the traffic. So from that angle, if any questions is there, definitely we will see at the end. Since we are running short of time, I know this is the time access for the evening walk. Most of you people to make health and wellness, see how immune system you can build up, do a little bit of yoga also, perhaps and many more activities. But definitely last interesting talk, last talk will be very, very interesting. From all the way from University of Kashmir, from Professor Masudi, who has been already introduced by the chair. So I request Professor Masudi to go ahead with his lecture. Himalayan fermented vegetables, problems and prospects. Professor Masudi, please.
With the permission of the chair, I would like to put.
Continue, sir. Continue.
Sir, in fact, I have another meeting with my vice chancellor and some deans of the university at 7:30, which will be followed by a meeting with Canadian delegation.
Sir, we are unable to hear you actually.
I don't know what has happened. I'm not.
Sir,
he is audible to me.
Sir, with the permission of the chair, Professor Thorat. I have to attend one meeting with Vice Chancellor at 7:30. This meeting will be followed by another meeting with a Canadian delegation, Shastri Indo-Canadian Institute's delegation at 8:30. So I express regrets for leaving the session at just within a couple of minutes, but my recorded presentation is already there.
You can share the abstracts or conclusions and all that, if you have time.
Number one. Number two, I really enjoyed this evening by listening to the presentation by Dr. Prakash and by Professor Thorat. It was
Thank you.
Highly valuable and informative for me. And hopefully this is opening some sort of ways for collaboration with both these.
Sir, आवाज सुनाई नहीं दे रहा, थोड़ा सा.
मुझे तो आ रहा है प्रकाश,
मेरे को तो कोई
मेरा आ रहा है.
तो आपका आ रहा है?
See, actually, he has a meeting with Honorable Vice Chancellor, and some foreign delegation is coming. So I think he could not able to.
They're just from Canada. It's an online meeting with them. It's online.
Online meeting.
Yes, sir. Yes,
Prakash, could you hear to me?
Yeah, I can hear you very clearly.
Yeah, that is the problem with Masudi sir.
Yeah, exactly.
So online meeting is there with Canadian delegation and
From the
Honorable Vice
ICFOST
Chancellor.
team can just brief us or update us.
Yeah, that's what I told him.
Yeah.
That you abstract, you can conclusions you can say.
Exactly. But otherwise also no harm, because we are very much actually interested to hear, sir.
Yes, sir. Professor Thorat, I was given to understand that only recorded presentation will be played there. So I'm
Okay.
not prepared right now with the slides for that presentation. But just briefly, I would like to submit. This presentation is about the upgradation of this traditional technology.
Okay.
One important problem which whole of the Himalayas face in these fermented foods, or particularly fermented vegetables. The months of October and November are most suitable for fermentation of these vegetables, because in this period the temperatures are most suitable for fermentation of these vegetables.
Correct.
Whole Himalayas, it ranges between 14 to say 18 or 19 degrees centigrade. So this temperature is most suitable for growth or for fermentation of these vegetables. Not only for fermentation, but those specific flavoring components in these fermented vegetables we experience in this temperature range. But in rest of the year, though fermentation may take place, but it won't. It will be either very brisk fermentation, and we don't get those specific flavoring components. That's why, in order to control this fermentation, we have developed a fermenter. We can go for fermentation round the year, and where there is by circulating that heating medium in the external jacket, so that we can control temperature. Plus, there is a system, there's a probe for monitoring the pH, etc. And within the major advantage of this fermenter is that we can produce pickles round the year, and then the quality of the pickles also maintained, because that fermenter, there is a provision for continuous mixing and remixing, which prevents mold growth. Otherwise, the conventional traditional technology, that we make use of those open pots or even plastic containers, and there remains an apprehension of growth of mold growth at the top. So this fermenter, it overcomes both these problems. This is one. And second, for this Himalayan region, another technology for processing of these vegetables is dehydration, solar dryers, or sometimes those conventional dehydrators are used. We have upgraded this technology by dehydrating them in microwave assisted vacuum dryers. And in my presentation, there is already I have my presentation, which is I have put those photographs there. I would like to request the organizers if they can play that recorded presentation.
Yes, sir. Just a minute.
Please.
If first IFT team try to rectify the issue, we are unable to hear Professor Masudi actually.
My bad luck.
Okay. It happens. It happens.
We will try to record that.
Especially Dr. Prakash is completely unable to listen me.
He is unable to listen. I will narrate.
But I really enjoyed this evening by listening to both of you. I really enjoyed it.
Thank you, sir. Thank you very much.
Thank you, sir. Now he is
friends, very old friends actually.
So we should have been together physically this evening. We should have been together either in Mysore or in Bangalore or in Mumbai or in Kashmir. But just the situation has prevented.
Yeah, beyond our control.
I'd like to thank organizers of the ICFOST to give me an opportunity.
Hello, who is speaking?
presentation probably.
Hello. Vinay is there? Hello.
So with the permission of the chair, I would like to leave the session.
Yeah, sir.
Professor
Continue.
Thorat?
Continue, sir.
Okay, sir. Good night.
Okay.
Good night.
Okay. Good night. Good night, sir. So only chairman and co-chairman.
Exactly. Thank you, Professor Masudi. Hope we will have some other time. We will interact more, and then we will be in touch. So thank you once again for participating in ICFOST, and specifically we had a great opportunity to interact with you in this our technical session, food biotech, food micro and fermentation. I will be actually happy to see your abstracts afterwards. Thank you.
Thank you, sir. Thank you. God bless you all.
Thank you. Thank you very much, sir. Now we had basically the three presentations, myself, then Professor Thorat, and then Professor Masudi in this wonderful session, which we are already late by half an hour. Now I request the chair to conclude the session, and then accordingly the report will be submitted with summary.
Part of this session.
The secretary.
This they are putting this.
Looks quite all right. I think we should go ahead to listen.
Yeah. It will take 20 minutes or more. We can. And other participants also, they will come to know.
Exactly.
Right.
Please
Sir,
go ahead.
Okay.
Sir, we are sharing Masudi sir's presentation.
Yes, please.
Okay. Carry on.
The topic that I have chosen for my presentation this afternoon is Himalayan vegetable processing problems and prospects. As all of us know that the country enjoys a special status in terms of the production of fruits and vegetables.
Sir, everyone able to see your audio is clear?
Yes.
Yeah, it's clear.
Okay. Thank you, sir.
Yes.
Mainly because of the reason that we have different types of climates in different regions, different parts of the country, which range from temperate climates to subtropical, tropical, and so on. So it is because of this very reason, we not only produce diverse types of vegetables, but we produce vegetables or fruits around the year. So you can find that in some part of the country, you will find that there is very slack season or production of fruits and vegetables is very less, but at the same time, in the same season, in other part of the country, you will find bumper crops of fruits and vegetables are produced. Let us have a cursory look on the statistical figures of the country, which are almost updated and have been notified, have been given by our this National Horticulture database. According to this data, we annually produce about 100 million tons of fruits and about 191 million tons of vegetables, different types of vegetables. And during 2020-21, India export fruits and vegetables worth 9,940 crores of rupees. So this gives us an idea about the potential of the production of fruits and vegetables in the country. But the major problem which we face is that a significant quantum of this produce is wasted annually. We are not in a position to utilize it properly. And secondly, from producers' field to consumers' table, the fruit or the vegetable, it loses a significant that proportion of its nutrition or its nutritional constituents. Again, this pertains to statistical figures of the production of or the wastage of these fruits and vegetables. This is being discussed in different fora of fruit processing policy, discussed by policy planners, by technologists, by processors all over the world. But just let's summarize it. According to FAO, it's around 1,850 million tons of fruits and vegetables are produced globally. But out of that, 44% of fruits and vegetables produced in developing countries, that is lost between its, say, harvest and consumption. Similarly, according to some survey of Indian Council of Agricultural Research's CIFET Institute, that the fruits and vegetables, in case of fruits and vegetables, the post-harvest losses range from 4 to 15% or more than that. And it varies from commodity to commodity depending upon the perishability or the nature of the fruit or vegetable. Then there are different those techniques which we can use to lower down, to utilize this proportion of the produce, which we can convert into value-added products. And this again, these technologies have been discussed. They are being used for reducing these post-harvest losses or minimizing this wastage, etc. But the overall percentage of fruits, vegetables, which we process in the country, it's very less. It's 3%, which is very less when we compare this percentage to our total production, or it is very less when we compare this percentage with the percentage of the quantum of produce processed in other parts of the world. Then coming again to this, how to minimize these post-harvest losses of fruits and vegetables. As I told you, losses can be in two ways. One is that from producer's field to consumer's table, it gets rotten because of its own physiological activities. The fruit may lose its nutritive value, or it no longer remains marketable if we don't handle it properly scientifically, because we categorize fruits, vegetables, most of them we categorize as perishables. So if we don't adopt those scientific practices, scientific post-harvest management practices, it will get lost as such. Or even if we are in a position to take it to the consumer's table, if this handling, processing, storage, transportation, if we don't follow those scientific principles, it may lose a significant proportion of nutrients in terms of micronutrients, these vitamins, minerals, etc. So that may be another loss, even if it reaches the consumer's table. So first thing is that we have to go for scientific post-harvest management practices. Of course, in recent past or recent couple of decades, we have seen cold chain has that's being used for transportation of these fruits and vegetables, but still we have to go a long way to prevent the losses or to maintain the freshness of our fruits and vegetables. Then another way is preservation and processing into different value-added products. That's commercially important products. We transform it into value-added products, which I don't feel this is appropriate time to discuss all those things, because most of the participants, most of our scholars, they are well versed with all these types of technologies. But as regards the selection of those suitable cultivars or suitable varieties of fruits and vegetables, we have seen, being from a temperate region, I would like to substantiate my statement. I would like to make my statement understandable by quoting few examples. Say selection of suitable varieties. If we take example of apple, you will see many varieties which don't have longer post-harvest life. You find that they loosen their texture. It becomes loose within a short span of time. Contrary to this, there are some other varieties which retain their textural attributes after harvest for prolonged periods of time. So here I think the role of biotechnologists they can play a vital role to evolve such varieties which last longer. Say a few scientific principles which I would like to point out here, like the enzyme activities, pectin degrading enzymes, or different types of those pectin degrading enzymes, pectin methyl esterase, polyglycerases, or pectin lyases. These are few important enzymes which belong to pectinases. If their activities are manipulated, we can retain the textural attributes for prolonged periods of time, as we do have some varieties of apple which retain these textural attributes for prolonged periods of time. So biotechnologists can play a role in transferring those genes which suppress the activities of certain enzymes, and suppression of those enzyme activities can result in prolonged post-harvest life or prolonged storage life. Similarly, another important phenomena in post-harvest physiology of fruits and vegetables is biosynthesis, as has been done in case of some other fruits like tomato, etc. Same, these principles can be used to prolong the post-harvest life or the storage life of these fruits, like apple is there, tomato is there, or banana, etc. is there. Since we belong to this region where apple is the commercial crop, that's why I'm giving the example of apple only. What are the scientific principles which we can make use of to prolong the post-harvest life of these fruits or vegetables. Then proper harvesting. There are different types of those, harvesting techniques. But again, say, if we don't adopt proper or scientific harvesting techniques, a small bruise, a small cut on the surface of apple or such types of fruits, it hastens its ripening process. It drastically reduces its post-harvest life, because even if it doesn't result, that bruise or that cut, even if it doesn't result in rots by those microbes, but it triggers that respiration. It results in increased respiration, as a result of which the post-harvest life of fruit or vegetable, it gets decreased. So as I told you that the topic of my presentation is Himalayan vegetables. What are the problems and prospects of Himalayan vegetable processing? Because the problems which this Himalayan belt of the country, which it faces, those problems are different from the problems which vegetable producers or vegetable traders in rest of the country they face. So the problems of this Himalayan range from northeast to Jammu and Kashmir, they are different. Of course, we do have some common advantages also in the Himalayan belt, but we have many disadvantages which are common to us and which are different from those of the rest of the country. So one of the important preservation techniques of these vegetables is the traditional fermentation. Those of you who have visited Himalayas or who are familiar with the culture of Himalayas, one of the important ways to preserve these vegetables is natural fermentation. But this natural fermentation, we adopt some conventional or traditional techniques. Those techniques result in poor quality product. Those techniques result in non-uniform quality of the product, as a result of which we are not in a position to commercialize, to upgrade, to upscale this technology. The natural fermentation, say, this natural fermentation results in production of those fermented vegetables, what we call in common language, we call them as pickles or achar, we say. The pickle which is produced throughout the country, it's not naturally fermented. Most of the pickle that's marketed in our markets all over the country, it's artificially acidified pickle. It's not naturally fermented. And similarly, India has an important place in the export of pickles also. Probably the #1 exporter of pickle in the world. India is the #1 exporter of pickle. But again, this a very small percentage of that pickle is produced by natural fermentation, whereas the major quantum of that pickle is produced through artificial acidification. So pickling is a global culinary art. The word pickle has originated from Dutch word pekkel that was used to refer to a solution of brine, often spiced for preserving and flavoring foods. So this pickling is one of the important vegetable preservation techniques of Himalayas. But again, the major problem of this, which I would like to again emphasize, that the technology is very traditional. It doesn't result in uniform quality product. It doesn't result in a product which is worth marketing. So the research activities which we conduct here, we will be giving a brief of those research activities and what we have achieved so far in upscaling, in upgrading, in refining this technology so that these Himalayan vegetable products, which are fermented products, they get commercialized so that we can produce products which are worth marketing. So in Indian subcontinent, especially in Himalayas and adjacent belts, pickle is popularly known as achar, as I told you in a while back, and generally no meal is complete without a pickle. It's assumed that owing to the rough terrain and practically unapproachable locales common to the entire Himalayas region may have been the common driving force behind the development out of this pickling, because as I told you, transportation facilities are very poor in extremes of these Himalayas, though we do have bumper production of these vegetables, particularly some specific categories of vegetables which we grow in Himalayas. We refer them as coal crops. So bumper crops are produced in many regions of the Himalayas, but because of the poor transportation, poor marketing facilities, there is no other option but to say process them. And one of the important, as I told you, important techniques, important ways to process these vegetables is for converting into these fermented products. So these figures give you an idea about the traditional or conventional techniques of these vegetable fermentations. So what is in this part of Himalayas? Of course, you will find right from northeast, different types of vegetables under different names like gundruk. It's produced in northeast. Here we call it as achar in this region of the Himalayas in Jammu and Kashmir. You just see these earthen pots. We fill it after salting, etc. We fill it in these earthen pots and then we let it ferment naturally. But you just see at the bottom, these earthen pots, they result in, once osmosis takes place inside this pot and this solution which contains nutrients, it oozes out from these earthen pots and results in fungal growth at the bottom. Generally, these Rhizopus and Penicillia we have identified. These molds, they grow. And then this is the pickle which is traditionally produced. Again, it faces, in addition this mold growth, we see that softening takes place because of these enzyme activities, etc. And again, this is the cabbage which we have packed in this earthen pot. And then we have used some little bit, we have tried to refine the technology. In the beginning, we tried to use these anaerobic jars to ferment, and this gave us some ideas how to refine this technology. So the major problems, as I told you, this conventional technique of fermenting these vegetables is when we use these earthen pots, there is frequent growth of these molds. Then there is softening of the raw material, softening of the vegetables. It takes place because of many types of those enzyme activities. And then once this fermentation continues, it results in gas production. And there is a spillage of oil and other fluids which are formed inside these containers. They come out from these containers from the top, they ooze out. And your product, if you say pack in bottles, it's not, you cannot display in on the shelves of retailers. So another technology which generally are that's commonly used in Himalayas is drying. I'll show you what are the conventional or traditional techniques of dehydration of these vegetables. Again, that dehydration is exposed to environmental contamination and we don't get a uniform product. You have to depend on the atmospheric temperatures, or of course we can use dryers also. But again, those dryers, we have to use very high temperatures. High temperatures may result in loss of nutrition. And also, they also take, compared to sun drying or solar drying, you may be in a position to reduce the time. But again, it takes, say, a lot of time, and temperatures too, or high temperatures are to be used for dehydration of these vegetables. So what we have thought how to proceed ahead to tackle these problems of fermentation and problems which we face in dehydration of these vegetables. Say, provide a hygiene and scientific basis for traditional product development, keeping in view the nutritional, microbiological, and sensory characteristics of the final product. So this was our goal. Before planning our experiments, this was in our mind, how to produce a product which is more hygienic, more acceptable to the consumer, which is wherein we can get a uniform quality of the product. And so it was translated into design of suitable equipments for processing and production. This basic principle was translated into designing a suitable equipment for processing and production, evaluating different processing techniques to aid in production. Then well-organized sector for production and marketing of traditionally produced products, so that this can find these products which we produce, which we generate through refinement of this technology, so that this was our ultimate goal. Well-organized sector for production and marketing of traditionally, these fermented vegetables are traditionally dehydrated vegetables. So this slide, it sums up the problems: lack of proper post-harvest management and processing facilities in J&K, a huge amount of produce is lost. The Department of Food Science and Technology at our university has a mandate to cater technological needs and requirements of the people of the region. We aim for refinement of this technology, traditional technology, fermentation technology, dehydration technology, that we are trying to refine, and finally to bridge the technological gaps and to mechanize the production process for better quality control and marketing. 2 prototypes. In order to refine the technology, this department has developed 2 prototypes, which I am going to share with you. So this is one prototype which we have developed. It's a solid state fermenter for vegetables. As I told you, we don't get a uniform quality product. Himalayas, as I told you, that we do have a common, the whole Himalayas, we have certain advantages compared to other parts of the country. That major advantage in this Himalayan vegetable processing is that the months of October and November, these are the most suitable months, or this is the most suitable period for fermentation of vegetables, because it's during this period that temperatures range between, say, 13 to 18 or 19 degrees centigrade. So this is the most suitable temperature for lactic acid fermentation of vegetables or pickling of these vegetables. And these October and November, it's followed by severe winters, that is December, January, and February. So you don't need refrigeration to preserve that. You just keep it at room temperature after getting a suitably fermented product, because as I told you, these 2 months are most suitable. You don't need any temperature control in this, because this temperature is most suitable for fermentation. Once we produce at room temperature even, then it's followed by severe winters. It can get preserved for 2-3 months, and then it can be consumed, or it can be marketed during these 2-3 months. But this temperature, lasts only for limited period of time, only for October and November, followed by severe winters. And from March onwards, again, you see that temperatures start picking up in Himalayas. We can produce fermented vegetables during rest of the period also. In remaining part of the year, we can produce these fermented vegetables. But the question is, the fermentation will be brisk. There will be excessive acid production. And as I told you, one of the common problems, there is spillage of oil. Once we ferment that pickle on the shelves of those retailers, it comes, the oozing continues from the mouth of those jars. Oozing starts, and retailers are not in a position to display it properly. And along with that oozing out or spillage of those fluids or liquids, you see that this fermentation continues. Excessive acid production is there. So this is the major problem of these Himalayas. So keeping that thing into consideration, we designed this fermentation where we can have a temperature control, we can have pH monitoring or acidity monitoring. So these are two basic things which we have incorporated in a solid state fermenter, wherein we have incorporated a chiller also that keeps this cool during extreme high temperatures, and then we have temperature control for maintaining a suitable temperature that is between 14 to 18 degrees centigrade. This has a chiller, and then for heating also we have arrangements for both these heating as well as cooling, so that temperatures remain in this range. And then we can tilt this. We can, because there's a need.
What happened? Hello.
So his second video is there.
Acha, acha.
So you change to the another video.
Upgradation of this technology. As you see, this is the fermenter that we have designed. Here we have the provision for temperature control. We let heating medium to circulate through this double jacket, so that it maintains the temperature. And then we have a chiller attached to it. And whenever we feel the need that temperatures are going too high, we can just switch on the chiller, so that it can bring the temperatures down and keep it within the range of, say, 14 to 18 degrees centigrade, which is the most suitable for lactic acid fermentation. And in addition to that, this has a provision of getting tilted. This fermenter, it has a provision of getting tilted, so that mixing also takes place without unloading the fermenter. When the product is still loaded, we can just tilt it and get the product inside it, remix it, or we can just remix it many times during fermentation process. And this has the advantage, this step has the advantage, if we don't mix it, we may have to unload it and then mix it. If we don't mix it regularly, that there are apprehensions of mold growth at the top of this surface. The product which is at the surface, which is at the top, that may get mold growth. So this is one advantage, or this, you can say, it's an upgradation of the traditional technology. And then we have, as I told you, chiller and heating medium arrangements are there. So this is one step for upgradation of this technology. So this is here, you can see our external view of this mixer, this fermenter. It can get tilted, and we can just unload the product here, and then fill it in those smaller units or bottles, etc. So this is the chiller which is attached to it. When this is the temperature controller here. Whenever we feel need to, we can switch on this chiller. And in addition to this, we have another device which is just for before we load the material, before we load the feed into this fermenter, we have designed a mixer. It's a very simple device. It's not anything new or advanced technology. So this slide gives you an idea, the type of product we get. So these are, as I told you, Himalayan vegetables, commonly cultivated vegetables, which we generally use for this fermentation purpose. This is the
say mixer, you can say. This is the final product. This is the feed inside this fermenter, the vegetables inside the fermenter. Here we can easily this is mixer basically. This is mixer and this is fermenter. This once we mix it here, we load it here, and then we can also mix it here during fermentation. This mixer is just for proper uniform distribution of these ingredients, etc. This is the transfer of to fermenter. The fermenter mix from mixer to fermenter. This is the fermenter and this is the end product which we get. So these are the advantages which this fermenter gives us. One is temperature control, normally which you don't have in this traditionally fermented. You can use this type of fermenter around the year. Whereas in traditional technology, as I told you, it's only the month of October and November when you can get suitable temperatures. But in this fermenter, you can get this suitable temperature, or you can go for production around the year. Then pH monitoring is there. Normally in this traditional technology, you can't say when there is adequate fermentation, when the product has achieved the adequate acidity or pH, you cannot make anything from that. But here you have a pH monitor, which you can give, which we can get an idea of the acidity. Then continuous mixing, as I told you, without unloading, you can mix it when it is still fermenting within the fermenter. Then easy loading and unloading is very easy. Then better textile attributes of the product we get, and then reduced fermentation time. These are some of the advantages over traditional technology, which we have achieved by designing this fermenter. So these are some of the basic, before designing this fermenter, we use these anaerobic jars, which are already available in the market. We use these anaerobic jars for fermentation of these vegetables. Then, as I told you, another common traditional technology of vegetable preservation is the dehydration. The sun drying, it exposes your product to environmental contamination, and you are dependent on the weather conditions of the region. And again, you don't get a uniform type of product. Then, of course, dryers, traditional dryers or conventional dryers are very much in use in the country. But again, you have to use very high temperatures, and the time of dehydration or removing that required quantum of moisture from the product is very large. So it takes a lot of time. So we have combined here these things. One is microwave technology. We have used microwave technology plus vacuum. This is probably for the first time, or few devices which have been prepared so far. So here we use these two devices. One is vacuum and another is this microwave dehydration. Here again, the biggest advantage is that we drastically reduce the temperature at which we dry because of vacuum, and then vacuum dehydration or vacuum heating, microwave heating, it results in uniform heating of the product. You don't just get variation in the quality of the product. So we have initially designed a microwave dehydrator with 6 trays. There are 6 trays in the chamber. That chamber is subjected to vacuum, and then there are 6 magnetrons are fixed in those, and like other conventional microwave dryers, those trays are rotating. So this is the chamber which you see. This is the extent or sketch of that chamber. So as I told you, this is the conventional way of dehydration of vegetables, just through ropes or on the rooftops, hanging from the ceilings. This is the bottle board. This is the tomato. These are conventional or traditional technologies. And you just see polyphenolic oxidation is there. You just see it results in browning of the product, and then it's exposed to environmental contamination, chemical contaminants and microbial contamination, etc. So you get a low quality, inferior quality product if you use conventional dehydration. Even those dehydrators, conventional dehydrators, which are electrically operated, again, you have to use very high temperatures, which result in loss of nutrition. This is the microwave assisted vacuum dryer. Here it's this trap. This traps the moisture here. Again, this creation of vacuum is still, we have not achieved complete that success in this, because sometimes this moisture, some quantity of moisture remains inside, and we are continuously trying to further upgrade this technology. So this is the external view of this vacuum dehydrator. Microwave assisted vacuum dehydrator. And then this is the internal view. You can see these 6 trays are loaded with the product, and then there are 6 magnetrons are fixed adjoining to these trays, which emits these microwave radiations. You just see different types of products. Tomato is there, banana is there, bottle board is at the bottom. So this is the raw material. And then you can see what's the quality of product at very low temperatures with very less time compared to conventional dehydrators or solar dehydrators or simple drying. You just see the tomato powder, how green this product is, this bottle gourd, and you just see the color of tomato, to what extent we have been in a position to retain this color. So for dehydration vacuum in combination with microwave, I think for vegetables and fruits, this is can be one of the potential technologies under our conditions, because fruits, vegetables are or among the important agricultural commodities of the country. You can see how successfully we have used this technology and what's the quality of this product there. Again, this is the advantage. I have summed up these advantages here: significant reduction in dehydration time, then superior quality of the dehydrated product, then high nutritional value and sensory qualities, no severe shrinkage is there, then prevention of oxidation due to absence of air under vacuum. We remove oxygen, and there is very limited oxidation in the product. So these are 2 technologies that we have upgraded to process Himalayan vegetables, so that we are in a position to maintain their quality and upgrade the traditional technology that we are using conventionally in this Himalayan belt. With these words, I thank all of you for giving me this chance to present my research findings here. Thank you very much.
Thank you, Professor Masuji, for such a wonderful lecture.